Hi, good morning, everyone.
Good morning.
Welcome to our Tier 5 rulemaking workshop number 2, amendments to off-road diesel and new engine regulations. This is the second day of our workshop, and the previous days, October 30th, has been recorded. Uh, and for anyone who had missed that, uh, soon it'll be available on CARB's YouTube website. Before we get started, uh, we'll first go over a few Zoom logistics. So for those who may need to step away from the computer and maybe would like to call and still be able to listen in, the phone number and access code are available on the screen now. For the question and answer sections later in the day, uh, in the Zoom interface, you could either use the raise hand feature, uh, and when we see your hand raised, we can ask you to unmute and you can ask your question. Or the popular method yesterday was to use the Q&A box feature in the Zoom interface. So you could type in your question, and during the Q&A phases, so after today's presentations, we can get to those. A third option is use it if you're using on the phone only, you can press #2 to raise your hand, and then we can ask you to unmute yourselves, and you can do so by pressing *6. Please state your name and affiliation before asking questions or making comments. Uh, Now I'd like to introduce Jenna, the manager of the Tier 5 regulation.
All right. Thanks, Christian, and good morning to everybody. Welcome back to day 2 of our extravaganza and happy Halloween. So, yeah, thank you for attending yesterday. For those of you who did, we had a great day 1 and lots of outstanding questions. And as I mentioned yesterday, our slides are all posted on our Tier 5 website. So you go to the meetings, and then on the right-hand side, there's a list of topics, including the agenda. So you can click on the agenda and find out if you want to look at it more, or if you want to look at a specific topic. Today, the first topic we're going to cover is useful life and warranty and defect reporting. So that's under useful life. You just click on it. I know folks had trouble finding that, so it's on the right-hand side. You do have to click on it to get the presentations. What we've been doing and what we'll continue to do today is have a question and answer period after each of the topics before we move on to the next topic. So that works really well. And then we'll have an open discussion at the end of the day. We'll take a lunch break in the middle of the day. What I was going to do is, since yesterday was such a heavy day, in terms of topics that we covered, if people have any questions that they thought of after you left the workshop and you wanted us to answer, we could take some of those right now. I see that there's 2 Q&A there now. So we can go over those. I think we
Um,
should just start with the one at 8:06.
yeah, so we have a question from Ashwin Ramesh. Will the Southwest Research Institute slides be made
Yeah, I can
uh,
take that one. Go
available to the
ahead.
public?
Yeah, those will if you can send us an email, because since they're not carb slides, and we have different, certain standards for posting stuff on our website. We'd like to hear, you know, send us an email to our Tier 5 email. It's tier5@arb.ca.gov to get a copy of those slides, and we'll email them to you.
Thank you, Jenna.
Hmm.
Our next question comes from Kathy Edwards. I didn't attend yesterday. Are we covering different material today?
I can take that one. Yeah, we're covering different material today. It was a 2-day workshop. So yesterday we covered the implementation schedule, the standards, some certification amendments, as well as, let's see, SCR inducements. We covered, oh yeah, am I getting that correct? Anyhow, we covered the off-road in-use testing program yesterday as well. So yes, there's all different topics today from yesterday, but don't worry if you missed yesterday's. We've been recording the meeting, and we'll post that on our website, and then all the slides from today and yesterday are on our webpage.
Okay, thank you. We have a question from Steve Berry from EMA on the in-use testing slides on slide number 38. You have proposed a screening criteria, one, average of bin emissions using a threshold that includes a conformity factor of 1.5. A conformity factor of anything more than 1.5 per PEMS testing will make the screening bin thresholds more stringent than the PEMS-based thresholds, assuming accuracy allowances for NOx sensors are applied with the same logic as those for the PEMS accuracy allowance. And looking beyond 2036, could you please comment?
Yi, would you like to take that question? Or Christian? Maybe we can put up the slide from yesterday.
Okay. One second, let me get the slide open.
Is this the question from David Youngren
I think it was from Steve Berry.
that we're
Yes.
oh, okay. I'm sorry,
Yeah.
I'm jumping ahead.
I mean, we can, while you're getting that open, I can answer, I can go to the next one. What are the next steps / milestones in the regulatory process until June 2025? So what we're going to be working on, Steph will be working on the SORIA, which is the cost impact report, and looking at costs, as well as working on regulatory language, and then the statement of reason. So we'll be working on those things, and then if folks have questions or would like to meet with us, then we can do that as well. But we're really focused on those things. And then the rest.
I can comment a little bit on Steve Berry's question.
Okay.
Yeah, so on the slide here, we have two criterias for the screening method that uses the NOx sensor data. It doesn't show how we'll include possibly NOx sensor accuracy margin on this slide, but that's something we will take into consideration. We don't want this screening to be any more stringent than uh, the PEMS testing method. I think the comment is because yesterday we wanted to receive comment for the conformity factor on the PEMS side. And so if that number was greater than 1.5, criterion number one here would be more stringent. But well, as the proposal progresses and we have more information on what the accuracy margins that we might apply to be, we'll keep track of it so it doesn't get out of balance. But the final accuracy margin for NOx sensors, we have a contract with Southwest investigating that topic, so we don't have the final number on that one yet.
Thanks, Christian. I think we can go to the question by David Youngren at 808.
Sure, I'll take that one, Jenna. Yeah, Sharp Eye. Actually, let me pull up that presentation so I can show what we're all talking about. Okay. When I presented yesterday, I said that we weren't going to include the capping standards as part of the Tier 5 interim provisions, and that is correct. However, there was this slide. It's a backup slide, so I was kind of surprised that it actually got posted. But in the backup slide, it clearly indicates N2O and CH4 capping standards during the interim periods. And that's an error. That's something we'll correct in an errata after the workshop. But yeah, thanks for pointing that out.
David Youngren at 809 asks about, he's asking about the implementation schedule and plans that we have.
That may be what I just explained.
Oh, okay.
Yeah,
Sorry.
I think so. He was just clarifying that.
Okay. Our next question is, can you talk about how these regulations will apply to affected businesses in California with heavy duty fleets?
I can take that one. Yeah, so this regulation is an engine manufacturer regulation, and so we're setting new standards for for off-road heavy-duty engines. So it applies to them in terms of of course. We understand that there will be costs associated not only to engine manufacturers but also to the businesses who buy the equipment. Um, but this isn't a mandate for that, a sales mandate for that equipment. So the reg with respect to it's called the heavy duty, or it's the off-road in use fleet regulation. That's a separate regulation, and then businesses fall under that regulation.
Maybe I could just chime in. So yeah, Tier 5 is an engine standard, so it directly applies to engine manufacturers. It's requirements that they need to meet in order to legally sell new diesel engines in California. And so the way this reg would affect other folks that use off-road equipment is just when you buy something, once this reg is in effect, that equipment would be cleaner and potentially might be a little more expensive to offset the cost that manufacturers are spending to meet this regulation.
Thank you. Thanks, Kim and Jana. Our next question comes from Steve Derry on slide 44 of the in-use testing slides. So I'll share that slide. Okay, the question is, you clarified that the term standard was correctly applied. Please confirm that this means the bin standard. So after multiplying by the conformity factor, and would this be not yet proposed PEMS conformity factor or one of two screening criteria conformity factors? Um, uh, so I believe the second one, 10 times higher than the standard. Steve is asking, what do we mean by the standard? So I'll go back a few slides to 39. So here are the equations for the final threshold. Here we have a conformity factor times the standard plus sensor accuracy. And I believe the question is asking, Steve is asking if the standard that we mentioned on slide 44 includes the conformity factor. And I believe the intention of the slides is the standard mentioned on 44 is just, for example, either the idle standard or this screening bin, which is the low load cycle standard, or the NRT cycle at 0.04 grams per kilowatt hour. So the standard that we mentioned there, we're talking about the cycle standards. We're not talking about the conformity factors applied to them and then multiplied by 10. Okay. The next question is from Daniel Langmaid. Uh, Not sure if it was answered yesterday, but one, if EPA does not adopt the Tier 5 standards for engines below 174 horsepower, does that mean CARB doesn't have authority to implement Tier 5 requirements for those engines? And two, if CARB wants DPFs on off-road engines, why not just require that versus hoping it'll happen? I believe Jenna would like to
I can
respond.
take that one, sure. Yeah, we did answer this one yesterday, and yeah, so there's some engine or equipment types that CARB does have authority for less than 175. However, the majority are by EPA. So we are setting standards for those power categories, and then the plan is that eventually EPA will be able to catch up and implement their own Tier 5 requirements. So, and then for number two, why not just require DPFs? And I think we did answer this one yesterday. And so we're setting standards based on our knowledge and expertise, such that we know that for the standards that we set, that will require certain technologies.
Jenna.
Well, and maybe I can add too, we generally, so there, when you're working on a regulation, you can take sort of a command and control approach and say like you must use this certain technology, or you can set a performance standard and say, the mass emissions have to be no more than this much. We tend to prefer the latter approach because we want to give manufacturers the ability to, maybe find a better, more cost-effective way to meet the same standard. So that's why generally we set performance standards rather than just saying use technology X or technology Y.
Thank you, Kim. Thank you, Jenna. Our next question comes from Robert Schober. I was wondering if you could share the link that shows the CARB regulations do not apply for diesel forklifts that EPA regulations apply instead. Thank you.
I believe Kim answered this one yesterday. If you want to repeat your answer, Kim.
Okay. Am I off mute? I'm
Yeah,
stuck
you're
on
up here.
mute. I'm stuck on mute, which is why I'm sitting here silently, not replying. Okay, thank you for the question. Yeah. So as I described yesterday, so the Clean Air Act explicitly gives EPA authority for writing new engine standards for some equipment, and that's farm and construction equipment under 175 horsepower. So CARB still has the authority to regulate such equipment in use, but the new standards can only be written by EPA for that equipment, and that's referred to as being preempted. So historically, in order to sort out which equipment had engines that needed to be certified by CARB versus which ones could only be certified by US EPA, CARB has posted a couple lists that have been up there for decades, kind of laying out which equipment falls in preempted versus not preempted. And I can drop a link. I will drop a link into the chat here so folks can navigate their way to that to those lists. Thank you for the question.
Thank you, Kim. Our next question is, will there be any changes for emergency exemptions in the Tier 5 program?
I can take that, Christian. I don't think that there's going to be any changes. We're going to leave the current exemptions as is for Tier 4. So we don't have any plans to make changes.
Okay. Our next question is, the NOx interim standard for 1956 kilowatt is 3.7 grams per kilowatt hour. Should the NMHC plus NOx equal 3.7 grams per kilowatt hour instead of NOx only?
Thanks for the question. I'll take this one, Christian. The current standard is combined hydrocarbon and NOx. I think it's 4.7 grams per kilowatt hour. For the interim standard, we're separating the NOx from the HC. So the 3.7 does represent NOx only. Thank you.
Thanks, Jeff. Our next question is, does REAL apply to greater than 560 kilowatts?
I can take this one, Christian.
Okay.
So to answer the question for the off-road in-use testing program, REAL applies for the 56 to 560. In terms of REAL, I think I can't recall if REAL applies to greater than 560. I might have to defer to somebody from the OBD team to answer that, because my team focused on the off-road in-use testing.
Yeah, Jenna, this is Jason. In our presentation, which will occur in about an hour or two, we're going to explain a little bit how REAL will apply. So it's going to be dependent upon if an SCR is part of the emission control solution. So if a greater than 560 kilowatt engine has SCR, it would be required to output REAL.
Thanks, Jason.
We're going to go over a question earlier from Steve Berry regarding slide 38 in the in-use testing slides. You have proposed screening criteria 1, the average of bin emissions using a threshold that includes a conformity factor of 1.5. The conformity factor of anything more than 1.5 for the PEM side of testing will make the screening bin thresholds more stringent than the PEMS-based bin thresholds, assuming accuracy allowances for NOx sensors are applied with the same logic as those for the PEMS accuracy allowances, and looking beyond 2036. You're right, we don't have so the final numbers for what the PEMS, for the sensor screening accuracy margin is, we don't have those yet. We currently have a contract with Southwest. So the final value for the threshold for the PEMS and the NOx calculations, currently right now it's not known which one is stringent. You know, there's some variables to play with, as you mentioned, that conformity factor on the PEM side, as well as the NOx sensor accuracy margin. We will be looking at those as things develop and we get more information from our contract at Southwest. I believe now the intention is not to have the NOx sensor screening program more stringent than PEMS, but we'll be tracking that. I hope that answers or addresses your question, Steve.
I believe he said wrong question, the next one.
There was 2 right after it?
The one at 808.
Oh, 808?
Slide 39, yeah.
808. Sorry, slide 39. Yesterday, you clarified the intent behind the interim NOx margin through 2036. Was it to give additional leeway to manufacturers to comply in the early years? Why don't we see this NOx compliance margin also applied to the off-road screening limits that are precursors to PEMS testing? So the first part of your question is yes, the interim margin is applied to through 2036 to give additional leeway to manufacturers for the compliance testing, and that is especially most important that we provide it on the PEM side of testing, because the PEMS testing actually has a final compliance determination. Currently, we don't have an interim margin on the NOx sensor side, but that is something that we could possibly look into. But the consequences, or at least the recall or corrective action consequences in the sensors program is less detrimental than the PEMS program. But we can look at that later. Sorry, I misread, and I read one of your other questions twice. Our next question is, in the current engines below 56 kilowatt, which uses a DOC only after treatment and complies with Tier 4, does CARB expect interim regulations will drive the application of a DPF in this example? I believe Jenna wanted to answer.
Yeah, the interim standard is an interim to get us to in order to give manufacturers time to meet the final standard. So in some cases, some of the engines already have the technologies to meet that 0.22 standard. In other cases, they may not have those technologies as part of their design. So it's hard to answer that question. But I guess I could say that for engines that were designed and already have the DPF and the SCR, well, then they would more easily meet the 0.22 standard.
Thank you, Jenna. Our next question comes from Michael Stetzel. For your information, the webinar chat is disabled on my end. If you post things there, I won't see it. The webinar Q&A works. Yes, Michael, the Q&A is enabled for our workshop here today. So any interaction will be solely through the Q&A feature.
I think he wrote something else, and he says, "Never mind, I saw the link was posted."
Oh,
so
sorry, I didn't see the.
I didn't see it either. It's at the very end.
Thank you. Our next question is, since the rule sets new, more stringent emission standards, does it offer sales phase out timelines for engines in California?
I can take that question. No, it does not offer sales timelines. This is for engine manufacturers to sell diesel engines. So I'd have to point you to the in-use off-road fleet reg, and that has different timelines.
Thank you, Jenna. Our next question is follow-up question. If an engine greater than 560 kilowatts meets emission standards with only a DPF, does REAL apply to that? I don't know if we have an OBD team member who would like to speak to it. I think Paul would like to respond.
Yeah, I can take that one. So I think the question means essentially that there's no SCR present, if I'm reading that right. And so if that's the case, then REAL would not apply. So it's only SCR equipped with NOx sensors, and that's kind of the kind of basis. But we'll talk more about that in the OBD presentation too.
Thank you, Paul. Our next question comes from Colin Winslet. Would you consider giving an incentive for manufacturers of less than 175 horsepower ag and construction machines to meet Tier 5, even if it's not mandated from them?
Yeah, I guess I could. This is the question from Colin.
Yes.
Okay. Again, typically, farm and construction less than 175 has been exempt from California's control. But again, this is kind of a new area since we're talking about credits and incentives. So It's something that we're considering our options with. We've been talking to legal about it. Other than that, I can't really give a firm answer at this time.
Thank you, Jeff. Our next question comes from Louis Nakuka. In real emissions reporting, is there any exclusion for low volume? And I think you would like to answer that.
We don't have any have the exclusion for low volume for the when the official program starts. But during the pilot program, we are not looking for data from small volume manufacturers.
Thank you, Yi. Let me check if there's any raised hands. No, we don't have any new questions in our Q&A section. Should we go to our first presentation for today? Jenna?
I think actually, I was just reading a chat.
James?
I think there may be a clarification, Jeff, if you want to take that one.
Sure. I don't see the question. Let me see if I can find it in the answered section here, real quick. Anyway, I don't see it. I don't want to wait.
I think the question was, since this rule sets more stringent emission standards, does it offer a sales phase out timeline for engine sales in California?
Okay. Thanks, Jenna. Appreciate that. So, we did describe the phase in, which is either a 3 or a 4 year period for the interim engines. That would be one way to answer this. Other than that, if you have more engines, if you produce more engines, but you haven't had an opportunity to sell them yet, for whatever reason, the economy is down, you still have a number of surplus engines. The regulations already allow you to continue selling those engines, even though there may be a standard change. The only caveat with that is that you can't intentionally, increase production the year before a standard change to try and circumvent it for as long as possible by having these surplus engines that you could continue selling into the next model year. But other than that, the current regulations do address this already.
Thanks, Jeff.
Mm-hmm.
One thing that we could do, I don't know if, I think you're back, right? You already answered a question, so I know you are. We had a couple of corrections from yesterday. Of course, we're going to post an errata for some of the for all the changes that we made to the slides. But maybe sorry to ask you this on the fly, but maybe you can go over the couple slides that you had changes to yesterday.
Sure, I can go over that. Sorry that I was out
That's okay.
for a moment, so
no
I
worries.
was not able to answer the questions. Should I share my screen?
Yes, that would be great.
Okay, let me do that. All right, so can you see my screen okay now?
Yes.
Yes.
Okay, so yesterday when I was reading this slide, we noticed that there is a typo in the slide. So I highlighted the change here. In this one, it's the special case for NOx and PM screening. If a significantly high number of flagged engines for an engine family are observed, the manufacturer would begin discussions with the executive officer to investigate the cause. This would be triggered if 80% or greater of reported engines failed the screening for an engine family. So please check our revisions as needed. And I hope this can clarify the confusion we had yesterday.
Yeah, I think what we'll do, Yi, is we'll put all the revisions to all the decks that we need to in one errata. So they won't have to check the existing slides, but rather we'll post something separate for any changes that we have.
Yeah, but for right now, I hope the revision is clear for people to see. Yeah, and I also want to emphasize, I think there was a question when I was away about the second bullet point. I want to emphasize it's the standard, not the threshold in the in this bullet point.
Okay,
And
thanks.
yeah, so and for this slide 48, this is for PAMS testing. So there's no 50-hour stored array or the lifetime array. I delete this language will be deleted in the errata. And I think that's all we have.
Okay, great. All right. Well, with that, I think we can, I don't see any more comments in the Q&A, but don't worry if you have others, we'll answer them later on. So why don't we move on to the first presentation, which is the useful life. Thanks, Shun.
All right. Do you see it?
Yes, we see it.
Yes.
Yeah, great. So thanks. My name is Shun Nakawa. I'm a air resources engineer working on Magena. So today I'll talk about useful life proposal, warranty proposal, and defect investigation reporting and corrective action proposal. And most of these slides are a repeat of what we presented in June 27th work group. There are a few there are some new information as well, but most of slides are repeat and included for completeness. So here's a background on useful life. Manufacturers must certify that their engines would comply with applicable emission standards throughout the useful life. And the useful life of off-road engines for greater than 37 kilowatt is 8,000 hours or 10 years, whichever comes first. In the November 2021 workshop, we asked for feedback for potentially lengthening useful life to 12,000 hours, and we received various feedbacks. For example, low usage equipment, especially seasonal agriculture usage, would not reach useful life hour limit, at least within a reasonable number of years. And equipment life can be shorter than engine's life. So in this case, if the engine's life is not the limiting factor of equipment life, then longer life engine doesn't have much benefit. And longer useful life exacerbates the after treatment system packaging challenge because longer useful life tend to require more catalyst. So larger amount of catalyst can create packaging challenge. So here's our analysis of useful life. The new data from our contractor showed that the average life of engines in construction and agriculture sector is approximately 10,000 hours or 18 years, which means in 10 years, average equipment only reaches about 5,600 hours, whereas the useful life is 8,000 hours. Which means in 15 years, if you think about 15 years, average equipment would fully utilize 8,000 hour useful life. Therefore, we propose to maintain the current useful life hour limits, but extend the year limits by about 50%. So regarding emission warranty background, manufacturers shall warrant to the purchaser that the engine is free from defects which cause the failure of a warranted part to be identical in all material respects to the part as described in the engine manufacturer's application for certification. And manufacturers are required to track information on possible defects and submit reports to CARB staff. And in our analysis of warranty, in our analysis available data, we found that most of off-road equipment reached the year limit of warranty periods before reaching the hour limit. Also, recent surveys to engine manufacturers conducted by our contractor 44 Energy suggested that the cost impact of lengthening only the year limits in useful life and warranty would be relatively small. For example, average incremental costs per engine would be approximately $401 for 56 to 130 kilowatt range. The final report of the project will be made available after completion of the project. Therefore, our proposal is to keep the hours the same, but lengthen the years by about 50% for both useful life and warranty for all power categories. And last but not least, first-time off-road onboard diagnostics or onboard monitoring requirement would encourage more owners to fix malfunctioning parts within the warranty period. So this slide summarizes the current useful life and warranty period, and as well as Tier 5 proposal. So again, there is no change in the hour limits, and the number of years are increased by 50% and rounded up to the nearest integer. Useful life would also apply to CARB's in-use compliance testing and manufacturer around in-use testing. So we are proposing these amendments to maintenance interval, and these are new, not included in the June work group presentation. So the current provision allows for the truncation of manufacturer's warranty liability after the first scheduled replacement of an emission-related component. Therefore, some emission-related components have minimum allowance maintenance intervals that are shorter than the warranty periods of the engines. For example, positive crankcase ventilation valves. So this means that some components' warranty periods are effectively shorter than the ones I presented in the previous slide. So we plan to revise this allowance and require that all emission-related components listed here remain covered throughout the full warranty period, regardless of their minimum allowable maintenance interval. And on a related note, EGR coolers is one of the components that have the shorter maintenance interval. And EGR coolers are critical components for controlling NOx emissions. And our available data show that the replacement frequency for EGR coolers in off-road construction equipment are approximately 4,500 hours. Therefore, we propose revising the minimum maintenance interval for EGR coolers from 1,500 hours to 3,000 hours, and for 4,500 hours for less than 130 kilowatt and greater than 130 kilowatt, respectively. This aligns EGR cooler with the rest of the EGR system, except filters. So here's the background of the three-step process of investigation, reporting, and corrective action requirements. So the first step is defect investigation. So if on-screen warranty claims suggest an issue with the emission-related components, manufacturer must investigate for defects. And then if the investigation shows that emission-related component is defective, manufacturer must submit the defect report. And then finally, if the failure rates exceed 4% of 50 units, manufacturer must conduct corrective action. And our current policy allows manufacturers to issue extended warranty instead of recalls for certain components. And then here we plan to clarify what certain components are in Tier 5. So Tier 5 corrective action proposal would codify the current policy by identifying which components would be subject to recall or lengthened warranty. Recall would be required for failures of exhaust after treatment devices, onboard computers or systems, urea dosers, and hydrocarbon injectors. And lengthen warranty to full useful life for other components. But we still think executive officers should retain the flexibility to determine whether a recall is necessary, consistent with the current practice. Okay, so this summarizes the defect investigation reporting corrective action thresholds. Now, as you can see, there are different thresholds for investigation, defect reporting, corrective action, and then also thresholds are different for less than 560 kilowatt and greater than 560 kilowatt. And as you can see, these thresholds are defined in terms of the absolute number, like 50, or percentage, like 10% here. Whichever is greater. I know this can be a little confusing, but the bottom line is that the small number generally apply to small sales engine family. So, for example, let's say there's a let's say there's a engine family with sales number 100, and then if you think about investigation threshold less than 560 kilowatt, if the sales number is 100, then 10% of 100 is 10, of course. So 50 or 10%, whichever is greater, means 50. So in that case, the investigation has to start when the number of unscreened defect hit 50. And again, this threshold is defined in nationwide, nationwide number, nationwide number and then unscreened defect. And then the next step is defect reporting. Again, this is defined in terms of nationwide number and then screened defect. And then the last step is corrective action. This is defined in California number and screened defect. Sorry. Excuse me. So these are the current threshold, and then in Tier 5 proposal, we plan to lower the absolute number threshold that applies to smaller sales engine family. And then this slide summarizes our thinking. So since Tier 5 is likely to be initially, at least initially, California-only program, the investigation thresholds need to be lowered to reflect the lower sales number to maintain the capability of identifying potential defects in most engine families. And corrective action thresholds with absolute number 50 needs to be lowered because our analysis suggested nearly half of engine families would be effectively exempted without lowering the threshold because, well, there's a lot of engine family with sales less than 50. The details of our analysis based on California sales numbers are not shown here to protect confidential business information. With that, this concludes this presentation.
Thank you, Shun. I think we had a couple questions. One, I'll just read them off. The first one is actually a question from the off-road and use testing, and it says, now that Yi's back, the in-use testing slide 44, can you clarify that the term standard was applied? I'm sorry, can you clarified that the term standard was correctly applied? Please confirm that this means bin standard. So after multiplying by conformity factor, this would be the not yet proposed PEMS conformity factor. or one of the two screening criteria conformity factors. And Yi indicated he would take this.
Yes, so for slide 44, it's still about the screening part. And we are using the standard. Basically, we are changing the conformity factor in the screening part to 10. That, for example, if it's bin C, that will be 10 times 0.04 grams per kilowatt hour. That gives you 0.4 grams per kilowatt hour plus sensor accuracy. If we use the in-use screening threshold as the basis, and if it's 10 times higher than the in-use screening threshold, that means you will also multiply the sensor accuracy margin by 10. Which is not reasonable. So that's why we are using 10 times higher than the standard in that slide. I hope that answered. Yeah.
Yeah. Would it be possible to pull up that slide? I think it's slide
Sure.
44.
Okay. Yeah. Let me share my screen again.
I think slide 38 that shows the equation might be helpful to answer this.
Yes, this is slide 44, and I think Steve is asking about the standard here. So it's 10 times higher than the standard, and then we can go back to slide 39. In this, this shows the NOx emission screening threshold. What we mean here, when that by 25% of 10 times higher than the standard is 10 times the applicable standard plus the sensor accuracy margin. And if we, this is what we mean. And just as I mentioned, for example, it's 25% of engines are emitting higher than 10 times 0.04 grams per kilowatt hour plus sensor accuracy margin for bin C, or 10 times the 0.06 grams per kilowatt hour plus sensor accuracy margin for bin B. If we use this original in-use screening threshold as the basis, if you times this by 10, that means it's the 1.5 times 0.04. That's times 10, multiplied by 10 plus 10 times the sensor accuracy margin. That is not what we expect. I hope that's clear.
Okay, thank you.
Thank you.
We can go on to the questions for Shun Stack.
Okay. Our first question for this presentation set comes from David Peck. Does CARB have any estimates on the cost of increasing emissions warranty for each power category that it affects? I believe Shun wanted to respond.
Yes, so we have a contractor, 44 Energy, so they survey the engine manufacturers and then estimated incremental cost, including warranty. So yes, we have information with the caveat that the survey was designed earlier, so a lot of programs elements have changed. So the numbers may not be directly applicable to what we are proposing, but we do have some information.
Thank you. Our next question comes from John Reich. On slide 12, is the model 2020 sales the appropriate data to use to adjust the numbers for defect reporting? Most sales were down that year due to the start of the pandemic. Were any other model years, for example, 2018, 2019, or 2022, considered and reviewed for this analysis? I believe Shun wanted to respond again.
Yeah, it is a good point. Well, we used the 20, that was the at the time we were performing the analysis. That was the latest information, and we well, there were some difference, but we thought that the general trend of the extremely low small the general trend of the extremely small size of the engine family was still consistent, but you're right, there might be some difference from the 28, for example, 2018, 19, or 22, but that's the best we could do at the point we were doing analysis.
Thank you. Our next question is, if CARB cannot regulate emissions for off-road equipment between 25 to 75 horsepower, can they regulate warranty on emission parts or other related things? Or are they all tied to this preemption?
Christian, I can take this one. Are you able to hear me?
Oh, yeah, we can hear you, Kim.
Okay. Yeah, so the warranty goes along with it's one of the parameters that's considered when new engine certification is issued. So a manufacturer has to offer the required warranty in order to sell the engine legally. And so for the engines that are preempted, they would be under the warranty requirements of US EPA, not CARB.
Oh, thank you, Kim. Our next question is, in the case where there's a recall situation occurring, is there any particular department in CARB we should report to? In other words, where should we report to?
Recall documents could be submitted to the field operations and warranty section along with defect reports. It's managed by Jeff Wong.
Thank you, Adil. Our next question comes from Will Barrett. Thank you for the presentations and conversations so far. Has staff conducted a total emissions estimate and health benefits analysis as part of the workshop? If not, when would that be available? Thank you. I believe Jenna wanted to respond.
Yeah, I can take that. Yeah, so the work for the health benefits as well as the cost estimate, that's currently ongoing right now, and it's not part of this workshop. However, at the end of today, we're going to have somebody from the inventory. Julie Schiffman will be discussing the changes to their inventory methodology, which then will help us reflect the NOx, actually all emission benefits. And I think the question was, when will we see that? I think that will be available, closer to posting to the board when we're closer to, I think we're going to the board in June 2025. So you'll see that, I think, sometime in early 2025.
Thank you, Jenna. Our next question comes from Adam Mezcampo. The extended warranty does not only affect the engine manufacturer. If DPF tank sensors and heated DEF lines are included in this requirement, 15 years of design life and 8 years of warranty will be costly for equipment OEMs and may be challenging to meet these components in particular. I believe Shun wanted to respond.
Yes, so so we have an estimate of cost from 44 Energy Survey. So regarding cost, we will consider our cost study. And then, yes, I understand 15 years or 8 years is long, but it only applies to very low usage equipment. So higher usage equipment will reach the hour limit first, so much sooner than 15 years or 8 years.
I'm not seeing any new questions in our Q&A section. We have a question from David Pike. Kim, you made a comment that the Tier 5 might increase the cost of an engine. Do you have any information that suggests there will be no engine cost increase or that the cost would decrease? Thanks. I think Kim would like to respond.
Yes. Yeah, you're right. Using the word might is maybe a bit of a euphemism. We do expect that these standards will increase the cost of an engine because we expect there'll need to be some improvements to the after treatment system. And as Jenna was referring to, we do look thoroughly at the cost and the benefit and sort of the cost effectiveness of various proposals before we decide exactly what rule design to propose. But yeah, just to be completely straightforward, yes, as previous emission standards have done, we expect this would have very significant health benefits, but also some associated cost increases.
Thank you, Kim.
Well, I don't see any more questions in the Q&A. So what I think we should do is go on to our next presenter. And then if you have any other questions on this topic, we can take them at the next break for questions. So I think next up is Muslim.
Yes. Can you see my slide?
We do.
Okay,
Yeah.
thank you. Good morning, good afternoon, and good evening. Muslim Mardi Tier 5 teams. I go over this presentation for selective catalytic reduction inducement and fleet rule clarification. So this presentation covers two topics: selective catalytic reduction, SCR inducement, and amendments to the in-use fleet rule 13 CCR 2449. I will cover the first portion of it, and the second portion is Mr. Jeff Lowry covering. So selective catalytic reduction or SCR inducement. This is the first topic. CARB staff aims to bring clarity and consistency to engine manufacturers and operators regarding the inducement provisions for new off-road compression ignition engines. The current SCR inducement specification for off-road engines can be found in the US EPA letter CD-14-10, dated May 12, 2014, and guidance from a collaborative public workshop conducted in July 2010 by US EPA and CARB. Our proposal involves incorporating this SCR inducement provision into the off-road diesel new engine regulation and California test procedure Part D. The staff proposal outlines the inducement requirement which would be applied to all new electronically controlled engines, regardless of their power categories, that utilize a selective catalytic reduction SCR system for model years starting from 2029 and beyond. The proposal includes inducement criteria for diesel exhaust fluid, depth level, depth quantity, and tampering. These criteria encourage operators to ensure the proper functioning of the SCR system. These requirements are specific to the SCR system. Other emission control system may undergo separate performance check. So in our Tier 5 proposal, staff is considering a comprehensive 4-element strategy to effectively address SCR-related issues. This strategy includes warning, initial inducement, severe inducement, and final inducement stages. In the warning stage, the driver will be alerted about the potential problem related to the SCR system. This serves as an early indication to prompt necessary action and prevent further complication. If the issue persists and remains unaddressed within a specified condition or time frame, the initial inducement stage comes into effect. During this stage, the engine's maximum available torque will be reduced according to the predefined level outlined in the table. This reduction is designed to create a noticeable impact on the engine's performance, serving as a strong incentive for the driver to promptly address the issue. In cases where the problem continues to persist despite the initial inducement, the severe inducement stage is implemented. Here, the engine's maximum torque reduction is intensified, further limiting the engine's performance. This stage aims to exert greater pressure on the driver to take immediate action and rectify the SCR system's problem. If all provision stages fail to bring about the necessary resolution, the final inducement stage is enacted. During this stage, the engine's maximum torque reduction reaches its maximum level, creating a significant impact on the engine's power output. Final inducement should provide enough advance warning to avoid unsafe condition and allow for diagnostic and restart after refill and mitigating the issue. Overall, this four-element strategy enables us to effectively address SCR-related issue while incentivizing drivers to promptly address and resolve any problems that may arise. On this slide, we are highlighting the key aspect of the general criteria for the SCR inducement proposal. And let's explore each point in greater details. First, self-healing. The system should possess the capability to automatically restart itself once the corrective action for the trigger event has been taken. This feature ensures that the system can recover and resume normal operation without external intervention. The next one is generic scan tool restriction, which means the use of generic scan tool to clear inducement is not allowed, which represent no changes to our existing policy. Instead, specific factory or dealership tools are required for this purpose. This requirement ensures that proper diagnostic and maintenance procedures are followed, maximizing the effectiveness of the system. Repeat offense. The system must be able to detect a repeat offense within 40 hours of engine operation after the final inducement activation. In the event of the repeat offense, the engine returns to the final inducement much more rapidly within 60 minutes instead of usual 4 hours, bypassing the standard sequence of inducement stages. A return to the final inducement would be initiated for depth level if empty tank condition occurs within the 40 hours repeat offense monitoring period. Safe harbor triggers. The final inducement is triggered when two of the following events occurs: refueling, parked idling, or engine restart. This mechanism is designed to ensure that the final inducement can be activated without posing any safety concern to the operator or the equipment. Practical example of how safe harbor condition can effectively minimize safety concern and mitigate risks are actions such as raising the drill from a hole, lowering the bucket, and safety maneuvering equipment off steep grades. Next item is freeze protection. Engine manufacturers should demonstrate that dosing can be achieved following the US EPA's prescribed limit of 70 minutes. Furthermore, engine manufacturers need to provide an attestation that DEF system can dose within a maximum of 40 minutes under typical California winter condition. The reductant must not refreeze during operation. And the last item, inducement engine derate fault code. Fault code associated with inducement or engine derates should be clearly displayed for the operator or easily accessible using a generic scan tool. This facilitates a straightforward identification and troubleshooting of inducement-related issue, enabling swift action and resolution. Overall, these criteria are designed to ensure proper operation of the SCR system, timely resolution of any issue that arise, and compliance with the relevant regulation. By adhering to these criteria, engine OEMs can provide reliable and effective SCR systems that meet emission standards and contribute to a cleaner and more sustainable environment. Now, on this slide, we are covering the difference between the existing US EPA non-road inducement program and CARB off-road inducement program. In terms of warning activation, US EPA requires either a warning lamp or an audible alarm, whereas CARB necessitates both. Regarding the repeat offense definition and consequences, US EPA characterizes it as a recurring offense, triggering a final inducement after 30 minutes. In contrast, CARB considers any second offense, whether it is the same or different as the initial one, and resulting in a final inducement after 60 minutes. For freeze protection, US EPA follows a prescribed method involving a cold soak at 0 degree Fahrenheit to freeze DEF, and a prescribed engine operation to thaw frozen DEF within a maximum of 70 minutes. CARB, however, relies on a manufacturer-provided data from US EPA tests and require an attestation that the DEF system can dose within a maximum of 40 minutes under typical California winter conditions. Here on these slides, we are summarizing the triggering event related to low DEF level and poor DEF quality. DEF levels are monitored by measuring the remaining DEF quantity in the tank, while DEF quality is assessed for its impact on the SCR efficiency, potentially leading to non-compliance. If DEF quality falls below certain levels, it can result in reduced SCR efficiency and consequently higher emission. Poor DEF quality can be detected through the urea quality sensor or NOx sensors. Engine manufacturers have raised concern about the current technology's capacity to effectively respond to concentration deviation in detecting non-compliance and the Tier 5 emission standard level. Therefore, staff has decided to maintain the non-compliance indicator for poor DEF quality as the Tier 4 final level. This slide presents a basic list of malfunctions that can be classified as tampering-related malfunctions, and staff acknowledges that creating a completely tamper-proof system is not achievable. However, engine manufacturers should thoroughly examine all aspects of SCR design that could be vulnerable to tampering and implement appropriate measures to reduce the risk of circumvention. And it brings me to the end of SCR presentation. And now, Jeff, please continue with the amendment to the in-use fleet rule. Thank you so much.
Thanks, Muslim.
Okay.
Please stick around so you can flip the slides for me.
Sure, go ahead.
Yeah, please go to the next slide. What we're doing here, we're actually opening up a different regulation, not the new off-road diesel engine regulations, but the in-use fleet rule regulations that most recently went to our board in 2022. And that would be Section 13 CCR 2449. This is an item that actually went with that rulemaking that was approved by the board when that rulemaking was taken to the board, but which was subsequently taken out during the 15-day modification process. The reason that this amendment was taken out at that time was because Tier 5 didn't exist. And what the amendment does is it kind of references future iterations of the standard and how they can be applied. in terms of adding equipment to the fleet. Yes, this is the equipment rule. This is different than our Tier 5 engine standards rule. Now, the amendment essentially wants to ensure that the cleanest engines are being added to fleets after Tier 5 kicks in, which would be in 2029. That'd be the Tier 5 interim standards. And the reason for this is because EPA is not likely to be in harmony with us regarding the Tier 5, the more stringent off-road diesel standards. So when a new engine, and this doesn't affect used or existing stuff, but when a new engine is added to a fleet, and again, not replacing something, but added new to a fleet, it has to be the cleanest engine available. In the past, this hasn't mattered because EPA and ARB have had the same standards for off-road diesel, but here we're leapfrogging them a bit, and we'll probably have more stringent standards before EPA has a chance to align or adopt their own stringent standards for non-road engines. So in any event, so if a manufacturer, if a fleet were to add equipment after 2029, it would have to be either California certified, which would ensure that if it's supposed to be Tier 5, it is Tier 5 and not the federal equivalent, which would still be Tier 4, presumably, or once EPA has come on board and aligned, then there'd be no problem. If they have identical standards, then a fleet can add a federally certified engine or a piece of equipment with a federally certified engine into their fleet, no problem, as long as the standards are aligned and the cleanest available. Can you go to the next slide, Muslim? Thanks. Put together some charts. It can be a little complicated. Again, I know we went back and forth on this several times during the fleet rule regulation in 2022, but essentially this is what we're looking for. So if a vehicle, if it's produced in 2029 or later with a California certified engine, then it may be used, it may be added to any fleet, per the allowance of the in-use fleet requirements. If it was produced before 2029 with the California certified engine, again, it can be added to any fleet per, the existing fleet allowances. If they allow a Tier 4 to be added after 2029, then it can be added if it's California certified. Sorry, that I have text blocking and I can't seem to get it out of the way. Hold on. Okay, if a vehicle is produced, you can't see, 2029 with an EPA certified engine, it's before 2029. Again, the standards are the same as they are in California. So there's no problem with that. It may also be added to a fleet in California according, to the restrictions and the allowances of the existing fleet rule. Now, the problem comes in that if a vehicle was produced after 2029 or in 2029 with an EPA certified engine, and presumably that would still be Tier 4 final, at least for a while, even though California would be in the Tier 5 timeframe, Tier 5 interim at least, and if it goes, much beyond 2029, it'll be Tier 5 final. Well, that engine, that federal engine, cannot be added to the fleet as of January 1st, 2029, unless the vehicle's engine is identical in all material respects to a model year 2029 plus California engine. So basically, if California and EPA, I should say CARB and EPA, have identical standards, again, there's no problem with adding this to a fleet as long as it abides by the existing allowances and provisions of the fleet rule. But if it's not, if it's still a Tier 4 final, it would not be allowed to be added to the fleet anew after 2029. Next slide, Muslim. And the amendment also applies to new replacement engines used in the fleet. So if the new replacement engine is done according to the California requirements, it can replace any engine in a fleet per the allowances of the existing regulation. If the engine was certified, take that back. It's not certified because it's a replacement engine, but if it was produced under the federal provisions of 1068-240, it cannot be allowed to replace a model year 2029 or later California engine in an existing fleet, again, unless that engine is identical to the California engine, which is probably not going to be the case for at least a couple of years. Now, if it's a used engine, doesn't matter if it's federal or California, then the current provisions and allowances in the fleet rule would apply. So wherever a federal, wherever a used engine can replace an engine in a piece of equipment that's already in a fleet, it would still be allowed to do so according to these amendments. And the same thing for rebuilt engines. Again, it doesn't matter if it was rebuilt according to the California requirements or to EPA's requirements, which at the moment are fairly similar. Again, it can be used to replace an engine in a fleet unless it, unless the fleet rules say otherwise. Next slide, Mosul.
I guess was the end of it.
That's the end of it. Thank goodness.
Yep.
Okay, thank you for your attention. I guess we'll take questions now.
Okay, thank you. Let's see here. We still have questions from warranty. We can get back to those later. Our first question is from Claude Pilger, 908. On slide 5 of inducements, should the DEF quality not be quality, not quantity? Is that correct?
No, actually, no. SCR inducement will cover both DEF quality and DEF quantity. So the level of DEF, which is quantity, of course, and the quality of the DEF. So it's for both. Yeah, that's what it says: level, DEF quantity, and tampering.
Thanks. Our next question comes from Justin Grohl regarding slide 9. Sorry, this is for the previous topic. Maybe we should go to Kevin Brown at 908. On slide 5, the second bullet, do you mean DEF quality? Oh, it's a similar question. Do you mean quality instead of quantity, which is covered by the first bullet of DEF level?
Oh, where is that? Sorry.
At 908.
Okay. So yeah, I understand what's going. Sorry, that probably there is a typo there. It should be we are gonna fix that. It's a quality. I guess it's showing as a quantity. That's correct. It's gonna be quality, right? That's the question, right, Christian?
Yeah, that's right.
Yeah, that's a typo. Sorry about that. Should be quality. Yeah.
Oh, okay.
Yeah, that's fine. You're
welcome. Let me see here. What's the next question? On Colin Winslet asks SCR asking about SCR inducement slide number 5. Will you include DEF quality in the sensor requirement to ensure correct fluid is used?
I don't quite, maybe I don't understand the question, but yes, DEF quality should be monitored either by urea quality sensor or based on the NOx sensor. If he can elaborate on the question, maybe he can answer later on. But that's for now, the proposal is based on checking the concentration of urea based on using the urea sensor or NOx sensors.
Thank you. Our next question is 40 to 60% torque reduction for severe inducement. It was said before that light load represent a significant part of off-road engine operations. This appears to be inconsistent, still allowing the use for the engine for a large chunk of operations. I believe that the current guidance for inducement is that no productive work should be possible in the severe inducement.
So the severe inducement actually is one stage before final inducement. So when you go to final inducement, there is a no power or idling. And we are here putting 40 to 60% because there are variation of different type of the off-road equipment and different cycle and applications and duty cycle. And with giving the 40 to 60%, we are trying to cover most of the off-road equipment. So, and the reason for the severe inducement for operator to incentivize to do the remedy for the fixing the problem and should be very kind of severe inducement in a sense that the equipment cannot do the work supposed to do in an effective way. So that's the reason for that. And light load, I don't know, is referring to light load before, but that's the reasoning and thought behind the 40 to 60% torque reduction.
Thank you. Our next question comes from Chad Google. For freeze protection, a requirement or attestation that the DEF thaw will occur in 40 minutes is a requirement change from the current regulation and guidance. This is counter to CARB's claim that they are not introducing new requirements. Does CARB acknowledge this is a requirement change and thus a potential design change from today's systems?
No, I don't think this is the different, but if Zach from certification team is here, can you comment on that? My understanding is currently also certification team requires attestation for 40 minutes and
Hello, good morning.
Good
This is Zach. Yes, we do ask manufacturers to state whether they can meet 40 minutes. And of course, then we require them to meet the 70 minutes. So I agree with you, Muslim, that I don't think that, I believe this is still in line with what we are doing currently.
Yeah, thank you, Zach.
Thank you, Zach. Thank you, Muslim.
Mm.
Our next question comes from Adam Mescampo. Does this SCR inducement protocol include low DEF tank level inducements? This can have a big impact on rental equipment, where operators may not be educated on the operation of fluid requirements. This will require a service call just because the operator does not take action to fill the tank within a prescribed time frame. A repeat occurrence by another operator on the same machine is more likely on rental equipment.
To answer this question, the first part is yes, but about the rental equipment, I guess they have to put in place the training for operator, and this is part of the operation manual of engine manufacturer. The engine manufacturer are providing the operation manual for this engine. They give it to equipment manufacturer as well. So I personally believe that part should be based on training and informing the staff. It's not things we have to consider for SCR inducement. This is the engine manufacturer certification process.
Thank you.
And I guess Bill has some comment. Bill, if you want to add, please chime in.
Just that, that's an operational, thing to incorporate into your procedure, and whether that's by topping off the DEF before you send equipment out or a combination of training or both. But running without DEF kind of defeats the purpose of having an SCR system on these vehicles. So it really changes the NOx output by an order of magnitude. So it is a pretty important thing to have functional.
Okay, thank you, Bill.
Our next question comes from Justin Google. Regarding the generic scan tool proposal on slide 7, Would this conflict with the recent amendments EPA made in the Clean Trucks Proposal rule to the OBD requirements? They are specifically, I'm sorry, they specifically require starting in 2027 that non-self healing inducements can be capable of reset via generic scan tool. Also, how might this proposal conflict with recent right to repair legislation in the various states that would require manufacturers to deliver dealer level repair tools to customers and third-party repair shops?
For our proposal, we are keeping the existing requirement for non-road document from the US EPA as well. So we are currently the US EPA for non-road engine also is not allowing the generic scan tool to clear off the inducement. And he's right that maybe there is a change on the CTP rule for generic scan tool, but since there is no change currently on the US EPA for off-road or non-road, we are sticking with that. And with respect to the right to repair, SCR inducement per se, I don't think it's considered as a right to repair, because this is something which based on negligence or maybe not filling of the depth or tampering the system or purposely use the low quality of depth, those kind of things. So that's cannot be correlated to the right to repair topic. That's my answer to this one with respect to right to repair.
Thank you.
Okay.
Our next question is, use of a generic scan tool is not allowed to clear inducement. Factory or dealership tools are required. Right to repair legislations currently or coming require that the dealership tools may be made available to any user. What's the point of prohibiting the use of a generic scan tool?
Again, yes, for this proposal, we are not allowing to use generic scan tool. And as I mentioned in my previous answer, the concept of inducement is different than the repair of the system. So when the system goes to inducements means you didn't take care of the system with respect to depth, like depth level, depth quality, and if there is a circumvention or tampering with the system. So what is the point of having the inducement if you are allowed to use the generic scan tool and clear the fault code? So that is kind of defeating the purpose of this inducement in general. So that's the goal of inducement. And I guess we are mixing up here inducement with the repair, which is not really right.
Thank you. Our next question is at 9:20. Is it allowed to activate the DPF regeneration after achieving final inducement?
Zach, do you have any comment on this one? Because I never heard this, like DPF regeneration after achieving the final inducement. What's the purpose of that?
Yes, I can speak to that.
Sure, thank you.
As far as I understand, there's no theoretical prohibition against that. However, I would be surprised for a manufacturer to successfully enact such a strategy.
Thank you. George Lynn asks, can you confirm that preempted construction and farm equipment, that is Tier 4, can be added to fleets after 2029?
When this amendment went before the board in 2022 as part of the fleet rule, it included a provision to exempt preempt equipment. So yeah, the answer to your question would be yes, based on how it was presented previously. This is how we intend to present it again. But in terms of me confirming, I'm not the last word on this. Obviously, everything has to go through legal, and they'll make the final determination. But if it goes as it did in the 2020 rulemaking, then yeah, the preempted stuff will be exempt.
Thank you, Jeff. Our next question comes from Jung-Ho Kim. Regarding including trigger event for poor quality DEF, the urea quality sensor in the DEF tank corresponds to NOx level exceeding 0.4 grams per kilowatt, the same as Tier 4 final, not Tier 5 final, 0.04 gram per kilowatt hour, or the Tier 5 interim standard at 0.22 grams per kilowatt hour. Is that correct?
Yes, it's as Tier 4 final. It's correct, yeah.
Thank you. Our next question is, did you say that the 2029 telehandler with a 2029 federally exempted engine cannot be bought in California? Could a 2029 telehandler with a 2028 federal exempt engine be sold in California in 2029? I believe Jeff would like to answer this.
Yeah, I'll give this a shot. I didn't say anything about telehandlers in particular or specifically, but if this is regarding adding to the fleet, this is similar to the previous question by George. If it's federally exempted or preempt, then the amendment would not apply to them. Thank you.
Thanks, Jeff. Our next question comes from David Campbell. What is the justification for SCR inducements different from EPA?
So as I said before, with respect to off-road for us and non-road for US EPA, we are not different. That's why I said in the generic scan tool that we are not allowing the generic scan tool the same as US EPA. So there is no justification for being different than US EPA with respect to off-road.
Thank you. John Reich at 926 asks about slide 13. If option 4 is chosen by a manufacturer to meet Tier 5 final at earlier dates, can a California certified model year 2029 plus FT4 engine be sold into a fleet before Tier 5 final date?
Yeah, it's a really good question, John. The implementation phase in that you're talking about, option 4, would require a manufacturer to continue producing Tier 4 final. Not require, but would allow a manufacturer to continue producing Tier 4 final engines beyond the 2029 date in exchange for an earlier introduction of Tier 5 final. Those Tier 4 final engines would be California compliant, and they would be allowed to be added to fleets according to the amendment that we're considering today. Thank you.
Thank you. Our next question at 926 is, EPA has penalized many vendors providing SCR deletion software as operators having fed up with inducements or lack of replacement parts, such as a sensor, etc., have opted for bypassing the inducements. What is CARB doing to ensure that the owners and operators do their part rather than saying that the manufacturer should devise anti-tampering software, which by our own admins is impossible?
Can you repeat the question, Christian? Sorry.
Sure. EPA has penalized many vendors for providing SCR deletion software as operators having fed up with the inducements or lack of replacement parts, such as sensors, etc., have opted for bypassing the inducements. What is CARB doing to ensure that owners and operators do their part rather than saying that manufacturers should devise anti-tampering software, which by your own admittance is impossible?
So as we acknowledge that this anti-tampering every aspect of that is it's impossible, but as mentioned in the presentation, we are expecting the manufacturer to do the diligence to do whatever they could do to prevent from tampering the system, and they have more knowledge about the system and how the whole like a control system and their software are working. It would be possible to put some conditions or some safeguard to avoid the operator or whoever is working to delete the software or do the circumvention with the software. So that's our expectation. Here we are proposing the inducement to avoid those kind of things, but we also relying on manufacturers which are more familiar with the technology to cover this type of situation which can happen, especially with the software and hardware. Anybody from CERT or other member of the team have more, please chime in.
Yeah, I would just add, that was a good answer, Muslim, but I would just add that, of course, we also do everything we can to try to stomp out the use of illegal defeat devices, and we have a whole aftermarket parts program aimed in part at that. And if we, in the course of doing inspections related to our in-use software diesel rule, if we find that kind of thing happening, we enforce where we can. But none of this is perfect, right? But we, as Muslim was describing, we want manufacturers to do as much as they can to make it hard to tamper as well.
Thank you, Kim.
I'd just add that there was a recent issue over the last couple of years where there was a supplier that was having some trouble with their SCR sensor package, and we both CARB and EPA worked pretty closely with the OEMs to manage that situation and provides workarounds that then were able to be taken back off once the parts became available again, or the revised, improved parts. So, we hope that that's a continuous learning experience for the supply chain, as well as I think it's a demonstration of us working with the OEMs and the end users to make sure that there's a reasonable path forward when unanticipated events happen.
Thank you. Our next question is, can you better explain how new engines that fall under the federal CAA preemption are affected by the fleet rule amendment?
Sure. Again, I've addressed, others had the same question. We would propose that if the engines are preempt, that the amendment would not be applicable to them. And that this is how it went before the board in 2022 in the fleet rule regulation, which was approved by the board. But again, legal has to weigh in as well. But that's how we would propose the amendment.
Thank you. Our next question comes from George Lynn. The fleet rule changes for replacement engines are confusing in terms of what are they intended to accomplish. How is this different than the existing replacement engine provision in 13 CCR 2423 and California 1068 test procedures? Is this additional language in the fleet rule for replacement engines necessary, or is it merely redundant?
Again, George, no, it's not. We don't believe it's redundant, which is obviously why we're proposing it, especially regarding the engine replacement provisions. If an engine is Tier 5 compliant, we don't want it to be replaced with a similar year federal engine after 2029 that is still Tier 4 final compliant. There are clarifications, regarding the existing language in the fleet rule, that we're hoping to achieve with this amendment. Again, we want to ensure that the cleanest engines are used or added to the fleets, especially when they're available in California. So no, George, I don't think it's redundant, but obviously we'll have further discussions on this, and if there things that aren't clear, we'll work them out. So thank you for your question.
And I'd just like to add one thing. Since the fleet rule applies to the owners of the equipment and not the engine or the machine manufacturers, I think it's important that this clarity is provided in the fleet rule so that owners of the equipment know what they can replace their engines with.
Thank you, Johanna.
Thank you. Our next question comes from David Campbell. For model year 2029 plus, many new preempt construction machines with the EPA Tier 4 engine may be added to an existing fleet.
Again, this goes back to the whole preemption thing. We are not proposing that preempted equipment or equipment that's beyond the control of California CARB would be subject to this amendment.
Thank you. A related next question is, do you think that your fleet rules apply to machines equipped with preempt engines?
I wish there was a copy and paste type of thing for answering these. Yeah, again, we're not proposing that it's that the amendments would be applicable to preempt equipment.
Thank you. Our next question comes from George Lynn. Inducement should not begin while the engine is fully emissions compliant, as in CARB's 25% inducent at 10% DEF. I recommend that warning should be required while DEF is available and the engine is emission compliant, and the inducements only impact when engines is not meeting the emissions.
So, as I said before, the inducement purpose to incentivize the operator to take care of the system before reaching the final dead ends or empty tanks. So one of the logic and reasoning behind the inducement is giving enough advance warning to the operator to do the refill the system, and that's why we are considering this strategy to be like a fair playing field for everybody, not different manufacturer come up with different percentage of DEF tank. And as far as the 25% inducement, probably is a good start for operator to notice that the system needs to be filled or have enough time or take care the filling the tank in a appropriate time before reaching the empty tank. So I guess it's gonna fill the purpose for the incentivizing the operator.
I just mentioned that, this is not something we dreamed up for the off-road. It's been a long-standing practice to have some level of inducement as the DEF gets running short in the on-road for, as long as we've had SCRs.
Thank you. Our next question is, why is freeze protection needed in California? How often and where does it get down to temperatures that can freeze diesel fluid? Maybe at the top of Mount Shasta or Mount Whitney during the winter, but not in LA or Tulare.
Yeah, I guess he's kind of answering his question. So if somebody doing something on the Mount Shasta or somewhere, which is this possibility of the freezing of the DEF is happening, they have to have the system to make sure it's working on those conditions. So this SCR inducement cannot work based on like an exception, so it should be like a general policy or general concept for every situation.
And again, this isn't something we've dreamed up for off-road. It's been a long-standing part of SCRs in general, which have generally been on-road.
Thank you, Bill.
Thank you. Our next question comes from Rahul Suresh. To ensure that inducement strategy is enforced accurately to prevent customer nuisance, what would be an appropriate way to disable inducements using rationality diagnostics before OBD inducements?
Anyone from OBD team can take on this one?
Oh, and I'm sorry, there was a correction. That's OBD implementation, not OBD inducements.
Yeah, Muslim. This is Jason speaking.
Sure.
This is not an OBD question. I think they're asking about inducements, what they have to do before OBD is implemented. So I think it's in your area.
Ensuring inducement strategies enforce accurate. So I believe this kind of related to the tampering part of inducement. So they have to have like a control and check the functionality of the sensor and make sure they are not getting the false inducement, and make sure if it's something happening with the sensor or the equipment which are monitoring the SCR system are correctly diagnostic with respect to the function and operation. That's my take on this one. So it's based on healthy monitoring of the sensors, not getting the false inducement or false signals from the systems.
Thank you. Next question comes from, oh, sorry.
Yeah, Christian, I was going to maybe add to what Muslim was saying. If we have inducement requirements today, then I think essentially a manufacturer can do what they're doing today, and that is meet the inducement requirements in the absence of OBD requirements. So I think that's what we would expect under the Tier 5 rule. They'd have to come up with a solution to the inducement requirements ahead of OBD implementation.
Thank you, Mike.
Thank you. Our next question comes from Adam Mezzacampo. Clarification on the DEF level. The concern is the additional activation service call required with factory tools to reset inducement for repeated instances of the inducement. Obviously, a derate is needed to prevent operation without DEF.
DEF level. Okay, service call with factory tools is the final inducement. So if, for example, the DEF level is still in a level that you can do the self-healing with the refilling the DEF tank, you shouldn't need to call the factory or use the factory tools to fix the problem. So one of the reasoning behind having like a different stage, like initial, severe, and final inducement is for that as well. So you get like a warning ahead to fix the problem, remedy the problem before reaching the final end, which is you need to go to the factory or need a special tool to fix the problem.
Thank you. Our next question comes from John Talesthorpe. Is severe inducement really necessary? A warning and an initial inducement should be enough to notify the operator before final inducement. A two-step inducement ladder would also be in line with the EU Stage 5.
Yeah, we believe the severe inducement is necessary because sometimes with 25% reduction, you still can do the intended purpose of the work you are doing with that equipment. So if you reduce the engine power more like a 40 to 60%, that is kind of limited the work that the equipment intended to do. And that was make it for operator to take care of the problem. And with respect, as far as I know, for EU stage, they have a two-step inducement as well. They have like what they call it low-level inducement, and they have a severe inducement, which is in ballpark of the 50%. And we are, for considering the different range of equipment, we are not giving the like a specific number, and we are providing a range from 40 to 60% for the severe inducement.
Thank you. Our next question is from Louis Nikoka. For the OEMs who are not engine manufacturers, they may be disconnect in SCR issues that the engine manufacturers may miss. Is there any requirement for the engine manufacturers to have telematic feature that makes them aware of these issues?
I think this is between the equipment manufacturer and engine manufacturer, and the responsibility of the engine manufacturer to provide like information about the SCR system and SCR inducement process and how their control system working with respect to the SCR inducement and what they implemented to go to the inducement. If they reach to agreement to have like a telematic to inform them or provide any alert, that would be fine. But as far as us, I don't think we can give comments on that.
Thank you. Our next question comes from Dave Campbell. If the SCR inducements are not different than EPA, then why do we need slide 8, or why do you need slide 8?
So when we say it's not different than EPA, is the general concept is not different, but there is some minor differences we wanted to point out on the slide 8. For example, for CARB, with respect to repeat offense, we are giving more time than US EPA. They're giving 30 minutes for repeat offense, and we are giving 60 minutes. And the other different is a couple different things we were trying to point out, make sure is clear here. But the general concept of how what is the purpose of the inducement and how it works and what are the stage of the inducement are the same with the US EPA.
Thank you. Next question, Steve Neva asks, so does the proposed fleet rule amendment require that preempted engines will still need to be annually certified to CARB Tier 4 once the proposed Tier 5 takes effect? I think Jeff wanted to respond.
Yeah, I did, and I'm not sure I fully understand the question. Actually, Johanna, if you're still on, can you chime in on this one, perhaps? Sorry to put you on the spot.
Yeah, no. So we don't certify preempt engines now. So in 2029, when the amendment would take effect, if you are bringing in a new vehicle that is a preempt vehicle, so construction or ag, it would just need to have the US EPA certified engine in it. Everything else would have a CARB certified tier 5 engine. So I'm not sure if that's answering the question, because we don't certify the preempt engines now, is my understanding.
Yeah, I didn't think so either. Thank you, Johanna.
Thank you. Our next question comes from Nathan Murphy on slide 5. Is that DEF quality? DEF quality, or should DEF quality equal DEF level?
Yeah, that was a typo. Sorry about that. It's a DEF quality. It's not DEF quantity.
Thank you. Our next question is, will CI and SI engines be treated in the same way?
Christian, I see that the anonymous attendee rephrased it at 9:57, and so the question is in the fleet rule.
Ah, I see. So will CI and SI engines be treated in the same way in regards to the fleet rule?
So the fleet reg, the in-use off-road diesel fuel fleet reg, only applies to the compression ignition equipment with compression ignition engines. There is a separate fleet regulation for large spark ignited equipment, but that's a completely different rule. And the 2029 proposal would not apply to that other rule. It only applies to the in-use off-road diesel fuel fleets rule, which covers the CI engines. I hope that clarifies.
And let me just add one more bit of clarification concerning the in-use off-road diesel fleet rule that Johanna was just talking about, because I think a lot of people in this call are probably manufacturers and may not be used to thinking much about the fleet rules. So we had a bunch of questions concerning, wait, what if stuff is preempted? So I just wanted to clarify. So for under the Clean Air Act, there's certain engines that CARB cannot certify. So ag and construction under 175 horsepower, we can't certify those when new. But once equipment is in use, that does fall under CARB's purview. So although the amendment to the in-use off-road reg that we're discussing can't include preempted engines because it concerns adding brand new stuff. Once things are in use, they're fair game and they're covered by the in-use off-road reg, which, for example, requires phase out of all tier 2s by a certain date, or requires a fleet's overall emission average be a certain number. So I just wanted to clarify but all the off-road diesel equipment owned by fleets, whether it was preempted or not, once it's in use, it is covered by that rule.
And I'd just like to make one clarification. I think the way I answered the question previously, where I thought we were talking about the certification of the engines annually, I think I'm wondering if maybe the question was whether or not that equipment needed to be reported for the regulation. The preempted equipment would need to continue to be reported under the in-use fleet rule. And it would need, as long as the equipment and the fleet is subject to the regulation, all the requirements for reporting and labeling and all the other requirements would apply. So I just wanted to make that clarification, because I'm not sure if that's what the question was referencing.
All right, thanks, Sean.
Yes, thank you. Our next question comes in at 9:51. You're requiring both an SCR warning lamp and an audible alarm in slide 8. What observations have you seen from the field to show having only one of those warning triggers is not adequate for the fleet operator to react?
Yeah, the observation is that sometimes the operator don't pay attention to the light, and that's why the audible alarm is helping to get their attention for fixing the problem. And any team member from in-use team have any comment, please chime in. But that's the main goal, because during the operation, sometimes the operator, they are not paying attention to the light, and that's having both of them would help to get their attention.
And beyond just the belt and suspenders of it, we do get regular feedback from equipment manufacturers that there is a very broad range of equipment types, and that different types of enunciation or indication may be more useful on one type of equipment than another. And so it's a way to be more generally applicable across the range of equipment types that these engines will be installed in.
Thank you, Bill.
Thank you.
So this is Elena. I'm sorry. I just wanted to if we are on the question 958 regarding inducements, I can also add that CARB, through its pilot off-road program, has been looking at how inducements are being implemented in the field currently for the Tier 4 engines. And I can confirm that indeed, most of the manufacturers are doing a good job following, implementing what they describe at the time of certification. There are instances for, particular cases that things might not go perfectly well. And in those situations, we do work with manufacturers where they do implement corrective actions. Hopefully that added a little bit more information on what we've seen from the field. And I want to repeat what Bill Robertson mentioned earlier. Inducements as a concept is not something new. OEMs had implemented this type of strategies for quite a few years now, and they're really good at them. It's just changes to the Tier 5 is bringing in some modifications to the current strategies that are being implemented.
Thanks, Elena. And then also, Christian, can you read that question at 958? I don't think we read it out loud.
We're at 958. As it has been stated many times that the inducements are not new, can CARB share data regarding effectiveness of inducements, such as operators taking appropriate actions to get into compliance when faced with inducements, or looking at circumventing it by installing aftermarket software? If this clear data is not available, what is the rationale behind continuing with inducements?
And in addition to what Elena Florea shared, I can just share that when we were developing proposed changes to the inducements on the on-road side, we did receive a lot of feedback from fleets regarding their desires for us to change inducements on the on-road side, because they were responding to inducements, and in fact they were concerned that the inducements were too harsh and were causing too much inconvenience to their operations. So that definitely indicates that not every fleet is going to be willing to try to cheat the inducement, right? I mean, there's always going to be some bad actors, but at least in my experience, most fleets want to be compliant. They want to do the right thing. So we know not everybody is just going to go looking for a defeat device.
Thank you. Our next question comes from Deepak Guruswamy. How, in the presence of SCR inducement, should the OBM real data logging operate? Is there a bin for phase 1 to put inducements active state and pause real data logging? I believe Paul wanted to respond to this.
Yeah, that's a very good question, Deepak. So for phase 1 at this point, we are thinking about allowing manufacturer like tailpipe NOx sensor diagnostics, for example, to be able to pause real tracking when the tailpipe NOx sensor is found to be bad. But specifically when SCR inducement is active, we need to take that back and find a good way to deal with that. So we're going to make a note of that and add that to the process. So thank you.
Thank you, Paul. Our next question comes from Alagura Rajan Karan. Does the urea quality correspond to the model year, since Tier 5 has an interim period as well?
Yes, and it's applied to Tier 5 interim too. I believe Jeff yesterday showed a table for implementation and SCR inducement mentioned on that. So based on the table, the interim Tier 5 models also included for SCR inducement.
Thank you. Our next question is regarding Mr. Neva's question from 1143. Many engines are CARB certified below 175 horsepower, but preemption prevents CARB from stopping sales in California.
Yeah, I'd like to take that. So there's nothing in the proposal that would prevent where CARB would be preventing sales in California of preempt engines. So once the Tier 5 standard is adopted, CARB would be certifying under the Tier 5 standards. And so the preempt engines would go through the US EPA certification, and those engines would go into the equipment, and would be sold in California as preempt engines. So I'm not sure entirely what the question is here, but there's nothing in the proposal that where we would be preventing sales in California of preempt engines.
And I will say that we're working closely with Johanna's team, or with the in-use team on this reg, so we're working together.
Thank you. Our next question is related to the previous questions on inducement activation. Are there any safety concerns considered when mandating inducement activation directly upon fault detection?
Yes, that was the section we talk about the safe harbor triggers, and that means before final inducement activation, two of that requirement, which like refueling, park idling, or engine restart should be met before the system goes to the final inducement. And that's for the safe harbor. It's considering the safety of equipment and operator.
This is kind of related to that question about, do we really need 3 stages of inducement level and whatnot? And it's, there's a guy that's cursing God because he got washed away in the flood after waving off the boat and the helicopter and the amphibious whatever that tried to take him off the roof. So yes, it's something we think about, but we try and make sure that final inducement isn't any surprise for anyone.
Thank you, Bill.
Our next question is regarding the DEF quality. The current EPA guidance is to initiate inducement at 1 times the standard. Given the lower ultra-low NOx limits, this is not feasible with DEF quality sensor technology. Will CARB be considering a reasonable threshold increase to account for the technology?
Yeah, that's why we mentioned that we are leaving this at Tier 4 final level, which is considering the Tier 5 final, which is 0.04, we are keeping it at 0.4. It means it's at 10 times the Tier 5 final, and that was we are considering that because of the same reason he mentioned here for the technology and the detection of deviation of the urea with the quality sensors. Yeah. So we have already considered that.
Thank you. It looks like we have a hand raised from Bridget Downs. I'm going to allow you to talk. Please unmute yourself and ask your question.
We can't hear you if you're speaking.
You're still muted on your end, Bridget, if you'd like to ask your question.
Maybe it was an error on her part.
That's okay. I'm going to lower your hand. If you have a question later, you may raise it again, Bridget.
All right. I suggest that we go on to our next topic for today, which is OBD. Thank you, Muslim
Yeah.
and Jeff and everyone, Johanna, for answering questions.
Okay, thanks, Jenna. Depending upon where people are joining us from, I'd like to wish everyone a good morning, afternoon, and evening. My name is Jason Wong, and I am the manager of the OBD program development section, which is the group in charge of developing onboard diagnostic requirements for the Tier 5 off-road rulemaking. Next slide. This slide outlines the four main elements of CARB's off-road OBD presentation. First, I will provide a brief overview of what an OR OBD system consists of. Second, Paul Hendrick will provide an overview of the proposal's standardization requirements. This will be followed by descriptions of the diagnostic requirements for OBMD, which will be given by Dr. Yong Yu of my staff. Dr. Shabnam Domagani will then provide the OBD diagnostic requirements before we conclude with the implementation schedule for the proposal, which will again be given by Dr. Yong Yu. Next slide. Okay. To develop the OR OBD proposal, my team sought input from the various programs and groups within CARB that would be the consumers or users of the information to be provided on an OR OBD system. These CARB groups include inventory, warranty, in-use compliance, and Tier 5 emission standards development teams. We used their input to help design elements and features that were critical to support their programs. While our program is highly dependent on the Tier 5 emission standards proposals that have been presented on Monday and today, we also sought to simplify the dependency on their requirements and our requirements as much as possible. With 6 different power categories and their associated emission standards and implementation options, we decided to center OR OBD requirements strictly on the emission control solutions utilized by manufacturers. In the various power categories, instead of having requirements specified by, instead of having things specified by the emission standards, we wanted to specify more by the emission control solutions within each power category. So as you can see on this slide, an OR OBD system has 2 requirement pathways and is strictly dependent on the inclusion of an SCR system in this emission control system. If an off-road equipment has an SCR, it is required to follow the OBMD requirements. If it does not have an SCR system, it must follow the OBD requirements. Both requirements have virtually identical standardization requirements and differ mainly with the OBM or NOx emission monitor element in the diagnostic requirements. Now, I will hand the presentation over to Paul Hendrick to describe the standardization requirements. Excuse me.
Okay, thank you, Jason. Standardization is going to be an essential piece of the OR OBD system. Standardization enables universal access to diagnostic information for everybody. So that's technicians, owners, operators, regulators, your neighbors, anybody. And it structures diagnostic information in a consistent, understandable format across all engine makes, models, ratings, all across the board. So basically somebody, does not need a dealer tool to access this information. A generic scan tool would be able to acquire and translate all of the diagnostic data. So at a high level, we're proposing implementation of the standardization requirements in 2 phases. So there's phase 1 standardization and phase 2. I'm going to start talking about phase 1 in some detail now. So could we go to the next slide, please? Okay, so, back one. So phase 1, it applies to all Tier 5 interim and final engines that have electronic control units. So if the engine is purely mechanically controlled, you can fall asleep right now. So phase 1 begins with the first model year that a Tier 5 engine is introduced, so right off the bat. And it covers engines in all power gap categories, from the really small to the really large. The basic elements of phase 1 standardization are listed on this slide. So it's going to touch on the communication protocol, the data link connector or DLC, data stream requirements, our off-road real emissions assessment logging data. That's a tracking requirement for SCR-equipped engines only for that one. And also, we are proposing calibration identification number, that's CAL-ID, and calibration verification number, CVN requirements. So I'm going to talk about all of those bullets going forward here. And I just wanted to point out that the diagnostic-related elements for standardization are going to be pushed back a few years later in phase 2. So that we'll get to that also in this presentation. So could we have the next slide, please? Okay, so for the first piece of phase 1, it relates to the communication protocols that we are proposing to allow. So we propose that either SAE J1939 or J1979-2 be allowed on Tier 5 engines. And J1939, that's already in widespread use across many different off-road engines. And by specifying these 2 particular communication protocols, we would be harmonizing with our current on-road heavy-duty engine requirements. And just as a side note, we will be specifying the 500 kilobit per second baud rate for J1939 engines. Next slide, please. So the data link connector. If you have a J1939 engine, we would be specifying the SAE J1939-13, the round green 9-pin Deutsch connector. And then if you go for J1979-2, that would be the SAE J1962 connector. That's the 16-pin, trapezoidal connector it's in your car today. Location. Location is a big topic. Where do you put the data link connector? So in the on-road world, we specify the location pretty clearly, but we recognize that in the off-road world, you have so many different types of equipment, so many different geometries, and so many sizes, shape, whatever, that specifying a location can be really daunting. So we are going to propose a sort of less specific, a little more general type of requirement, and that is that the DLC must be near operator controls or the engine's power switch and not be hidden behind a panel. Kind of basic there. But if that is not technically feasible, for some reason, if this is still just going to be a major hurdle for a manufacturer, we're also proposing that you can request to apply a durable label to the exterior of the equipment, which indicates where the DLC is. So yeah, if you have good reason, we're keeping the door open for this option. And that location, though, it must be easily accessible. We don't want the DLC to be buried somewhere in the engine compartment where you have to remove other components and dig down to get to it. So that's not what we want. Okay, so let's go on to the next slide, please. There was an interesting proposal made by industry as an alternative to the traditional data link connector concept, and that is the embedded scan tool. So an electronic device that basically would provide diagnostic data wirelessly so that a user could access that data through a web browser and potentially through Wi-Fi or Bluetooth. So it's an interesting idea, and we do want to give it consideration. So we're thinking that perhaps we could allow such an alternative if certain equivalence criteria are met. So equivalence to what we would get from a physical data link connector traditionally. So one of those criteria might be, we have here universal access. So, no fees, no special permission to get that data. Another criterion would be reliable lifetime access. So, if the data is, if it were to only be available through a web browser, then that sort of means you're at the mercy of the server that is maintained by the manufacturer, and that needs to be up and running, and it needs to be up and running as long as that piece of equipment is up and running. So one way to address this equivalence criterion might be ensuring that the embedded scan tool also has a local wireless communication method built into it, so you're not exclusively reliant on a web-based interface. Another equivalence criterion is data logging functionality. So, with the data link connector, today we're very used to being able to plug in and request data at 1 hertz or greater, depending on what kind of communication protocol we're working with, and being able to log data over a trip or some drive cycle. So we would want to have that same type of functionality and not be limited to just getting a static snapshot every now and then from the web. And by the way, that's also important for PEMS testing, having this functionality. Another equivalence criterion relates to data authenticity. If you go up to a wheel loader and you plug in, you're getting OBD data, you're pretty confident that the data you're getting is actually from that wheel loader. So we would want to have some type of assurance along those lines with this embedded scan tool concept as well, that the data we're getting is where we think it's coming from. So yeah, so those are some criteria to think about when entertaining the notion of an embedded scan tool. Next slide, please. Okay, data stream. So what kind of data do we want to get? In the on-road world, historically, we've specified these long lists of parameters that we want to be supported in data stream. And for the off-road case, we're taking a little bit of a different angle. And as you see here, the first bullet, we're listing all physical inputs and outputs related to the engine and emission control system. So this is all sensor input data, like temperature sensors, pressure sensors, and so on, as well as all output data, like commanded EGR valve position, commanded DEF dosing rate, and so on. The reason for the change in this breadth is that there will be reduced standardized diagnostic requirements for off-road engines, which you will see later in the presentation. And so in order to give technicians and owners a little bit more of an edge when it comes to figuring out what's going on with their engine, we would propose that additional data stream support be there to help them get information about the inner workings of the engine when they need to figure, when they're troubleshooting, basically. So in addition to all of the physical inputs, I'll just add that when we say physical inputs, these are not like calculated parameters. These are like actual sensors providing data. So in addition to those, there's a few other parameters we wanted included in data stream, and those are ones that relate to PEMS testing and also real calculations if the engine is equipped with SCR. So these include engine speed, reference torque, actual indicated torque, nominal engine friction torque, NOx sensor concentrations, NOx sensor status, exhaust gas mass flow rate, and fuel rate. Okay, next slide, please. Okay, adding to this list, we would like to see parameters that will support the in-use compliance screening program. So these include engine family name, engine serial number, engine rated power, engine hours of operation, OBD requirements to which the engine is certified, and engine runtime since last code clear. So next slide, please. Okay. So now we're getting to a tracking requirement. This is, you've seen this before yesterday. We have a couple of different colors here for you today, but it's the same structure. So for real data tracking, we will propose that NOx mass and engine activity data be stored in these bins that you see in this table. And if you look at the top table, that's bin 1 through 13. These are defined in terms of SCR outlet temperature windows, like we covered yesterday, as well as these power windows. And that's actually the same structure that we have in terms of the power that we have for on-road real. Bin 1 is simply the total of bins 2 through 13. And we also have a couple of special bins right below there. There's a DPF regen bin, which will store data only when DPF regen events are being commanded. And there's a mill on bin, bin 15, that will only store data when the mill is on. Now that is going to come, that will be active later in phase 2. So in phase 1, we do not have mill requirements or diagnostic requirements at all. So but that is part of the overall tracking structure. Then you'll see on the bottom left, there's the 3 bin MAW bins, bin A, B, and C, that'll be used in NOx screening. And finally, the for PM screening, we will be introducing a fault code history tracking parameter, and that is also going to be added in phase 2. And it's being added in phase 2 because there are no required DPF monitors in phase 1. So that will come later. Next slide, please. Okay, this table lists out the parameters that are going to be tracked in those bins, which you just saw. So there's 5 parameters. These 5 parameters are actually the same as in on-road reel, but on-road reel has one more parameter beyond these 5. So for off-road, it's going to be NOx mass, engine out, NOx mass at the tailpipe, engine output energy, engine runtime, and total fuel consumption. And then you'll see there's 4 different arrays. The first 3 arrays in orange or red, orange, or whatever that color is. The first 3 there only track data when the NOx sensors are active. And then the last one in blue, that tracks only engine activity data, but it's doing so continuously. So whether or not the NOx sensors are reporting data, those bins will be storing engine activity data. And by engine activity data, I mean specifically the last 3 parameters: engine output energy, engine runtime, and total fuel consumption. So the first array, the active 50-hour array, that will be accumulating data over a window of 50 engine operating hours. So as you fill up these bins with data, once you reach 50 hours of engine operation, that chunk of data will get transferred over to the stored 50-hour array. And essentially, it will overwrite what was previously stored in the stored 50-hour array. The lifetime array is just what it sounds like. It will continue to accumulate data for the life of the vehicle, or at least until the next time that the ECU gets reflashed. Okay, and next slide, please. All right, so now Cal ID and CVN. So this is how we ensure the integrity of the calibration data that is being used by a control module. We assign a calibration identification number to that cal, and a CVN. CVN is like a checksum. So there's an algorithm that the ECU runs and calculates over all of the calibration data, and it spits out a number, and that number is unique to that set of cal data. So this is useful for ensuring that only the certified calibration is being used by an engine. So in phase 1, what we're proposing is that all ECUs associated with engine controls, emission controls, or after treatment controls, such as the DEF dosing module, must support Cal ID and CVN. And we actually had to split out phase 1 and phase 2 a little bit, because traditionally in the on-road world, we assigned Cal ID and CVN to a DEC ECU. And a DEC ECU is a diagnostic or emission critical ECU, which had some degree of diagnostic content in the definition. So since we were not requiring diagnostic content in phase 1, we had to take a different approach towards defining which ECUs are going to get Cal ID and CBN. So anyway, once phase 2 kicks in, now we can add DEC ECUs to the list because diagnostics are going to be required. And I'll just point out the bottom of the slide. We have a proposed definition for the DEC ECU for the off-road context here. It is the engine control unit and any other onboard electronic powertrain control unit that is field reprogrammable and has primary control over any major monitor or any rationality fault diagnostic or functional check for any input or output component under OR OBD. So that actually borrows quite heavily from the on-road definition that we use today. So next slide, please. Okay, so phase 2. So phase 2 is going to start several years after phase 1. You'll see what the implementation schedule looks like at the end of the presentation today. But just to point out, so phase 2 builds upon phase 1. So those requirements are in addition to phase 1. And it will only apply to Tier 5 final engines. And just a note that there was a typo in the web version of this presentation, where here at this point it said that phase 2 applied to Tier 5 interim and final, but that's not correct. It is simply Tier 5 final. And you'll see that once we get to the implementation schedule slide at the end. And then again, it only applies to electronically controlled engines and in all power categories. So the elements of phase 2 include fault code related standardization, test results, additional data stream parameters, and tracking data. So we're going to go through those points next. Next slide, please. Okay, so the fault code related piece. What we're proposing is that both pending codes and confirmed codes be supported. As I'll point out later, we're not proposing permanent fault codes. This is a big simplification from on-road OBD. And actually, you'll notice that there are quite a few places in this presentation where there will be quite a simplification relative to on-road OBD. So we want to see pending and confirmed fault codes, and they need to be standardized. So you're going to be following either SAE J2012 structures or SAE J1939. For fault code handling, this is how you set and clear a fault code. For both the OBMD and OBD engines, we're proposing that the first time a malfunction is detected, that is what will trigger a pending code, and that 2 fails would be required to confirm and turn on the mill. As far as now how you heal, this is something it's up for discussion. And in the on-road world, we have what some people refer to as the sticky mill. So it can take 3 subsequent passes of the diagnostic before the mill is naturally healed and turned off, and you clear the fault code. We'll see where we kind of go on this one, and so it's like I said, up for discussion. And actually this was mentioned earlier, but we also are going to want to have a tracking parameter for the engine runtime since code clear. The next bullet point is actually quite significant. We would like to see any additional pre-existing manufacturer diagnostics start using standardized fault codes as well, if they relate to emission controls. So, you know, the actual diagnostic requirements that we're going to propose are pretty limited. And as such, we would imagine that manufacturers will be using a lot of their own diagnostics for those components that we're not going to touch on formally. And so this is simply asking that for those diagnostics that you actually start using standardized fault codes that are, you know, that you can interpret with a generic scan tool. And then last here on this slide, we propose to require that the OBD system support freeze frames. So freeze frame is basically just a snapshot of all of the data stream values at the time that the fault was detected. And next slide, please. So continuing on, and this is a big one. We do want to see a dedicated mill. So, you know, there's a lot of value in having a nice universal standardized symbol for indicating when an emissions related malfunction is present. So we want to continue that as we have in the on-road arena. But there are a couple subtleties here, depending on if it's a OBD or OBMD engine. So for OBD, we're proposing that the mill can be activated for the actual life of the engine. So that's the same as on-road. So as long as that piece of equipment is operating, the diagnostics need to be able to turn the mill on. For OBMD, we have the same basic proposal that the mill activates for the actual life of the engine, except, and this is a big except, that's why it's in all caps and underlined, so except for the OBM NOx monitor. So that's a special case. So what we're proposing is that the OBM NOx mill only be active during the emission warranty period, and then subsequent to that, this monitor would not turn on the mill, but it would nevertheless continue to store fault codes, and that would be for the actual life of the engine. So a couple of important points here are that at the bottom are some things that are not required, and these are pretty big simplifications relative to the on-road world. Readiness status, we're not going to be requiring readiness as we do in the on-road context. And like I said before, no permanent fault codes. So next slide, please. Okay, test results. We do propose that some limited test results be supported by the OBD system. And this is just like as we have with on-road OBD, except it'll be a shorter list of what actually needs to support test results. So for an OBD engine, so this is without SCR, we'd propose that just the major monitors support test results, and that would be the PM filter, monitor, EGR, PM sensors, DOC, and fuel system. For an OBMD engine, so this is with SCR, again, we're going to focus on the major monitors. So we'll want to see test results for the OBM NOx monitor, PM filter monitor, NOx, and PM sensor monitors. Now there's a somewhat new player, but not really, as you'll see, a new acronym, but not really, as you'll soon see. Monitor activity data, MAD. Yeah, it just worked out that way, MAD. I'll get to that in subsequent slides in more detail. Additional data stream parameters. We're proposing to require some data stream parameters that will shed light into the inner working of the OBM NOx monitor. So the first one there is that we would like to see OBM NOx window counters. So these are the 3-bin MAW window counters for bin B and C. And that'll make more sense once later we're going to talk about what that OBM NOx monitor is and how it works. But basically, it's going to be storing data in a couple of these bins, just like the real bins, bin B and C. So we can see, like, okay, how close is it to making its next decision and whatnot. And then also the OBM NOx and work data that it is also tracking and accumulating prior to making its decision. Another important point here at the bottom, it's another not required piece. So in the on-road world, we have IUMPR, which is in-use monitor performance ratio tracking. And this is another big simplification for the off-road context. This, for those that don't know, this is basically tracking of how often all the conditions are satisfied for monitors to be able to detect a malfunction. And there's a lot of rules and details about how that tracking is done and how frequent it must occur in order to be compliant, and so on and so on and so on. So that's not going to be required for the off-road context. So next slide, please. Here, I'm going to give some more detail about that PM fault code history tracking parameter that I mentioned earlier, which this piece is being added to essentially to the real umbrella, right, in phase 2. So this is to support the PM screening program, and it's just a parameter that's going to store fault code data that relates to the PM filtration efficiency monitor and the PM sensor monitors. And so we're adding the PM sensor fault codes to this because that is what we expect manufacturers are going to use to satisfy the PM filtration efficiency monitoring requirements. And if there are malfunctions with that PM sensor, then that can interfere with the ability to monitor the DPF in the first place. So it's something that we want to keep an eye on. But the basic idea is that if you have a high rate of these PM filter related fault codes, that is a flag that we might have a high PM emission problem on our hands. So the actual data that gets tracked, there's 2 pieces. So it's going to be the actual fault codes themselves, both pending and mill on fault codes. And there's going to be essentially 5 slots so that you can store the 5 most recent fault codes, and that'll be together with the engine hour timestamps. So you'll know when those codes occurred relative to the current engine hour meter. Next slide, please. Okay, yeah, I promised we're gonna get mad here. So an introduction to the monitor activity data. So it's basically what this is a simple method to track and report how often monitors are making decisions. And it's pretty much identical to the on-road SMAD, which is supplemental monitor activity data. But in the case of off-road, there's no IOMPR. And so therefore it's not supplemental. It's all we have. We don't have anything else. So we had to drop the S, and that made us mad. So MAD counts the following parameters. It counts up the actual monitor decisions. These are pass or fail. And it's not like, unlike IOMPR, it is not sizing up all of the conditions needed to detect a malfunction. It's much simpler than that. It's just looking, say, hey, did the monitor make a decision? Yes or no? That's it. And it's counting each time a monitor made a decision. And then it's also counting the number of engine ignition cycles that meet minimum engine activity criteria. And for those of you who know a little bit about OBD, this is the general denominator. And well, I'll talk more about that soon. So with this MAD tracking, there are no special denominators to worry about, as there are with IOMPR. There are very simple pause criteria, and I'll talk about that more soon too. Yeah, so and the structure of MAD or SMAD has already been implemented in SAE J1979-2, but it has not yet been implemented in J1939. So this is something that we need to work on with the 1939 committee. So yeah, so that is something to keep on the radar screen. And then last here, we are thinking about having some form of minimum monitoring frequency, just to ensure that we don't have any inert, dead monitors on our hands, just to have some sign of life that yes, these things actually are functional. So that's also to be determined. Okay, next slide, please. Okay, so here we're showing the 3 specific tracking parameters that MAD will use. The first one is called the mini denominator. This is a 1 byte trip counter, essentially, or you could engine ignition cycle counter, you could say, which increments only when the general denominator increments. And so this is when some minimum predefined level of engine activity has occurred, and then you count that. It's like, okay, I've run the engine enough to meet some basic activity requirements, and in this particular parameter can increment from 0 to 255. And the idea here is that every DEC ECU will support 1 mini denominator. The next parameter is the mini numerator. It's also a 1 byte counter, And this one is assigned to every MIL-relevant diagnostic trouble code, and will increment when the associated monitor runs and completes. So the monitor has to make a decision, and then that monitor's own mini numerator will increment by 1. So the mini numerator will reset to 0 once the mini denominator hits its maximum value of 255. And once it does, then you can calculate this ratio of the mini numerator to the mini denominator. And that's called the monitor activity ratio. And so that's another 1 byte value, again assigned to every MIL-relevant DTC. And it is basically just storing what the ratio was for the last batch of 255, trips, if you will. Next slide, please. Okay, pause criteria. So this is it's pretty simple. Rather than requiring that pausing take place on a monitor by monitor basis when there's some malfunction that disables just that particular monitor. So that can get a little complicated. We have a very simple proposal here, which is aligned with the on-road SMAD. So basically that all counters on a DEC ECU will pause for the rest of an ignition cycle if a MIL-relevant pending or confirmed fault code is present on that DEC ECU. So just trying to keep it simple there. For the general denominator, so we need to define a general denominator to support the monitor activity data. And so what is that? Okay, the general denominator is a measure of the number of times an engine has been operated such that certain criteria are satisfied within an ignition cycle. We haven't yet specified what that's going to look like for the off-road context. So this is also to be determined, but it's something like this example, 10 minutes of engine runtime with at least 5 minutes over 8% rated power. That's one way that the general denominator could be defined. You basically want to create a definition that gives enough engine activity so that not all monitors can run, but a fair number could run, basically. Next slide, please. Actually, that's my last slide, I think. Yeah, that's my last slide. Okay, so I'm gonna now hand it over to Yong, and he's gonna get into the diagnostic side of things. Thank you.
Hello. Good morning, good afternoon, and thanks, Paul. And I will continue the OBD OROD system diagnostic requirement here. Before I go, let me emphasize the OROBD system again. I think my manager Jason had already mentioned these things at the beginning of this presentation. So any kind of Tier 5 engines, if you equipped with SCR system, then you will go to the pathway with OBMD pathway. And if you don't equip with SCR system, and you will go to the OBD pathway. And I will talk in the diagnostic requirement under the OBMD. And my coworker and Shamna will talk in the OBD requirement. For the OBMD, actually, they have a few components here, and we will see the standardization and the NOx monitoring and the limited diagnostic. Next slide, please. For the OBMD proposal overview, which I mentioned earlier, they have a certain kind of components under this OBMD. The standardization requirements, I think my coworker Paul Henrik already gave the very detailed description for this kind of requirements. And I will be focused on the OBMD diagnostic requirement here. For the OBMD diagnostic requirements, they have the few important elements here. The first one is the OBM NOx emission threshold monitor. Then we have the PM filter emission threshold monitor as well. And the tailpipe NOx sensor performance monitors, and the PM sensor diagnostics requirements. And the last part of this OBMD diagnostic requirement will be the comprehensive component monitor, we usually call the CCM. Next slide, please. Let me talk in the first important part of the diagnostic requirements, which is the OBM NOx emission threshold monitor. As we mentioned in the earlier workshops and the meetings with manufacturers, and they will have a new concept for OBMD, which is use the NOx sensor to determine the system NOx compliance. So here we call the OBM NOx emission threshold monitor. For this monitor, we set up the fixed threshold based on 3 bin mol, bin B, and bin C. And here's a table. We list the OBM NOx emission threshold values. For any kind of power between 56 kilowatt and 560 kilowatt. And the OBM NOx emission threshold monitor threshold will be set for bin B is 0.6 gram kilowatt hour. For the bin C, it's set same as the bin B, will be 6.6 gram kilowatt hour. For any kind of engines larger than 560 kilowatts, there was no requirement for the bin B, and there was the emission threshold will be subject to 1.2 gram kilowatt hour for bin C. Next slide, please. I will talk a little bit more detail about the OBM NOx emission threshold monitor. So the monitor we're using the same 3 bin mol window states, which is installed in the OR real bins. And you were tracking the bin B and the bin C windows separately. So this means that they will have 2 independent monitors for bin B and bin C. And you collect all the data, and the decision will be made to be compliant or not compliant with the emission threshold when 2,400 windows are accumulated. And for this OBM NOx emission threshold monitor, and the fault code handling will have pretty much the same as we mentioned earlier. And the 1 fail will be set to the pending code. 2 fails will be conformed the codes, and the mule will be turned on. There was certain kind of the protocol how you heard this kind of fault codes, and we're still under the consideration. This OBM NOx emission threshold monitors, the monitoring only pauses for certain critical malfunctions. I give one example. For instance, the mule is on for tailpipe NOx sensor fault. Next slide. The other important part for the OBM diagnostic requirements is the tailpipe NOx sensor diagnostic. As I mentioned earlier, we will be using the tailpipe NOx sensor to perform the OBM. So the performance about the tailpipe NOx sensor, it's a key point for the OBM monitors. So this performance monitor for the OBM is mainly for the NOx measurement errors. So it has to detect the malfunction before the sensor fails or deterioration. For instance, like the offset or gain causes measurement error to exceed a certain kind of values. And we're still under the consideration about what kind of value should set for this kind of measurement errors. The second part for the tailpipe NOx sensor diagnostic is circuit faults. That's very straightforward and very evidently, and it should be required. The last part for the tailpipe NOx sensor diagnostics is the NOx sensor measurement readiness. What this means that you should detect when the NOx sensor is improperly offline. Because NOx sensor online and provide the data for the OBM is critical, and unreasonable long offline time will be set the flag for the NOx sensor inactivity and will be defeats the OBM purpose. Next slide. The other important part for the OBMD diagnostic requirement is the PM filtration performance diagnostic. And I will be talking here pretty briefly because my coworker Shomna will be talking this part as well. And the PM filter diagnostic will be, as we stated here, it will be identical for both OBMD and OBD proposals. Here I just talking about the minifunction criteria, and CARB step proposing the same emission threshold level as on-road heavy-duty OBD, which set is 0.04 gram kWh. There was a fact which I want to emphasize here, and currently on-road heavy-duty engine OEMs already meet this kind of requirement using resistant PM sensor Science 2016 model year for the similar threshold. Next slide, please. I will talk in the last part of the OBMD diagnostic requirement, which is Comprehensive Component Monitor, CCM. And this will be required quite a lot of monitors. And as we state here, all inputs and outputs associated with major monitors, ACDs, OBM, or OR rear tracking must be monitored. For the input components, circuit continuity, off the range, and the full nationality requirement. For the output components, circuit continuity and functionality monitors. For all DEC ECU inputs and outputs, and not described above, also must be monitored for. Circuit continuity, out of range, and limited nationality for input components. And the circuit continuity and the functionality for the output components. Next slide. Here I will repeat and kind of emphasize the OBM fault code and MU requirement here again. For the OBM MU emulation required only during the warranty period. This is OBM NOx MU emulation. And OBM fault code storage protocol applies over the engine actual life. The OBM fault code and the MU are not tied to the inducement. And the MU and the fault code associated with other diagnostics under the OBMD apply to our engine actual life. That's complete my OBMD diagnostic requirement. I will be passing the presentation to my coworker, Shomna. Shomna, go ahead.
Thanks, John, and good morning, everybody. I'm going to continue with the OBD section of our proposal. As Jason mentioned earlier and Young emphasized, any Tier 5 engine that is not equipped with SCR falls under OBD requirements. For OBD requirements, we are proposing a standardization requirements, which Paul explained in detail, and diagnostic requirements, in which we are proposing emission threshold diagnostic for PM filter, fuel system, and EGR. Also, we are proposing performance-based monitoring for select major components, which I'm going to explain in coming slides, and comprehensive component diagnostic, or CCM. In our current concept, major components that we selected for diagnostic requirements are PM filters, which we propose PM emission threshold of 0.04 gram per kilowatt hour, PM sensor and heater with monitoring capabilities such as voltage resistance, current response rate, and offset. And monitors must detect any malfunction that prevent detection of a threshold PM filter. Also for PM sensor and heater, we are proposing heater performance not within manufacturer's limits and circuit diagnostics. Another major component that is selected is EGR, or exhaust gas recirculation system, which we propose emission threshold of 2 times of emission standard for NMHC, CO, NOx, and PM. Except for smaller engines with 19 to 56 kilowatt, which we propose PM threshold of 0.04 gram per kilowatt hour. Other major components that we selected for OBD diagnostics are diesel oxidation catalyst, or DOC, if can't achieve exotherm to regenerate PM filter, and electronically controlled fuel systems. For electronically controlled fuel systems, we are proposing emission thresholds and feedback control. Regarding the emission thresholds, we are proposing 2 times of a standard for NMHC, CO, NOx, and PM, again, except for smaller engines with 19 to 56 kilowatts, which we propose PM thresholds of 0.04 gram per kilowatt hour. And that includes pressure control monitors, injection quantity, and injection timing. In terms of CCM requirements, we are proposing that all inputs and outputs associated with major monitors or AECD must be monitored for circuit continuity, out of range, and full rationality. For input components and for output components, circuit continuity and functionality. Again, we are proposing that all DIC ECU inputs and outputs not described above must be monitored for circuit continuity, out of range, and similar to OB&D, limited rationality in this case for input components, and for output components, circuit continuity and functionality. And to give you an example, for limited rationality, consider a stocking range sensor. I'm going to hand it over to Yang to continue with OR-OBD implementation elements.
Thanks, Shobna. And let me finish with this kind of part of the presentation for OBD and implementation element. All OBD system have the following few elements for the implementation. The first thing evidently is the OR-OBD certification. So all the application must be submitted to the CARB E5 system, and will be lots of details will follow by that, but we just give you a statement for that. Second thing is that the OR-OBD system demonstration requirements. And we know that the OBD system, when you submit the application, they always have the demonstration engine. Demonstrates OBD system always required. For the demonstrate engines, and if you go to the OBMD pathway, and we only require you for the tailpipe NOx sensor agent full use time plus the degraded engine and after treatment. That's the big release for the demonstrated engine in comparison to the on-road OBD system. And for the OBD path, so you can align with tailpipe certification durability requirements. And regarding the numbers of demonstration engines per year, and we're still under the consideration, and we'll possibly release this information later. Under the demonstration requirements, there was one very special one, which is pretty similar as we have the on-road heavy-duty OBD for the real things, which is demonstrating the OBD system tailpipe NOx mass versus the lab results. We proposed to require a certain kind of the values within certain kind of values of difference for the tailpipe NOx mass versus the lab results of NRTC. And we're still working on this kind of details, and we'll be giving the final number for that. This is just our proposal. Next slide. And for the OROBD demonstration requirements, and we will be required manufacturers to demonstrate limited diagnostic during the certification period. For the OBMD pathway, and there were several emission threshold testing required, which including OBM, NOx monitors, DPF monitors, and NOx sense monitors. We also required a certain kind of performance monitors, which doesn't subject to the emissions testing, which is very similar to our on-road J2 or L2 requirements. And this performance monitors includes the NOx sensor, PM sensors, and the CCM. For the OBD pathway, and the emission threshold testing required, including DPF, fuel system, and EGR. Similar, the performance monitor will be required, the PM sensors, DOC, and the CCM. Next slide, please. After the certification, we usually have the one activity will be required, which is called post-certification. And we usually call the production engine or vehicle evaluation. And this is we only will require the verification of the standardized requirements, very similar to our on-road OBD requirements, PEV, J1 or L1. For the other important implementation elements, which is deficiency and fines, this kind of requirement will be pretty similar to our on-road OBD requirements and allowance. And will be follow up with the details in later. There was third kind of conditions will be totally prohibited certification, which we usually call a no third condition. The first condition is that any issues that advise impact in use program. For instance, missing parameters for PAMS testing, in-use screen, and standardized connectors, 3B MOS implementation errors. All these conditions will be put in the no third condition. Second, when you demonstrate the emission thresholds, for the first 3 years, which is the stage 2 for the implementation will be mentioned later, if you over 3 times diagnostic emission thresholds, then you will be subject to the no thirds conditions. After the three years, and the emission threshold will be where this no third condition will be slightly dropped from the threshold to 2 times the diagnostic emission threshold. And the third condition is that any kind of emission threshold model is done wrong. Next slide, please. OROBD implementation schedules will be including 2 stages. The first stage is the phase 1 standardization begins as early as 2029 model year, and the stage 2 will be including the phase 1 plus phase 2 standardization, OBMD pathway or OBD pathway, and PEVE, and begins as early as 2032 model year. CarbStep developed this implementation schedules actually provide sufficient lead time and stabilization time. For the lead time, and it will be aligned with Tier 5 emission standard, and the chart readings actually have additional lead time for the stage 2. We will see the diagram in next slides. For the stability and for the PERD readings, and we will see that at least 3 to 4 years stability time for that. For the chart readings, actually, we give even more stability time, which is 6 to 7 years. And we also provide a grace period, and the deficient fines will delay the 4th year of the stage 2 for the parent engines. And for the chart and for the parent and chart engine definitions, we're still working on that, and will be provided detail later. Next slide, please. Here is the diagram for the visualize about the implementation schedules. And we provide the parent engine implementation plan and the child engine implementation plan in the 2 diagrams. The up one is the parent engine implementation plan. And let me explain a little bit about this diagram. For instance, like we just pick one of the power categories. Let's see, 56 kilowatt, between 56 kilowatt and 130 kilowatts. And the phase one requirement will start at 2031 model year and last for 3 years. And then you will require for the either OBD or OBMD requirements, subject to if your engines with or without SCR, and along with the phase one and the phase two standardization requirements. Last for 3 years. And our deficiency and our fine will begin to start from 2037 model year, which all these diagrams actually describe the material and the contents I presented the last slides. For the chart, engine is similar. Let's see the 56 kilowatt, between 56 kilowatt and 130 kilowatt. You will see the chart readings have very long time implementation for the phase one. It starts from 2031 model year until to 2036 model years. But be notable that your implementation for the phase two standardizations along with the phase one and the OBMD and the PV is you only have 1 year lead time, 1 year stipulated time for that. And from 2030 model years, the division 5 will begin. So that's complete the implementation schedule. The next slide. And here is the contact information for the OROBD system and the rulemaking. And you can directly contact the Jason Wang, who is the manager of the OBD program development sections. And here lists his email and phone number. You also can contact the Mike Rickoffers, and who is the chief of our branch chief. And the email, the phone is provided as well. If you have any questions, we're willing to answer. Thank you, everyone. This completes our OBD system presentation. Thank you, everyone.
Okay, let's go to our Q&A. Here, I think the first OBD question is from Chad Grugel on OBD slide number 5. CARB states that OBD standardization on all engines with ECUs regardless of power category, and standardization includes off-road reel for all SCR-equipped engines. There is no off-road IUT program or LLC engines for less than 56 kilowatts and greater than 560 kilowatts. There are, nonetheless, off-cycle emission standards for engines less than 56 kilowatts and greater than 560 kilowatts. With or without SCR? Question mark. If yes, how will the bin B standard be determined without an LLC standard?
Yeah, Christian, I think I volunteered for this answer. Yeah, basically, I think your question, Chad, is that there is no bin B requirement for less than 56 kilowatt and greater than 560 kilowatt power categories. I think that's your question. So I just wanted to, and why there's like a data collection requirement for bin B in off-road reel. The answer is that the bin collection data is just that. It's just for collecting data. There is no requirement to meet bin B for compliance. It's there is no enforcement of it. It's just for data collection so that we can take a look to see like what the emission levels are. Hope that answers your question.
Thanks, Jason. The next question comes from George Lin. If an engine has NOx sensors but no SCR, can it certify with OBM instead of OBD? If not, why?
Yeah, right now, like I've mentioned before, George, is that we try to simplify our OBD requirements, and so we kind of tied it to SCR, which normally would have NOx sensors. We didn't consider an option where an engine manufacturer would include NOx sensors, but not an SCR system. I don't think our current proposal really considers that, but we could think about it to see if there's really, this is really something that someone would consider, but right now it doesn't.
Thank you. Our next question is from George again. If an equipment manufacturer places the DLC in a non-suitable location based on ARB's opinion, whose responsibility is that to correct?
Okay. As you probably saw toward the end of our presentation, there's like an implementation requirements, and I'm not too sure if anyone's controlling the slides, but we have some grace period for implementation requirements. In other words, like free deficiencies. It would be nice if we could share that presentation, but that last slide with the implementation, I don't know if
Shabnam, can you share the last slide?
Sure, give me a second.
Yeah, not the last one, the second to last one with the implementation schedule. So as you can see, all of that orange area is where compliance would start. So, but like the gray lines that are vertical, that's when OBD implementation first starts for phase 1. So there's a lot of grace period before we would call something deficient with fines. We would during the phase 1 implementation for your DLC question, we would write a deficiency and just note it, and we would expect you to like fix it within a reasonable amount of time. But right, that's what the expectation is. So the manufacturer will be required for compliance, and some of those details were not like provided and hashed out yet, but that's the plan.
Thank you. Our next question is from Chad Google on OBD slide number 11. How should phase 1 beginning manage faults on NOx sensors and or SCR outlet temperature?
Okay. Yeah, I'll let Shabnam go to the phase 1, slide 11.
I'm sorry, sometimes I experience some delays.
No worries. Okay. I thought that was it. Was that slide 11?
You mentioned 11, so.
Yeah. So I think I could start talking while you're scrolling. Looks like it went to data tracking. I think Paul Hendrick answered this question earlier this morning, but I'll just reiterate it. So for phase 1, there is no diagnostic requirements that we're requiring, but there would be a manufacturer or sensor supply diagnostics would apply here. So if they might be like simple circuit checks or whatever is included by the manufacturer on the NOx sensor. That if there's a failure for those diagnostics, that would pause the binning.
Thank you. Next question is from John Reich. Can you confirm or clarify if option 4 is chosen by a manufacturer to meet Tier 5 final at the earlier dates that the Tier 4 final engines that are sold into California in model year 2029 and beyond are exempt from OBM and OBD requirements and other interim Tier 5 requirements such as DAC, DF, or extend the useful life and warranty? Initial thought is that the provision would be allowed using carryover Tier 4 final data from previous model year certifications until Tier 5 final implementation.
Yeah, I'm not too sure I totally understand the question, but if your question is if a manufacturer chooses option 4, are they required to meet our OBD requirements? The answer is no. Our requirements are only triggered with Tier 5 implementation.
Thank you. Our next question is from Steve Barry. It might be for the in-use team, but for the in-use testing off-road real screening, what is the engine family pass-fail criteria regarding DPF fault tracking?
Yeah, I will answer that. So Steve, if you can go to our slide deck, slide deck number 5, it's slide 43. I can share my screen with you. Just give me a second. Can you see the screen now?
Yes.
Yeah. So for the PM, this is what percentage of engines with DPF fault code would trigger the PAMS testing. For a large sales volume engine family, that's with more than 200 engines. 5% of total sales have DPF fault code that will trigger the PAMS testing. For small sales volume engine families, that's between 50 to 200. That's 5% of total sales or 8, whichever is greater. And for very small sales volume engine family, that's smaller than 50. It's 5% of total sales or 2 engines, whichever is greater.
And just to clarify, we don't have the DEX numbered as number 5 on the website. So Steve, you need to go to the in-use programs deck that's on our website.
Yeah.
Thanks, Yi.
Thank you. Our next question is from Chad Grugel on OBD slide number 13. Can CARB provide examples of DEC ECUs that would be introduced in phase 2 that would not be required in phase 1?
Yeah. Hey, Christian, can you tell me where? Oh, okay, I see it now.
Is 10:44 a.m.?
10:44 a.m. Yeah, I was trying to look at the new Q&A coming at the same time, and I now have to go back to this. Let's see. Let me read this. Just one second. Oh, okay. I think Sheldon has the slide here. Yeah, for right now, I can't think of any differences in as far as like the controllers that would be in phase 1 versus phase 2. We just had to provide a different definition here because if you notice on this slide for phase 1, we described it as all ECUs associated with engine controls, emission controls, or after treatment controls must support Cal ID CBN and NCBN. For phase 2, we include that also, but we also added deck ECUs, which are is defined below, and is any ECU that has a primary control over any major monitor or rationality fault diagnostic or functional check for any input or output component. So we just added the deck ECUs because we excluded diagnostics for phase 1 because it doesn't have any diagnostic requirements governed by us or required by us in our proposal. But for phase 2, that's when the diagnostic requirements come in. So that's why there's that addition. Now, if you put your diagnostics in your original ECU in phase 1, then there would be no difference. But if you put it in a different standalone one, then there might be a difference. Hope that answers your question.
Thank you. Our next question is from Brandon Kiss. Why on slide 11, the off-road OBD diagnostics, is there a differentiation in SCR temperature above the functional range? The primary info needed is whether or not the SCR is above or below the 200 to 250 range. Why is it required to provide the 250 to 400 C bin or even the greater than 400 Celsius bin?
Yeah, I think this question was answered earlier by Paul Hendrick, but I'll reiterate it. Or maybe it was answered yesterday. For this binning structure for Rio, we included these temperature ranges because just to give to define how to bin in the on-road sector, we had instead of SCR outlet temperature, we had vehicle speed, but that doesn't make sense here. So since SCR temperature, it has a impact on SCR efficiency, we felt that was a good parameter to choose for binning. So the temperatures outside where SCR is most efficient, that kind of, we would expect that NOx rates would be higher, and that's what we would expect. So it's more to give some context to the data, to make sure the data is what we expect, and if there's any outliers or there's some weird behavior, we might go back to the manufacturer and ask, like, hey, there's some weird things going on here, any ideas, and so forth. So it's just kind of like it just gives some context to the data.
Thank you. Our next question is from Victor Siniz. What OBD monitors will be mandated?
Yeah, I think that's was described in the presentation. I don't know if Victor is asking about our OBD requirements, but if he has, then Shabnam, can you go to the OBD slide that you presented earlier? Yeah, so on this slide here, it shows that the diagnostic requirements are PM filter emission threshold, some performance-based monitors for select major components, and comprehensive component diagnostics. And then can you go to the next slide? So provide some details of some of the other requirements for, so the PM filter is an emission threshold, diagnostic PM sensor and heater. They're more like functional checks, but with these stipulation here. And then there's EGR requirement with emission threshold, except for it shows 2 times emission thresholds except for the 19 to 56 kilowatt engines with a different PM threshold. So I hope that answers your question.
Thank you. The next question is from Eric Swenson. My suggestion for intermin use, example, stationary backup power generation applications, is to avoid the sticky mill. Inducements for this example application would not be recommended either, not unlike fire and rescue on-road applications today.
Okay, this doesn't seem like a question, it's more about a comment. I'll just ask Eric if he has like good suggestions for how to conduct the fault handling. Just contact us. As you could probably, in the presentation, we mentioned that the fault handling is TBD. We haven't decided yet. We provided some ideas like one fault for pending, two faults going to confirm, yeah, in mill, but like how to heal, we haven't really decided what to do. So please contact us if you have some suggestions.
Our next question is, can CARB confirm what is disabled after the warranty period? OBM, NOx mill, or the OBM NOx monitor, or both?
Yeah, let me answer this question. So I think if you go through all the presentation there, we're pretty clear indicated that after the warranty period, it's only the OBM NOx mill will be disabled. OBM NOx monitor will be still around, fault code will be there. So yeah, that's the answer. Hopefully clarify that.
Thanks, Hyung. Eric Swanson has another question. May the number of MAW bins be harmonized with on-road heavy-duty engines?
I will answer this question. So for the on-road, EPA CTP is considering a two-bin moving average window method. But for off-road, we are proposing a three-bin moving average window method because we feel this method is more suitable for off-road applications. We did our data analysis on the bin number distribution from real-world activity data. We noticed that for some applications, most of the windows would be in bin B, in either bin B or bin C. The low load bin or the high load bin, and we understand, especially for an application that has a lot of low load operations, it is more difficult for them to meet a 2B more standard. So we feel the 3B more is more suitable for off-road because of the diversity in the off-road applications. I hope that answers your question. But we'd also like your comments about this topic. We will consider your comments in our final in our proposed regulation.
Thank you. Eric Swenson has another question. About how many monitors are anticipated for MED? Extending DM7 SPN based on using DM4 would be limited to 442 SPs. I believe Jason wanted to comment on this.
Oh, I'm sorry. I was trying to look at the new questions, and I was hoping I'd get a break for a little bit. Let me see. Wait,
no
what
worries.
time?
This is at 11:02 from Eric Swenson.
Okay. Maybe, at this time, maybe I'll have some of my staff, they could peruse some of the new questions and claim them if they can answer it. Because let's see. Okay, about how many monitors? Oh, okay. So that's a good question, Eric. We don't really know or how many monitors to expect. We haven't seen, I suppose, even if we look at current off-road like Tier 4, well, there's no requirements yet as far as OBD for off-road, so we can even look at the current system. So we have no idea, not until there's some ideas of exactly what emission controls and sensors would be on on these engines, but it would basically encompass all of those that an engine manufacturer might consider to meet the Tier 5 requirements. So I can't really give you a firm answer right now, but I'm assuming at least like maybe like 100 or so. But I don't have a really good answer for you right now.
Thanks, Jason. Our next question is the minimum monitoring frequency on certification cycles or for engines in use? If considering in use, will it be based on an engine family?
Yeah, right now, you're talking about the MAD requirement. And right now, we haven't decided on a minimum requirement, but it would be in-use requirements that we're considering right now. At least that's the idea, because for the 56 to 560 kilowatt power categories, which are in the in-use testing program screening program, that it encompasses those power categories. And I think one of the requirements is to get the OBD snapshots of all of the different modes. So we would expect to get the information there as far as the monitoring frequency. So that would all be in use vehicles, and from that data, it would be probably tied to a specific calibration. So it'd be engine family rating related. So I think that's how we would consider its performance. It would be based upon the calibration, which most likely would be engine family rating down to that level.
Right. Our next question is from Chad Grugel on OBD slide 19. What is the basis for the decision to implement MAD over IUMPR concept? What are the pros and cons from implementing SMAD on-road?
Yeah, I'll take that one. So one of the themes in the off-road OBD proposal is a simplification relative to on-road OBD. And so in on-road, we have IUMPR, which has a lot of very particular rules and requirements for how incrementation is done and when it is paused, and it's more involved. And we thought that by going to the simpler MAD methodology, it would make the overall OROBD system a bit easier to implement and a little bit more clear. And so that's the main driver. One of the big pros of MAD or SMAD is that it covers all mil relevant monitors. So IUMPR, it covers a specified subset of like major monitors, and they're kind of grouped in certain ways. So it doesn't give visibility on what all of the monitors are doing, like how often they are making decisions. So MAD and SMAD, they have the simplifications I was referring to, and also have a broader scope of coverage in terms of which monitors ultimately will get some feedback on as far as how often they are actually running.
Thanks, Paul. Our next question comes at 11:07. If the greater than 560 kilowatt is equipped with SCR, it needs OBMD. If not equipped with the SCR, does it need a OBD instead? I think Jason wanted to respond to that one.
Okay, sorry, Christian. What time? Let me scroll
That was
up.
at 11:07.
11:07. Oh, the anonymous attendee?
That's right.
Okay, let me see. Okay, yeah, that's correct. It's our proposal is simplified to just like be dependent upon like if an SCR is utilized as part of the submission controls. So if you use an SCR for greater than 560 kilowatts, it has to go to OBMD pathway. If not, it goes to OBD. It's independent upon power categories. It's all just dependent upon the mission control.
Thank you. The next question at 11:10 is from Chad Google. OBMD, slide 24. Why does bin B have the same OBM threshold as bin C? Bin B is based on lower load where the emission standards are set to be higher.
Yeah, I think when setting these emission thresholds, we consider like what is being done as far as on-road OBD, what threshold levels are being required, and we have not proposed anything more stringent than what's on heavy duty OBD. So while the thresholds are different, we felt that they kind of warranted the same level. We didn't want it like too tight, and unless Chad thinks otherwise, but like that's what we were kind of thinking. I don't know if any of my staff want to add anything more, but that's what we considered.
Yeah, this is Yong. I can chime in a little bit, and we have some kind of discussion in intern the OBD the group, the staff, and we actually the Bing B as Chad pointed, the Bing B is a slightly higher standard than Bing C. Is 0.06 versus 0.04, and for setting the OBD threshold size, and we just want to simplify that and put the 0.6, which is 10 times as the Bing B and 15 times as Bing C. That's pretty much our thinking point behind that. But if Chad think that's we should be like set more stringent for the Bing C, we're pretty much welcome this kind of idea.
Thank you. Our next question comes from George Lin at 11:11 a.m. On your table on page 24 for the OBMD NOx thresholds for greater than 560 kilowatts, the 1.2 gram per kilowatt hour threshold, I'm assuming that this is for gensets. Would this also be the threshold for non-gensets?
Okay, let me answer this again. It's basically the same answer I just answered right now, or just previously. Our requirements is just based upon your emission control solution. If you have an SCR system, you have to comply with OBMD. We don't specify based upon power categories or like 560 non-gen sets versus 560 gen sets. It's strictly the emission control solution.
Thank you. At 11:12, Chad Google asks, on OBMD slide 25, explain why 2400 Windows is sufficient for an OBM fault decision. Is that a combination of B and C windows or separate?
Yeah, I'll comment on that one. So first of all, it is separate. So B and C, so you can think of it as like B and C having their own independent monitors, and then each one would require the 2,400 windows. And that choice comes from the in-use requirement. So for PEMS testing and screening, you need at least 2,400 windows before a determination is made in either of those bins. So that's it's basically an alignment with that.
Thank you, Paul. Our next question at 11:12. 1 failing pending code, 2 fails confirm code. Does this have anything to do with number 1 driving cycles or 2 consecutive failures? I think Jason would like to comment on this.
Yeah, sorry, Christian. Can you tell me what time?
11:12.
11:12. Let's go. Yeah, I'm still checking for questions. If people stop asking new questions, I could maybe let's see. 11:12. Is it George Lin?
The anonymous at 11:12, the first one. There's like 3 at exactly 11:12, but
there's 3 at 11:12. Oh, okay.
The 1 failing pending code.
Okay, 1 failing pending code. Okay, 1 failing pending code, 2 fails, confirmed fault code. Does this has anything to do with driving cycles, consecutive failures? Oh, okay. So, right now it's we're still trying to determine the fault handling. Right. We put a suggestion, maybe one fail as a pending code and 2 fails a confirmed code. We haven't really said anything more than that, but it would make sense to have at least that part be similar to on-road OBD in that it would be consecutive. But we haven't firmed out the details yet. But that's like some of our ideas now. So if there's any suggestions about what exactly to do for fault handling, you can provide input to us, but that's what we were kind of thinking of.
Thank you. Our next question, can CARB confirm that diagnostics of the NOx sensor and SCR outlet temperature are not required until phase 2?
Yes, that is correct. We don't have any mandatory diagnostic requirements for the NOx sensor or SCR outlet temperature sensor or anything else until phase 2. So I think this question is kind of touching on the fact that these are important inputs for real in phase 1, and so that's why we would envision that if a manufacturer has their own diagnostics, so not that we require, just that the manufacturer supports, for example, with the tailpipe NOx sensor, and you detect a malfunction, that qualify as a means to pause real tracking. But anyway, just yes, no diagnostic requirements until phase 2. Thank you.
Thank you. Our next question comes from George Lin at 11:12, same as the previous question, but on slide 27 for PM. What is required for greater than 560 kilowatts in terms of OBMD PM threshold for gensets and non-gensets?
Yeah, I think as mentioned earlier, as Jason, to this kind of questions, because we're pretty much all the OBD, OBMD requirements based on the emission control solutions. For instance, like if you have the PM DPF was installed larger than 560 kilowatt things, regardless what kind of general sense or no general sense, you are subject to the same kind of threshold. So I hopefully this answers this questions. Yeah. If you without the DPF, you don't need to be put the monitor here because this is particularly for PM filtration monitor. Thank you.
Thank you. Our next question at 11:15 is from Chad Grugel on OBD slide number 28. Can CARB explain the difference between full rationality and limited rationality?
Okay. Yeah, slide 28. Yeah, okay. Yeah, basically what we mean by full rationality, Chad, is that that's kind of like more on the similar to what's required on road heavy duty OBD. So double-sided rationality to the extent feasible. And limited rationality, what we're considering is something less calibration intensive. So maybe something like simpler, like a stuck check. That's what we're kind of thinking of. So hope that answers your question.
Thank you. Our next question at 11:15. Is there any requirement for boost monitoring?
Simple answer is no. What we list in the presentation is what is required. Boost monitoring would only be in the comprehensive component monitoring requirement. So no for like emission threshold, but like yes for comprehensive component monitoring.
The next question is on the DOC monitor for OBD. There is no monitoring threshold regarding NMHC or CO, but only total functional failure monitor. Is that right?
Let's see. That's for OBD. Shabnam, can you go to our OBD slide? I think we just said the threshold is for regeneration purposes, or what did we say? I forget. Cannot achieve exotherm to regenerate. So that's a monitoring threshold. That's strictly the criteria. It's not an emission threshold. So let's move on.
Our next question: why DOC monitoring is not mentioned for OBMD, only for OBD?
Yeah, right now for OBMD, we were just limiting monitoring to certain like critical emission control components, and we didn't think DOC was like a big one. We were concentrating on NOx and PM, and how Tier 5 was structured was like it seemed like a lot of the categories that had stringent SCR or stringent NOx requirements would push manufacturers to including an SCR system, which would force it to the OBMD category, but it also has stringent PM requirements, which would push it to requiring DPFs. So because of that reasoning, we did not include DOC. We figured if we kind of concentrated on the DOC, the DPF, and the SCR monitoring requirements, that was good enough in our thinking. And if my staff has anything more to add, please feel free to interject.
Thank you. Our next question comes from Rob Weiss. For the J1/L1, what product categories will be needed in J1699-5?
Hi, Robert. This is Yung. I tried to answer this question. So actually, for the J1 and L1 for the testing, which is PV of J1L. Actually, if you noticed earlier, we talking about standardization. Actually, for the off-road engines, they either subject to the 79-2 or 1939. So if it's subject to the 197-2 protocol, so we'll be automatically go to the 69-5. So I hopefully answer these questions. Yeah.
Thank you. Our next question is, what is the difference between parent program and child program? Please clarify.
Yeah, I think if I correctly understand your question, you're talking about the parents and the child engine implementation. Yeah, the first thing is we are still working on define the parent and the child engine group. The second thing is that there was not very much difference for the OBD OROBD system requirements. Only the implementation will be different. So in Gem2C, the child engine gives the more time to develop the OBD system. That is the only difference between there. Thank you.
Thanks. Next question is from Eric Swenson at 11:31. By the time standardization is required, automotive Ethernet is anticipated to be prominent. May DUIP ISO 13400 be considered?
Yeah, Eric, we haven't really considered that yet. I think that was in the recent ZEV proposal to allow it. So we haven't really considered it, but if this is something that manufacturers would like, and enough of them do want to use DOIP, we could consider it. We'll take it back. But if Eric has more like supporting details on why we should support it, please contact us.
Thank you. The next question is from Brendan Sherry. For the certification on slide 35, are we to take performance monitors to mean full PVE of all monitors, or is this intended to be a smaller subset of diagnostics?
Yeah, as we stated in the presentation, actually, this is kind of the smaller subset of the diagnostics. It's not like totally full PVE things. And but we'll be give more detailed information later. Thank you.
Thanks. This is a question regarding slide 38. What does PEV stand for?
It's a mean production engine or vehicle evaluation testing. So it's pretty standard for that, which is the J1L1, the verification for standardization requirements verification. So yeah. And I think there was the other question on the 1135 asked for that. I think pretty much the same answer for that one.
Okay.
Thank you.
Thank you. The next question at 1134 is, how about the applicability for the mechanical controlled engine? The applicability of the original off-road OBD concept was for 56 to 560 kilowatt category.
Yeah, Christian. I just want to state that our OBD requirements does not comprehend mechanically controlled engines, so they're not in our proposal. Right now, we figured like if you can meet the Tier 5 emission standard requirements without having electronically controlled engines, then we're not going to require you to to be part of OR OBD.
Okay. George Lynn asks at 11:36. My question was about the DLC, not the DOC. The question is specifically about the connector location. What happens if the connector is not in the correct location? What does ARB go after?
Yeah, I thought I had answered the question earlier, and I thought I said DLC, not DOC, but if I did misspeak, I apologize. The answer is the same. The implementation period with free deficiencies rather long, we would write the manufacturer up for not complying with the requirements, and we would expect a resolution to fix it within a reasonable amount of time. So whether it's DOC, or other requirements that are in our regulation or proposal, right now, that's what would happen. You're not compliant, you get some free deficiencies. So it's not emission control. It could be standardization. It could be mill. It could be whatever. But that's what we're proposing right now.
Just to clarify Christian's question, I think Christian read it as what does ARB go after, but the question says who does ARB go after? And I think your response is the engine manufacturer, correct, Jason?
Yes.
Okay.
It's the engine manufacturer, whoever submits the application, let me put it this way. Whoever is in charge of the OR OBD application, we would go after that. If somehow the vehicle or the equipment manufacturer decides to take responsibility for the OR OBD system, then it would be that. So it's whoever submits the application and takes responsibility. Most times in the on-road sector, that's the engine manufacturer.
Thanks, Jason.
Thank you. Our next question is, sorry, I'm a little confused. When do manufacturers need to submit OBMD or OBD data? Just once at time of certification or periodically need to submit these data?
Yeah, let me answer this question. The first thing is I think the question is not very clear to us. I assume that you are asked for the OBMD and OBD data for the demonstration data during the certification period. If that's true, yes, you just need to submit the during the certification the period time. But again, because maybe you're not familiar with all the certification process for the demonstration engines, and it's not every engine family will be picked as the demonstration engines. So this kind of the demonstration data don't need to be submitted by every application. So and also similar like that's every time the engine was picked as a demonstration engine during the certification, you need to do every application which is with the DDE engine was selected. But for the NOx sensor, it's similar things that you just need to do possibly the 1% of the engine family. You don't need to do the next time. I hope you answer these questions.
Thank you. Our next question is from John Reich on slide 34. For the full useful life, can the NOx sensor be part of the DAC aging to full useful life, or is it truly aged to full useful life, i.e. 8,000 hours for greater than 37 kilowatts?
I'm not sure that the question looks reading a little bit confused. The full use time is full use time, but you are asking how you really aging the NOx sensor, which I stand in the presentation. We request actually is only the NOx sensor to be aged the full use time. Yeah, I think still under the consideration lots of the possibility to aging to the full use time. I think the DAC actually aging the full use time as a part, because NOx sensor is a part, not the full with the engine. So it can be under the consideration for the approved the protocol. But you mean the truly edged full use time? Do you mean that you install the NOx sensor on the engine to edge it to the full use time? We didn't ask you do the engine, but if you want to do that way, that sounds pretty good to me. So I hope I ask this question.
Thanks, Young. Our next question is from George Lin. Was the alignment of load for A, B, and C bins and off-road reel intentionally misaligned for any reason, for a reason?
Yeah, so first of all, the 3-bin MAW bins, A, B, and C, of course, were in real, we're following the definitions developed that Yitan described. And for the bins 1 through 13, yes, they do have different load windows. And those load windows give us another perspective on the data. So rather than giving us the same perspective on the data and the in-use experience, we're getting another perspective. So I think that, and actually that also happens to align with the on-road windows as well.
I also want to add to that. So for the in-use screening bins, those are based on the 300 moving average windows. So yeah, as Paul mentioned, this is a totally different perspective. So we do not expect the 1 Hertz bins will be aligned with the in-use bins.
Thank you. Let's see. I just want to note there's some questions related to the in-use testing. We're going to hold on to these questions for the open session, but focus on the OBD section right now. So our next OBD question is, are the OBD and OBMD requirements applicable to hybrids?
Yeah, we haven't specifically mentioned hybrids, but we're thinking it would also apply to hybrids, and so a lot of the hybrid components would be considered under comprehensive component monitoring, similar to what's required in on-road OBD, on-road heavy-duty OBD.
Thank you. The next question is from Brendan Sherry. Has there been any consideration to requiring a too frequent regen diagnostic?
Yeah, it's good questions. Actually, I think the too frequent regen diagnostic might be needed, but we haven't specified during this kind of presentation, and we're still under the consideration for this part. It's pretty good question for that, and we will take back.
Thank you. Our next question is, would OBD require the engine to be electronic? Does anybody know of a small horsepower single-cylinder gensets that are electric? Most I know are mechanical and don't have any sort of complicated display screen. Would the MAL lights need to be touchscreen or just simple engine light, like a car?
Yeah, I think this question is a little bit. I don't know if the person posting this question is asking if OBD is required on mechanically controlled engines, and I think I already answered that previously. That our requirements, our current proposal does not include mechanically controlled engines. So I think that would exclude like this engine that the poster put here. So it wouldn't have to comply with our proposal.
Thank you. Next question is, can CARB clarify that the OBMD mill is only for high NOx reading associated with bins B and C and not other NOx system monitors? On slide 16, can CARB confirm the OBD mill and OBMD mill are physically the same mill?
Yeah, actually, the OBMD mill we're talking about, they have two types of the OBMD mills. First one is the OBMD NOx mill, and that was only for the high NOx reading. But they also have other kind of mills associated to, as we said, the PM sensor, PM filter filtration, and the CCM, other kind of things. So don't be confused with the mill, because mill can come from a variety of different fault codes. And so it's only OBMD NOx emission threshold monitor mill is associated with the bin B and the bin C with high NOx. And the slide 16, can CARB confirm the OBD mill and OBMD mill are physically same mill? Actually, this is kind of interesting questions, because if you come to be OBMD requirement and OBD requirement, there's different pathway there. So I'm not sure if it's same, but it can be, because they're subject to different kind of pathway for the OROBD system. And physically same, and it's not great term to say the physically same. It can be like you just use the different lights. You use the same light to set the OBD mill and OBMD mill. It's just if it's engine light, it can be same.
Thanks, Young. The next question is, what would be the NOx OBM threshold for greater than 560 kilowatts for non-gen sets, please? Since the 1.2, I presume, is for gen sets.
Okay. I think I answered this earlier today, but I think maybe it wasn't clear that our proposal is strictly based upon the mission control system that the OEM chooses. So it's not geared toward like specific power categories, like greater than 560 non-gen sets versus greater than 560 gen sets. It's strictly, you go the OBMD route, which would have the NOx threshold that's mentioned here, only if it includes an SCR system as part of its emission control solution.
Thanks, Jason. We have two hands raised. They've been patiently waiting, so maybe we should go to their questions. The first is Bridget Downs. I'm going to ask you to unmute, and you can unmute yourself and ask your question.
Sorry about that. That was an error.
Oh, no problem.
Next.
Okay. Sure. The next question, raised hand, is from George Lin. I'm going to ask you to unmute, then you can ask your question.
Is my audio coming through?
Yeah, I can hear you, George.
Okay. Yeah, so the question, I think I asked it twice and then someone else asked it, and it's in regards to the OBD thresholds for greater than 560. So if you go to slide 24, the question is this: the threshold on bin C for greater than 560 is proposed to be 1.2. The emissions threshold for greater than 560 is 3 grams NOx. I'm assuming you don't want us to turn on the light when it's 60% below the emissions threshold. And so the question is, what is the emissions threshold for greater than 560?
I thought I've answered this one before, but maybe I don't understand his question. It's
so here you have the threshold set at 1.2 grams, right?
Yes.
The emissions threshold is 3 grams. So this would say turn on the light at 1.2 grams.
Are you going to have an SCR system to meet the 3 grams?
Yes. Yes.
You will?
Yes, on some products.
Really? Okay. We didn't think that that people would be putting SCR systems for the looser emission standards for the mobile machines. You were talking about mobile machines, right?
Correct, correct.
All right. Well, we'll have to take that back because we really didn't think someone would put an SCR system in there. So
yeah, well, right now, I guess, you know, in the future, we don't know yet, right? But right now for tier 4 and greater than 560, there are both SCR and non-SCR equipment, right? That are non-gen sets.
Okay. We actually thought about this possibility, but like we thought that it would be very unlikely that someone would put an SCR system for a category that has a very loose NOx tier 5 standard. So we'll have to take that back.
Yeah,
so
and so that,
this
yeah. So then that's fine. That's fine. Yeah, and the same question applies for the PM threshold as well. So we're just wondering what the OBD threshold would be and what the PM threshold would be.
Okay.
For non-gen sets.
Yeah, the non-gen sets, if it has an SCR system, you know, what Caterpillar is proposing, having the SCR system for a looser emission category kind of throws our proposal for a loop. So we'll have to consider that anomaly. I don't know if others would be considering doing something like that, but we'll have to think of a solution there. So I don't have an answer for you right now, but we'll have to get back to you on that.
All right, thanks. Oh, and then the other question I had about the connector, it's so, you know, in the non-road space, it is far more diversified or there are many more equipment manufacturers. So are you saying that the engine manufacturer then has to really essentially like inspect each equipment that the engine is installed into to ensure that the connector is put in the right place?
No, it's I'm not going to tell you what to do, but like basically if somehow we turn to the slide where the standardization for the DOC, Shabnam, I don't know where exactly it is, but it's we don't have we have like some options there, so I'll just wait for it to get there.
Yeah, because we have, you know, as an engine OEM, we don't really have too much to do with where the equipment manufacturer mounts the diagnostic connector.
Yeah, I understand that. But like, when you sell an engine to the equipment manufacturer, you have build specs, right?
Yes. Yeah. There's some installation guides.
Yeah. So we would expect that the engine manufacturer provide those build specs and make it clear that what they should do. So here it says the DOC must be near the operator controls or engine power switch and not hidden behind the panel. If not technically feasible, you may request to apply a durable label to the exterior of equipment which indicates DOC location. So just tell us where it is, put a sticker on it, and the only stipulation that it's got to be easily accessible. But
who does the ask? Is it the equipment manufacturer or the engine manufacturer?
What do you mean, who does the ask?
Like, if not technically feasible, may request to apply. Who is the may request to apply?
Who will be submitting the application to us?
For the engine certification, it would be the engine manufacturer.
Then the engine manufacturer would submit that request.
So this is like, so you're expecting that afterwards, the engine manufacturer, this is, way past certification, right? The products are being sold, and then if there's an OEM or equipment manufacturer that installs this, then, and for some reason it doesn't meet ARB's requirement for the actual location, then they'd have to go back to the engine manufacturer. The engine manufacturer then submit the request ARB at that time.
Yeah, there would have to be some kind of communication between the two, because like we would say like, hey, it's if we find out like something's not being put in the right area, that in equipment that you guys provided the engines for, we would say like, hey, can you ensure that whoever you sell it to knows what they have to do? And we would, the thought now is perhaps, and it's not like firm yet, because that's why we're having a workshop, George, is that we would write a deficiency for it and say like, hey, it's this engine that is this equipment, which is the engine supplied by Caterpillar, let's say, does not meet the DOC requirements, but there'll be like 3 deficiencies. So we would expect that to be like addressed. And, that's the idea. And yeah. I think these questions came up during On-Road too, about like, manufacturers like Caterpillar would, and others would say that, hey, we don't control the equipment manufacturer. But I don't think there has been too many issues with that in the on-road sector, where that came back to bite us or to be an issue.
Well, so I'll suggest that on-road is, on-road has wheels. It's got a cab. It's got a steering wheel. It's got a throttle and a brake pedal, right? None of those things, other than having an engine, are given in off-road.
Yeah, I mean, like if it turns out to be an issue, we have a long implementation like time period. I think putting a label on it to say like, hey, it's here. I think that would probably suffice for now. We don't know what to expect, so that's why we're as far as like how problematic this could be. So
okay, all right. Well, yeah, we can have more discussion on it. No, thanks for your comments, though.
Just to add, I mean, you already have a implementation guide that goes out that's prepared for every engine model that covers cooling packages that people apply and how the fuel has to come to it, and a whole range, the length of the downpipe that's allowable between the engine and the after treatment system. And so, I mean, there are a lot of things that you're already dealing with in sort of how good is good enough within the leeway you allow your customer in installation. So it seems like a lot of the situations can be handled in that sort of manner. And then we have a path for the harder things or more ambiguous.
Yeah, I think we can state, I guess we would probably just ask ARB to make some sort of statement, and we would just communicate that statement verbatim. And so, yeah, so that's, I guess maybe that could be one takeaway for ARB in terms of providing those instructions, because I assume that it would be the same industry wide. But I think my question is really more about, okay, so some equipment manufacturer doesn't follow this guideline, or maybe it's like, because there's a subjective nature to this location, and what happens, like, really, who does ARB go after? And if it's the engine manufacturer, then it's the engine manufacturer. But it just seems like we're as an engine manufacturer, we're really not the responsible party for where the equipment manufacturer decides to put the connector.
I mean, you could make that same argument for length of downpipe and a bunch of these other things that you do control and with these kind of methods. So, yeah, I think it's a conversation as to how can we make sure that we can set up a system where we the largest number of equipment comes to a reasonable conclusion directly, and then be able to discuss the few remaining ones. But there should be a path to pretty reasonably locating these connectors on a large number of equipment.
Okay, thanks so much, George and Jason. I think what we'd like to do right now is, since it's basically 12:45, I suggest we take a 45-minute lunch break instead of the full hour, because we had so many OBD questions, excellent OBD questions, and we didn't quite finish them up, and I'd like us to be able to finish our questions. Plus, we have some other outstanding questions from other topics, and we still have 3 presentations to go. So let's come back to the workshop at 1:30, and that way everybody can get a bite and use the restroom, and we'll resume with the presentation on I think it's incentives. All right, thanks so much, and we'll see you at 1:30.
Bye. Jana, you shorted us 5 minutes.
It's it's 1:30.
Must be 1:35.
What?
And just according to the timing sheet you had, it was 1:35, but that's fine.
Oh yeah, no, we have to. Yeah, we had to.
So am I gonna just start with the presentation, or did you want to finish up the questions?
No, you're going to start with the presentation. Also, this is live.
Okay, let me pull it up.
Thanks, Jeff.
Do you want to wait a few minutes, or should I just?
It's already 1:31. I suggest that we just stay on schedule, since Christian had the note up that says we're returning at 1:30. I think we should start.
Sounds good.
Thanks, Jeff.
Hope everyone had a good lunch. We're on the back 9 here, so stay with us. We should get through this pretty successfully, answer questions, and be done for the day. This next slide presentation, it's on incentives and the equipment flexibility provisions that we'll be proposing in Tier 5. Basically, we've been proposing a concept to have an off-road hybrid powertrain credit program. I'm going to explain why we've decided not to pursue that any longer. In its place, we're going to adopt an off-road zero emission credit program. And I'm also going to explain something we haven't work grouped or workshop before, the new transition program for equipment manufacturers in California. And the 2 pictures here represent 2 things that I don't have. So I'll leave it at that. Okay, so why aren't we continuing to propose credits, a hybrid powertrain credits? Well, it was a very complicated process because Tier 5 is an engine-only regulation. We wanted something simple. We wanted something that would encourage the production and sale of hybrids while not over-crediting for the product. And that became a very, very difficult task to do in a simplistic approach, because we don't have standardized certification procedures for hybrids like there are for on-road. We don't have dedicated hybrid powertrain test cycles like they do in off-road or in on-road. In order to come up with those, it would have potentially put the timing of Tier 5 in jeopardy. We didn't want to do that. So although we're not pursuing hybrids, it's something that may be pursued in the future, or it may not be, depending on what the priorities of the agency are. And, you know, again, some of the other reasons, if not done properly, even a simplistic approach, there was always the risk that we could approve something that would ultimately end up creating more NOx emissions, you know, than we were trying to reduce with the hybrid technology. And also, everybody knows Executive Order N7920. It requires zero emission equipment to, you know, dominate, if not replace everything in the off-road by 2035, where feasible. So it's better to focus emissions on ZEVs, on pure electrics or pure zero emission powertrains. At least that was our thinking, than to have this transition of hybrids and then to ZEVs. Way to conserve resources. So what we're doing instead, and partly because of this, is that, and you've seen, if you were here yesterday, you saw me present on the later phase-in schedules, the interim schedules, and the delayed schedules for Tier 5. We're providing relief to the industry by proposing less stringent interim standards than we had previously. And we're also adopting a new credit program for pure ZEV, for zero emission powertrains. Something else I don't have. Okay, so what's special about ZEVs? Well, they're an incentive for cleaner propulsion technology. Obviously, there are no emissions from ZEVs, so that's one of the benefits. They also, by encouraging their production and sale now, kind of lays the groundwork for compliance with N7920. You know, it hopefully will encourage the production and speed things up towards that end. Also, it provides some compliance flexibility, much like an ABT program would. It could potentially extend Tier 5 phase-in periods. If you produce enough ZEVs, you produce enough credits, you can delay the introduction of Tier 5. And it could potentially be a possible alternative to Tier 5 for some power categories. We know that the less than 19 kilowatt power categories, there are already a lot of electrically powered pieces of equipment out there. You know, potentially this could, you know, replace the CI standards altogether if a manufacturer wanted to go that route, if they wanted to speed things up and only power their equipment with zero emission powertrains. You know, the engine manufacturer wouldn't have to build CI engines if they didn't want to. So it's a compliance flexibility tool. And, you know, again, like an ABT program, it helps to reduce costs. So instead of having to redesign engines all at once, you know, to meet Tier 5, you could potentially bring in at a slower pace because of the credits that you have. So the first thing we did was we came up with a definition of what a zero emission piece of equipment is. We basically utilized the definition in the off-road fleet rule in 13 CCR 2449, which also happens to be the same as what was adopted in our on-road heavy-duty omnibus rulemaking. We tweaked it very slightly. I think the on-road or the 2449 said vehicles only. We added here off-road vehicles or equipment. But other than that, it's the same. So the definition has been around. We didn't create it from scratch. And this is the definition that we're proposing to use for the zero emission credit program. So the program would be applicable to new equipment. This is not an in-use program that would, you know, pull pieces of equipment out of the fleet and replace them with in-use with zero emission powered in-use equipment, because Tier 5 is a new engine rule. It would apply to new equipment traditionally powered by off-road diesel engines. Now, what does that mean? That means that what we're looking to do primarily is supplant equipment with diesel engines and have them use electric engines or other zero emission powertrains. This is a little bit different. It's not just semantics, but it's a little bit different than, you know, certifying a zero emission piece of equipment you know, from the ground up and then adding it to a fleet. Now that would also be allowed under this program, but the priority is for it to replace diesel equipment that's already in use. Obviously, this would increase the turnover rate of diesel equipment to cleaner zero emission powered equipment. And it would help to minimize the potential for overcrediting from categories that are regulated to be zero emission powertrains. For example, SOAR, the small off-road gasoline engine regulations, recently came on board, requires zero emissions for most of the equipment less than 19 kilowatts. We wouldn't want to give credits for one of those pieces of equipment, that had a zero emission powertrain, because it was already required to meet zero emissions under the SOAR regulations, the SI regulations. We're looking at a forklift rulemaking right now. Same thing, it's for SI engines. Again, if we require that those become zero emissions, we don't really want to give credits. We don't want them coming into the off-road diesel regulation and asking for credits under the diesel program, because the SI regulation required them to go zero emission. So limiting this to, to the new equipment traditionally powered by off-road diesel engines, it helps to eliminate that. I won't call it gaming, but it's an undesired consequence, because we want this to generate additional emission benefits. Now, certain exclusions from the onset, the transport refrigeration units, there's a separate regulation for them. They've already required zero emission powertrains for TRUs, transport refrigeration units, used in trucks. They will also shortly be requiring transport refrigeration units for use in trailers. Again, we don't want to force, we don't want to give, well, it's kind of similar to what I presented yesterday, where we don't want to force standards on a category that's going to go zero emission. In this case, we don't want to give credits either to a category that's already going to be required to go zero emission. And similar with the cargo handling equipment. And also for, I suspect that, over the years, we'll see additional equipment mandatorily required to go zero emissions, especially in the off-road, because of N7920, which requires, everything to be zero emission by 2035 as feasible. So I think we'll be seeing more and more of that. Again, if it's required in another program, we don't want to give credits for it. It's kind of a double counting type of thing. And then like we've proposed for all the California ABT credits, there'll be a 5-year expiration date. This is the philosophy. It's not that much different than what we currently have for the ABT program, which I showed earlier. The difference is that instead of having the credits based on the difference between the standard and the FEL, it would be based on the standard itself, and we would apply a credit factor, which is the CF. It would be based on the zero emission powertrain sales, or in this case, the equipment sales, actually. The power bin, which I'll explain in the next slide, and the useful life of the engine that's being replaced, the diesel engine that's being replaced, which again, if you're building from the ground up, you're not really replacing an engine. It makes it a little bit harder in this simplistic concept for giving credits to know how many credits to give. But there is an allowance for that, and I'll get into that a little bit later as well. But the power bin is a little bit different. Instead of being the maximum average power, it's skewed a little bit. It's kind of a filtered value that kind of shifts it to the lower end of the spectrum. And the reason we do this is to prevent overcrediting. There is not really a one-to-one correspondence between motor power and engine power. It becomes very difficult to equate the two. So this is a way, again, in this first simplistic approach at crediting electric vehicles in the off-road or electric equipment. It's a simplistic way to get that done. So similar to what we were proposing for early introduction Tier 5 engines between 2026 and 2028, we would also be giving additional credit for engines produced in that time frame. We would be the credit factor would be 90% of the Tier 4 standard. If the engine was greater than 130 kilowatts, or the engine family is greater than 130 kilowatts, and it would be 80% of the Tier 4 standard if it's less than 130. You may be asking why the difference, why isn't it the same amount? Again, we're seeing a lot more electrified equipment or zero emission equipment in the lower horsepower regions. So it already exists. We want to encourage the development of technology where it does not already exist. And that's why we're giving a little bit more credit for the greater than 130 kilowatt. Now, this would be for the early introduction. Now, we're still, give credit if during the Tier 5 or concurrent with the implementation of the Tier 5 standards, a manufacturer were to, bring in electric vehicles or electric equipment. The credit factor would be lower. It'd be 75% and 50% for the 130, for the greater than 130 and the less than 130 accordingly. Again, for the same reasons. We would also, if the zero emission equipment comes in concurrent with Tier 5, we would also be offering credits for the greenhouse gas standards that we'll be adopting as part of Tier 5. They won't exist yet in 2026 to 2028, so we're limiting the credit to NOx and PM only. But we will be including the greenhouse gases during the Tier 5 period, the actual Tier 5 implementation period if the manufacturer produces and sells electric equipment at that time. Okay, and here's just a chart, an example of what we're doing, what I meant by the filtering. Here we take the 130 to 560 kilowatt power range, and we subdivide it into 10 bins. And within those 10 bins, we have a power range. And if the engine power falls within one of those bins, the engine that's being replaced with or supplanted, if you will, with a electric or zero emission powertrain, if it falls within the 130 to 172 range, we would give the power bin towards the low end of that. It would be 130. And that would be the case for all of these bins. Again, it's a type of filtering. With this simplistic approach, it's meant to minimize overcrediting, if not prevent it altogether, when you use this factor in the equation that I had showed previously. Let me pull that up again. Yeah, so here you see the PWR bin, the power bin. These are the ones in gray are what you would actually use there, depending on where the actual engine being replaced, its maximum horsepower fell within this power range. And again, okay, so even though it's not the ideal situation, if the zero emission powertrain isn't replacing a diesel engine, the manufacturer would have to prove to the executive officer's satisfaction that the equipment that it's using, it would have used a particular diesel engine of a particular power. They'd have to make that case, and then the bin would be calculated from that accordingly. And the useful life would be the same as the replacement engine. There's no filtering going on with that. Here we have a couple examples of the crediting approach. So if the horsepower or if the bin power is greater than 130 kilowatts, then we know that the crediting factor is 90 if it's an early introduction engine, which is the case with the first row. Would apply to NOx and PM. The Tier 4 standard is 0.4 grams per kilowatt hour. We assume 100 units. We assume the 260 kilowatt power bin number, 8,000 hours, which is useful life in this category. And we come up with the 74,880 kilograms of NOx credit. I'm not going to go through each one of these, but if you go down to with Tier 5, which would be the third row, it's basically the same example, but it's based on a Tier 5 engine, which is no longer getting the early introduction credit at 90%. It's getting 75%. And it's multiplied by 0.04 grams per kilowatt hour because that was the proposed Tier 5 standard. And you'll see that it ends up with 6,240 kilograms of NOx credit. Significantly different than the 74,880 in the first row. So there is a lot of advantage to doing this early during the Tier 4 timeframe. But this is how the crediting examples would work. And this is just an equivalency table we put together. How many zero emission pieces of equipment would be needed to offset one Tier 4 engine in the Tier 5 implementation timeframe? And you can go through this at your leisure. It's more for background information rather than being pertinent information for the rule. but it just shows what the displacement, given the time frame and given the power category of the engines being replaced. Okay, so the reporting requirements, there are some reporting requirements for the engine manufacturer in this program. I'm sorry, for the zero emission manufacturer and for the equipment manufacturer. So the zero, even though we say engine here, the powertrain manufacturer, they would provide us with the name and the contact information of the credit supplying equipment manufacturer, because these credits do go to the equipment manufacturer. Let me make that clear. And the equipment manufacturer will sell, trade, or otherwise, exchange them or transfer them to the engine manufacturer, and the engine manufacturer will end up using those as offsets when they certify their engines. There will be a database. CARB will manage the database just to make sure that the credits are being calculated properly, they're being accounted for properly, and when they're used, they're subtracted from the balance properly. So anyway, so these are the reporting requirements for the powertrain manufacturer up top and for the zero emission equipment manufacturer below. There would be some new requirements because we don't currently regulate equipment in California. And we want to make sure that the equipment does have a footprint in California, a sales presence and operation. We're looking to go back at least 3 years. And again, there's going to be a bit of a challenge here for manufacturers who want to do it because most manufacturers don't report even engine sales in California. And they certainly don't report equipment sales yet in California. But to use this provision, they would have to report equipment sales. Okay, we would have to know how much equipment is being produced with these zero emission engines. And the other bullets here, the actual number of zero equipment sold at the end of the year, an accounting of the zero emission equipment, the credits that have been generated, bank transferred or used, and also an attestation letter to us, basically guaranteeing that the credits were done according to the regulation requirements for generating credits, showing us the methodology, but basically an attestation letter, saying that it was done properly. Something that, if necessary, we could follow up with if, things aren't averaging out correctly or if we suspect that there's a problem. And so that was pretty much it for the zero emission program. I'm going to go through the TPEM program and then we'll take questions on both of these afterwards. So initially we weren't going to propose another transition program for equipment manufacturer or flexibility program as it's often called. We were hoping that because the technologies that we're proposing are the same as what were adopted in Tier 4 final, namely diesel particulate filters and selective catalyst reduction. We were hoping that a TPM program wouldn't be necessary. We've met with many folks, industry individuals who tell us, that they will absolutely need additional flexibility just because they are not going to be sure, what the footprint or what the operating characteristics are of the engines that they get from the manufacturer to be able to install them in their equipment and make it work reliably and according to the regulations. They're going to need additional time. So there have been a couple iterations of the TPEM program federally. California has always been a participant in the federal program. We've never had our own program within California borders. The last TPEM program, which was associated with Tier 4, it ended in 2021. So there really hasn't been any of this relief provided since then. Now the TPM program, it's undeniable that it's a cost-effective way for the equipment manufacturer to transition to the new engines with the new standards. But by doing so, it does delay the introduction of the cleaner engines into the marketplace because the equipment manufacturer is allowed to continue producing new equipment with older engines. Well, the engines are new, technically freshly built, but they meet older emission standards. And that's what this program allows. It provides a certain number of years for the manufacturers to do this in order to gain experience and just to figure it out. So what we're proposing for the California TPM program, and again, this is just us, EPA, they won't be a participant in this. Hopefully at some point we can merge again in the future, but we will have different programs, at least in the near term when we adopt Tier 5. The program would apply to all the power categories individually. The equipment manufacturer would be given a fixed number of allowances, and it would be based on the average of the 2026 through 2028 model year sales in California for each power category. Again, I mentioned this earlier, this is going to be challenging because manufacturers, both engine and equipment, rarely report sales to California. And in order to use this provision, the equipment manufacturers would have to start doing this in 2026. And that would be the year, if all goes as planned, we go to the board in 2025. In 2026, that would be the year that Tier 5 would become effective live. So that would be the first year that you could apply for this provision. I take that back. You wouldn't be applying until you actually start producing the equipment with the new engines, but you would have to make an account of your California sales. You'd have to figure out how to do this. Now, we're not requiring you to do this, but if you want to use this provision, this is a voluntary provision. This is going to be something that you have to provide to us, so we know exactly what's out there and we know how many allowances that we can afford to give you. And the EPA program, they had a different way of doing it, whether you were a small volume manufacturer versus whether you were a non-small volume manufacturer. For the non-small volume manufacturer, it was called percent of production. And you had to figure out each year, what your sales were, and then you would base your allowances on that. So it was kind of a dynamic thing, gave a lot of heartache to the certification folks that we'd like to avoid in this iteration, and I think we can. Small volume manufacturers had a fixed number. We're not proposing to have separate small and non-small volume provisions for the California TPM program. All the allowances would be based on the reported actual California equipment sales, which again, manufacturers who want to use this provision will have to figure out how to do that beginning in 2026. And in terms of the duration, okay, this is also where California's program differs from what EPA had previously. EPA used to allow up to 7 years for a manufacturer to use its allowances. We're shortening that, again, because the technologies have already been out there. We think that, some of the manufacturers below 56 kilowatts, they hadn't not used or were not required to use after treatment based technologies in the past, especially the less than 19 for DPFs, but SCR also less than 56, but DPFs above 19 kilowatts were targeted to be required. I know a lot of manufacturers are able to meet the standard without actually using that. But again, the reason we're giving 4 years is because the technology's been out there, it's well known, and 4 years we're giving 1 extra year for the manufacturers less than 56 kilowatts because they were less likely to have had SCR and DPF technologies. And up to 3 years and 50% for the power categories above 56 kilowatts, where you see SCR quite frequently and DPFs not quite as frequently, but they're definitely out there above 56 as well. So we're giving less a shorter period and a shorter amount of flexibility credits, hence the 50% versus the 80% for the less than 56 kilowatts. And this is kind of a background of what EPA did. I probably should have shown this slide first. It applied to all power categories federally. It was up to 7 years. It was a cumulative total of 80% of the annual production within each power category. That was for the percent of production manufacturers. For the small volume manufacturers, the numbers changed. That you had 700 total with 200 units annually. If you had a single engine family, that became 525 total and 150 units annually. If you had multiple engine families, and for small volume manufacturers greater than 130 kilowatts, became 350 total credits and 100 units. But it was all up to 7 years. So yeah, this is what we're changing. This is what was in effect for the Tier 4 program, the TPEM program, and we're changing that a little bit. Instead of 80% for everything, it's only 80% for less than 56 kilowatts and 50% for greater than 56 kilowatts. And it's only 4 years and 3 years respectively for those categories. This chart just shows what we envision, or how we envision the credits to be utilized. EPA allowed the regular availability of the credits, which started with their Tier 4 interim provisions. We would do the same. We would if a manufacturer needs it for Tier 5, which really should be highly unlikely, then the manufacturer could use it with the engine being brought in as a Tier 4 final. I think, even though we call it the delayed availability approach, I think it's probably the more likely approach. These are the years based on the power categories that things would kick in. And it's also the Tier 5 interim standard would be the engine that would have to be brought in versus the Tier 4 final if they use the credits earlier. Okay, some other considerations regarding the TPM program. The record keeping and reporting requirements would remain largely the same as they are right now under the Tier 4 program, except that they would be based on California sales. All equipment manufacturers, seeking to utilize this provision would be required to report California equipment sales beginning in 2026. One of the differences that exists now between CARB and EPA is that for these engines, they're built brand new. They're built to previous year, emission configurations and specifications. We in California have required executive orders for them for quite a while. It's a simplified executive order approach. We would continue to do that under the Tier 5. It helps with tracking, for one thing. It also helps should we ever need to do corrective action in the field, we ever find a problem. It ensures that we have our own independent autonomous authority to do corrective action on these engines. And then I mentioned a bond provision. Here, EPA has a bond provision in their Tier 4 TPEM requirements. My understanding is that was to ensure that manufacturers weren't creating subsets that could each claim a small volume allowance of credits, which would end up being more than the manufacturer was entitled to, when you considered all the sub-entities together. I think this was done primarily, I don't think it applied domestically, but when a manufacturer, wanted to come into California from out of the country, and it didn't have a history, it was like a first-time creation. This was an assurance. It's a refundable bond, so it would be paid up front. Status would be verified. Make sure that it's a legitimate company, not somebody that's trying to game the system, and the money would be refundable. And I think I mentioned this, but the last bullet, it states that that the equipment manufacturer would have to consider all California directed equipment sales when calculating its allowances. And this would include those from the parent or subsidiary companies and any other companies licensed by the manufacturer. This isn't new. This language is plagiarized from the EPA regulations. So it would be new for California because it's a new requirement in California, but it's what EPA had been requiring all along. Okay, that's the end of the presentation. I guess we can take questions now. I see 2 hands raised already.
Jeff, I think there were 2 people in front of them, so there's 3 questions beginning at 141, and Christian will read those off before you take the hands.
Okay.
Sure. The first question is from Patrick Ulanake. What considerations would be given for equipment that is currently either CI or SI?
Yeah, I'm not sure. think maybe this had been answered previously, and I'm not sure to which presentation this is really.
Jeff, this presentation, this question is with respect to the presentation on zero emission credits.
Okay. The Tier 5 regulations are just for compression ignition engines. And I mentioned in the presentation on the credits that, you know, we don't want to give credits for equipment that is mandatorily required to become zero emission under an SI program, for example, SOAR, I mentioned. There's a forklift regulation that's being developed that would require all SI forklifts to be zero emission. We would not give them credits under the Tier 5 ZE program. It's reserved just for CI. Hopefully that answered the question.
Thanks. We have another question from Patrick Ulanake. How will power be defined for electric powertrains, i.e. continuous versus peak versus something other?
Yeah, that's a good question. It's something that, you know, we've gone back and forth with. I'm not sure we have a definitive answer for you today, right now. I think we are leaning towards continuous power for that. But again, it's being compared to the engine power in terms of providing credits. So that comes into play as well. The program that, you know, that we're proposing, it's kind of a simplified crediting program. More comprehensive program can be developed and likely will be in future regulations or future iterations of this one potentially. But for now, it's a simplistic approach. And we'd have to get back to you. Let us, you know, talk that over a little bit more, and you know, we'll post an answer in the near future. Thank you.
Thanks. Patrick, another question from Patrick here. Is EIN a fleet assigned identification? What about non-fleet equipment?
Right. Great question. It's an easy way to identify whether or not, you know, the manufacturers had a market, a footprint in the California market. And that's why we put it there. I think we put that it could also be proven in another way. Let me see if I can find that slide. Bear with me. Okay, I think here it is. The second bullet, the first sub bullet, valid California equipment identification number dating back at least 3 years, or other proof of prior California sales presence and operations. So, you know, we're open to other forms of proof. And I guess I'll leave it at that.
Jeff, maybe I can provide a little background by what we mean by EIN. So that's a term we usually use in the context of our in-use off-road diesel reg, which requires anyone operating off-road diesel equipment, mobile, 25 horsepower and up, to register in our DOORS system and then like report their equipment and then label it with a number that we assign to them, sort of like a license plate number. So showing that one of your customers had that number shows that somebody's like bought your equipment and is using it in California.
Thanks, Kim.
Maybe we'll go to those raised hands. First is from George Lynn. I'll ask you to unmute and ask your question.
Yeah, thanks. So, Jeff, if I understand this correctly, for the TPEM credits, if a manufacturer has okay, so first of all, at a high level, this is just the percentage of production, right? There isn't really a small volume allowance now for the Tier 5 TPEM, right? So if a manufacturer sells, like, let's say their average is 1,000 units greater than 130 kilowatts, let's say it's 1,000 units, they would be allocated 50% of that 1,000 units, so 500 units to use over the TPEM period. Is that correct?
Yeah, it'd be 80% of the average over that 5-year period of a 1-year production, and that would be allowed to be used over the 4 years for less than 56, and it would be 50% over the 500 if your engines are over 56 kilowatts.
Yeah, so the greater than 56 kilowatt scenario, it's the average over the 3 years.
Right.
And then I take that average. So if it's 1,000 units average over 3 years, I take that, then I would multiply that by 50%, so I get 500. So I have 500 TPEM credits to use over 3 years.
That's correct.
Okay, great. Thank you.
Our next question comes from Don Nguyen. I'll ask you to unmute your mic and ask your question. Again, Don Nguyen, I've asked you to unmute. You could unmute and ask a question.
It may have been a mistake, Christian.
Okay. So we'll move to our next question. CARB should ensure zero-emission equipment has consistent warranty and performance with replaced diesel equipment. Diesels must meet requirement emissions warranty provisions. With zero equipment, there is a significant loss of warranty emissions warranty on the zero-emission equipment and the batteries versus diesel, along with loss of functionality of batteries. Zero-emission equipment only works with a specific proprietary battery, like mobile cars and trucks. Zero-emission equipment should include a battery warranties the same length as the equipment warranty. For example, equipment warranties vary from 2 to 4 years, while batteries for equipment varies for 90 days to 3 years. Compare EGO, DeWalt, Greenworks, Mean Green, equipment battery. Also, battery performance degrades significantly over time. Mean Green restricts battery warranty within 65% of charge in year 3. Battery performance should be much higher than the cost is much higher with added waste and energy.
Yeah, I'll take that one, Christian. First of all, I appreciate the comments. Looking at warranty, it's something we've considered. We have not rejected that concept. We're still mulling it over. It's something to be determined in terms of this proposal. It does make sense that there should be some type of warranty, but again, this provision, it's an introductory zero emission provision for the engine manufacturer. So we have to take that into consideration as well. Personally, I think that, well, I don't want to go off and make policy, but I like the idea of warranting the zero emission piece of equipment to the same degree that that a diesel powered piece of equipment would be warranted. But it's something that we have been talking about, we'll look into, and we'll have a future response for you on this.
Yeah, I think just to clarify that, I don't think we made a decision on that at all. So I would say, thanks for the comment, and we'll definitely consider it. But there's other pieces to take into account too with Tier 5. So appreciate it. We will consider it.
The next question asks, could you clarify what the power bins will be for the less than 130 kilowatts on page 9?
Yeah, I think I just gave an example of the 130 to 560 range. Essentially, I don't have it printed out, but you would take 10 bins within that power category for the 130. Right now we have less than 19 to 56 to 130. So the 19 to 56, you would carve that into 10 different bins, and the methodology we were using, I think we were rounding it down to the nearest, 5 value towards the lower end. And that would be the same process. That's what our current thinking is for the bin for that category as well. So you'd have 10 separate slices, and then wherever the engine being replaced falls within those categories, you would take the low end of that power range, round it up to the the closest 5. Okay.
Okay. The next question is for TPEM and all other CARB Tier 5 reporting requirements for non-road, including in-screening reporting for IUT program. Does CARB and industry equipment manufacturers have current infrastructure to support such reporting requirements? And if EPA adopts CARB Tier 5, is there a national reporting standard infrastructure in place for non-road?
Yeah, I'll take this as well. Okay, for one thing, TPM is not a requirement. It's a voluntary provision. Manufacturers do not have to utilize it. I suspect most will, but it's a voluntary provision. In terms of having the manpower to do this, I'm pretty sure that we'll probably have to add a few people here and there, primarily to our certification group. EPA has been doing TPM for a number of years. We've been getting their reports. So, we, in a sense, we have a head start because we know what to look for or what we will need to look for, but it will be an increase in the workload on CARB staff. And in my humble opinion, which means next to nothing, we will probably have to add more personnel in order to accomplish this. And in the second part of this is that if EPA adopts Tier 5, yeah, ideally, if EPA comes on board, they adopt the same standards, the same provisions, the in-use provisions. If it's an identical rulemaking, then yeah, I think it makes a lot of sense to have a harmonized program again like we do now, where California is a participant. But short of that, I think we're probably going to need the California program for at least a while. Thank you.
Our next question is from Patrick Ulenok. For crediting, the question is, how would it happen? How would it be handled if equipment currently has both CI and SI options? A mower available as CI or SI?
Again, if this is regarding the credits, the credit program or the ZEV program, we're not proposing to give credits for SI equipment, especially not for equipment that are required to be electrified under the SI regulations. Aside from that, Tier 5 is a CI only program, only regulation. It's not like our on-road program that includes both gas and diesel. For off-road, the engine, it's just diesel that we look at primarily. Thank you.
Our next question. Will Tier 5 zero emission credit program be an alternative way to meet the TMR?
And that's an interesting question. Right now, it's designed to offset the engine emission levels. I'm not sure what TMR is going to look like. It's still, very early in its conceptual stage. So whether it regulates engines or equipment, I don't know. I mean, I suppose it's possible, but as of right now, we're not factoring that into the equation.
Our next question, for the greater than 560 applicability between 2030 and 2032 and delayed 2034 through 2036, what about 2033?
Let me pull up the slide. Okay, for greater than 560, delayed option. Oh, general applicability, 2032. Okay, and 2034 to 2036. What about 2033? So you're talking, okay, I'm not sure I fully understand this question, but if it's asking what happens in the delayed option in 2033, oh, I see. Well, in 2033, the allowances wouldn't be available any longer. If you did the general availability, the calendar years during which you could use these credits for the greater than 560 category. I'm sorry, I said credits, I meant allowances. You'd use it for 2030, 2031, and 2032. Those credits would no longer be available in 2033. And so you're saying that there's a year gap. Let me look at that. Okay, I didn't realize that that was in there. Let me look at that, and we'll get back to see if that's an issue or not. But these were the periods that the allowances were supposed to be allowed. So presumably, if this is correct, and I will double check when I go back, but presumably if it's correct, then you either use your allowances between 2030 and 2032, and then in 2033, you no longer have allowances. Your equipment has to have Tier 5 compliant engines in it, or you start in 2034. You start with this delayed approach, and in 2033, you need to have most likely a Tier 5 interim engine. But let me double check just to make sure that this makes sense. Thank you for the question.
I'm not seeing any new questions. Perhaps we should move on to the next presentation and any additional questions.
Since we have extra time, why don't we go back and take a few, because I know some staff are on the line who've been waiting a long time. Like specifically question at 9:06 a.m. and 9:06 and 9:08.
Okay. 9:06, Adam Mezzacampo asks, do the extended emissions warranty requirements only require that the parts are covered by warranty? Is there any other requirement to cover the labor for replacing the part, travel, etc.? I believe Adil would have liked to respond to that.
Sure, thanks, Crispin. Yeah, the emissions warranty would typically cover parts and labor, but not other costs such as travel or rental equipment or loaner replacement equipment.
Thanks, Adil. We have another question for you, 908 from Justin Gruel. Regarding slide 9, or the previous presentation, defects and reporting, can you please clarify whether the corrective action requirements of 13 CCR subsection 2143 apply to off-road engines today?
Sure. Yeah, the corrective action thresholds in 2143 do apply. Some of the other sections, such as the reporting sections in that article, such as 2141, 45, and 46 would not apply. But yeah, to answer to your question, yes, 2143 would.
Thank you, Jill. Other questions we have at 905, Rob Weiss asks, to add on the question about extended warranty, many manufacturers will not know if their products will be used in a low or high hour machines. So they will have to design for the worst case. Point is, the low use, high use argument is not a relevant one in many cases. This is a comment more than a question.
Yeah, so I appreciate the comment. So at least I want to say that we recognize that the longer years is not without a challenge. So we understand it is a challenge. But when at least our understanding is that the cost impact of longer years is much less than the cost impact of lengthening the hour. And so we think it's lengthening the year limit is a reasonable way to achieve emission benefit from the low usage equipment that generally hit the year limit way before the hour limit. So that's our intent. But thanks for the comment.
Thank you, Shun. At 11:37, we received a question from Steve Berry. More for the IUT team, perhaps. But coming back to engines less than 56 and greater than 560 kilowatts, if I understood the response correctly, even if there are not screening or manufacturer-run PEMS compliance program requirements, off-cycle emission limits do apply for bins A and C, correct?
I will take this question. Yes, there's no in-use testing requirements for engines smaller than 56 and larger than 560 kilowatt. The OBD off-cycle emission limits are different from our in-use testing requirements. So I don't know if OBD staff is available to answer this question as well.
Yeah, we don't, when it comes to OBD, we wouldn't think of it in terms of off-cycle emissions limits. I mean, there's the malfunction criteria that are established through the monitoring requirements. So the bins B and C, like the OBM NOx, I'm not sure if he's referring to the OBM NOx monitor still being active. It certainly would be. So it would extend beyond just the circle of in-use compliance requirements, that the screening and PEMS type requirements. So I think that's what the question is surrounding.
Steve has his hand raised. Maybe he has a follow-up or clarification. Steve, I've allowed you to unmute yourself. And
great. Thank you, Christian. Can you hear me?
Yeah, I can hear you, Steve.
Good. Thanks for taking the question. The question doesn't have anything to do with OBD. It's simply with respect to the off-cycle emissions standards, where you control 56 to 560 with 3 BMOL requirements. It's possible to have emission standards in place without a compliance program to check them. So that's my question. Are there off-cycle emissions requirements for engines less than 56 and greater than 560, even though there's no compliance program? Today, for example, we have not to exceed standards. What will we have with Tier 5?
I can take that one, actually. That's a really good question. I know that the in-use compliance folks are running their own, will be running their own in-use compliance testing. And so we'll have to get back to you on that question.
Yeah.
And consider it, yeah.
And if they're running in-use compliance testing, they need some standards to check their results against.
Yep.
So, yeah.
That's why we need to get back to you.
Thank you.
At 11:41, Steve Berry asks, this is probably a follow-up to questions and answers in the earlier section, but it was in regards to Yi's response. Are the active fault codes? I don't 100% remember the context. Do you?
Yes, I do. It's about the PM screening proposal. And what we mean is actually the pending and active near-own fault codes. These, let me check the slide number. I think it's slide number 42 in the in-use testing slide deck. Yes.
We have another question from Steve Berry at 11:48. Sorry for coming back to the IET slides. So on slide 43, what qualifies as a code, an active code in the 50-hour array? Question mark pending codes, the lifetime array. How does the 5 most recent information play into the pass-fail criteria for an engine family? Hopefully this describes the additional detail I was looking for.
Yeah, I guess I'll speak to the PM fault code tracking aspect of this question. So the codes are either the pending or mill-on code stored and by the OBD system, and so soon as a filtration deficiency or PM sensor malfunction is detected, and either a pending code is stored or a mill-on code is stored, that this tracking parameter will also record that very same code, and along with the engine hour timestamp. So it doesn't have anything to do with the 50-hour array or lifetime array. It's an independent parameter that is simply recording the most recent last 5 fault code events that are associated with the PM filtration efficiency monitor and PM sensor. And so when they collect the data in the in-use program annually for an engine family, they're counting up, okay, I've got this many engines in this family, and what do you know, 5% of them, if more than 5% of them have the fault code present, any of those fault codes present in this tracking parameter, then it gets counted towards, then that's basically the flag. But maybe Eitan can comment more on that.
I don't have additional comments about this. Yeah.
I think Steve has follow-up. Steve, I've asked you to unmute.
Yeah, so thank you. It's just any evidence of a fault is going to declare the engine family as not a clean engine family. Is that what I'm to understand? Any evidence in the 50-hour array has nothing to do with lifetime array. Just any evidence of a DPF related fault in the 50-hour array is going to flag the engine family as not being a clean engine family.
One wrinkle, so it's not associated with the 50-hour array. This tracking parameter is simply 5 slots of space for fault codes, and it just overwrites the oldest with the newest as they occur, such that when a download of the data occurs for the engines in this engine family, and if there is a fault code present, then it gets counted towards that 5% threshold.
Okay, so any evidence of a fault code in lifetime then doesn't have to be just the 50-hour array. It can have 6,000 hours on it, and if it had a fault at 1,000 hours, it'll get flagged as not a clean engine family. That's what I'm understanding.
Yeah, I think the details about time frame, like there are some subtleties, and you're pointing them out. There's some subtleties to how that counting is going to ultimately be done in practice. And I think what you've seen today is a higher level picture of the concept of what it looks like. And some of these finer points do indeed need to be worked out.
Yeah, we can continue the conversation after the workshop.
Okay, thank you.
We have more questions from the previous topics, but to stay on track, I think we should move on to the next presentation, but we'll still save these for the open session at the end of today.
Thanks, Christian.
I think that's me again. Give me a second to pull it up. Okay, just a few more seconds. Okay, hopefully you can see it. Miscellaneous amendments. Yes. All right, thank you. So in addition to these more focused amendments that we've been proposing on, we also want to do some cleanup, and we want to address some topics that basically have been left unaddressed for a number of years. And in addition to these, I throw out just a general request that, if there are other inconsistencies in the regs that you have found, please do let us know. And if we need to address them, we will in the Tier 5 rulemaking. So the point we want to, obviously, whenever there's typographical errors or other consistencies in the regulations or the test procedures, we want to fix those. We want to clarify the conditional approval of certified on-road engines as off-road compliant engines. And I'll get into these in more detail. We basically want to make sure that, the new standards, for example, the 0.04 grams per kilowatt hour, we want to make sure that that's 40 milligrams and not 0.04 rounded. So we'll have to make modifications there. There's a defect in the language for replacement engines that we want to address, which inadvertently disallows the use of a clean Tier 4 final engine as a replacement engine if the EO has expired. That's something we'll get into. And also, just as a general rule of thumb, whenever possible, we want to make sure that compliance is as harmonized as possible between us and EPA, just not to overburden manufacturers or to require duplicative testing that's unnecessary. And another issue that we've been aware of for a while, and we're finally going to get around to fix, is the fact that we require basically Tier 2 land-based standards for diesel marine engines less than 37 kilowatts. The standards have progressed over the years. EPA includes them in a different rulemaking packet, so I'll address that as well. Okay, more of the same, correcting errors, typographical errors, inconsistencies, some of which I've just pointed out. This does seem to be a little bit redundant. And to clarify conditional approval of certified on-road engines as off-road compliant engines. Okay, and as I mentioned, right now, the PM standard for Tier 4 is 0.02. We want to extend that out to 0.005. We just want to make sure that the significant digits work, match, just so it's not something where rounding comes into play and it inadvertently circumvents the emission benefits that we'd be getting from the standards. Same thing for the NOx standard, 0.04, it's going to become 0.040. EPA, and I think probably CARB as well, I think they adopted milligrams per kilowatt hour standards. So, in their case, it'd be 35 milligrams per horsepower hour, instead of 0.035. I think we'll probably end up leaving it the same, but it's something that could change as well. But the bottom line is we just want to make sure it goes out to the proper number of significant digits when the standards are calculated, just like it was demonstrated at Southwest Research Institute. Oops. getting ahead of myself here. Apologies. Okay, so the language, the second bullet here, the incorporated language in 40 CFR 1068-240 of the test procedures, it's as I explained before, it was inadvertent. We wouldn't, intentionally have wanted not to allow a clean engine, a Tier 4 final engine, to not be able to replace, a Tier 4 final engine in the field just because its executive order had expired, with the alternative being having to recertify that engine in order to be able to use it as such. EPA corrected this mistake or this inadvertent language in, I want to say 2014 or 2016. Essentially, we're just going to align with that change. So we no longer have this impediment for using a Tier 4 final, and obviously this will extend to Tier 5 eventually, engine whose executive order has expired, to be able to use that as a replacement engine. There's no precedent for that in the other categories. Tier 3 with an expired engine can still be used as a replacement engine if it ends up being the cleanest engine available. So that's a fix that we intend to make. There are a number of instances where we still have the old El Monte address in the regulations. That's going to be updated with the new Riverside address for when information is submitted through the mail, which hopefully doesn't happen too often anymore. But yeah, just to make sure it gets to the right place. And again, just as a general comment, we've incorporated sections 1039, 1065, and 1068 of the EPA regulations. We call them test procedures in California. We like to keep them as closely aligned as possible. Obviously, that's not always possible, especially when you have different standards. But in terms of the testing requirements and what's needed to show compliance, generally, there shouldn't be an impediment in determining that. So again, we want to make that as harmonized as possible to eliminate any burdens that it would otherwise place on the industry when complying with our regulations. And the diesel marine propulsion engine exclusion, I'd kind of covered this already, but I'll give you the background. Traditionally, we have included diesel marine propulsion less than 37 kilowatts as part of the land base, that they would be subject to the land-based off-road compression ignition standards. And that was the case both federally and in California until EPA adopted Tier 4. When they adopted Tier 4, they exempted these engines from Tier 4 completely. And the intent was to allow them to be covered under 40 CFR 10, doing this from memory, folks. I believe it's 1042, which is the compression ignition provisions for spark ignition engines. Problem was that back in 2004, when we adopted it, the engines less than 37 kilowatts were not yet included in CFR 40 CFR 1042. If I have that correctly. So we decided to keep the standard where it was, which at the time was at the Tier 2 level. Again, we just did not want these engines to be excluded and to be considered not subject to any standards. So we wanted to make sure that they were at least subject to the prior standards, since EPA did not include them under the Tier 4 umbrella. Well, that was back in 2004. Things have changed since then. These less than 37 kilowatt diesel propulsion engines are now included in those provisions. Manufacturers come to us all the time asking if they can certify to the more stringent standards. And this has been a point of controversy, I suppose. Although I know our legal folks have said that there's no impediment to certifying to a more stringent standard than that which is required. But we're going to fix this. We're going to remove this category from California's new off-road diesel engine regulations. So these engines would be regulated solely under EPA's regulations from now on, or whenever this, the board approves this. Again, way back when, from what I could find, and this happened even before I came on board, which was a long time ago, it was believed that these engines were unlikely to cross state lines or cross international borders, so they were fair game. Not not so sure that that's still the case, but regardless, we were going to propose to no longer make these engines subject to the land-based off-road diesel standards in our Tier 5 rulemaking. Now, auxiliary diesel marine engines, they will still be required to meet the land-based standards unless they share the same fueling, exhaust, cooling as the propulsion engine. Again, we would be aligned with EPA. It's what we've been doing all along right now, but it's just the propulsion engine that EPA will be regulating under 1042. The auxiliary stuff will still be based, if it's portable, it'll still be based on the land-based standards. Hope that was clear. And yeah, here's our final request that, if there's anything else, any other errors that you see, I'll share something with you, even though it's not something that we're going to correct, but we've made it known, is that if you go online and look at the regulations online, I believe it's Westlaw, they made some changes somewhat recently. I'm guessing it was for ADA purposes, and the tables they're not useful for compliance, to be perfectly honest. We brought it to our attention. They will be fixing that. That's not something that we would propose in our amendments, but stuff like that. If you come across, anything that's obviously a mistake, let us know, and we'll try to address it in Tier 5. All right. Open it up for questions now. Thank you.
Thanks, Jeff.
Welcome.
So I don't see any questions on this topic. And since Julie Schiffman's been waiting for 2 days to give her presentation, I think it would be prudent to have her give it right now. And then let her take her questions, and then we can circle back to all the other questions.
Sounds good. Good luck, Julie.
Hi, Christian, this is Julie. Can you allow me to share, please?
Oh, sure. Make that adjustment. Okay, Julie, I made you a co-host. Can you try sharing one more time?
Got it. Thank you. Okay, good afternoon. My name is Julie Schiffman. I'm the lead staff on the off-road emission factor updates, and I'm going to walk through changes to the emission inventory methodology. These will impact not just Tier 5, but the off-road diesel emission inventories. So a concept overview, what we're looking at here is we're using real-world off-road diesel equipment data to quantify activity patterns and NOx emissions. And this is a first for off-road. On-road has been doing this for 30 plus years. And so the current method for off-road emissions is no variation in engine load, one emission factor, and a load factor based on the equipment type grouping. The new method we're looking at will reflect time and emissions at different engine loads and load factors based on engine horsepower grouping. So our goals here in this emissions inventory update is to collect emissions in load bin from PEMS units, and that's based on simulated activity, and then to collect activity and time in load bin from the same PEMS units and the additional HEM data loggers that were used during real-world equipment operation. We are going to combine the emissions activity and the emissions data and the activity data by load bin, and we are going to establish new NOx emission profiles and new load factors. So here's a look at the data logger on the left, which are small, inexpensive, and easy to install. And they're used to capture months of real-world activity and load data, but no emissions data. And then on the right, we have these very large PEMS devices that are difficult to install. And each of these were used for about 48 hours of simulated activity. They can also capture activity and load data, but we have the PEMS allows us to capture NOx emissions data, and it's a limited real-world activity data. So here's a look at the different data sets. It's just a little snapshot. So the PEMS on the left is a compilation of 27 pieces of 2011 construction data and 23 pieces of 2019 construction data. And here's just some little raw data looking at load, speed, NOx, and fuel. And in this instance, idle is when load equals 0. And then the bluish green color is non-idle. And on the right, we have the activity data. And that's about 12 months of real-world data. And it includes 64 pieces of 2022 construction data and the additional PEMS data. Our next steps is to study the ag tractor data. It's a contract that is just finishing, and we have just a little snapshot here of the load and speed in the raw data form, where again in this like pinkish red color is when load equals 0, and then the green is all other activity. So the first step here is grouping the activity, and so this data that we're looking at is the construction data, and so our potential for ag data in the future, and then any other sectors as data becomes available. But we have grouped the construction activity data into these 3 bins. So we have bin 1, bin 2, and bin 3. It's based on horsepower bin, and this analysis comes from our agricultural equipment emissions inventory technical documentation. And from the agricultural equipment inventory, we've discovered that equipment from 0 to 74 horsepower have similar activity patterns, and then from 75 to 174 horsepower, and then 175 horsepower and larger. So if we look at the construction data, this is activity only, and so this is a combination of PEMS and HEM data loggers. And so the new activity groups this is specific for construction, and it's based on engine horsepower, and so we have bin 2 and bin 3. Bin 1, we have no data yet for that. That's under 75 horsepower. And so with additional testing, we're going to be able to add more information to this. But as you can see, this larger chunk of these bar on the bottom, 36% and 42%, that's idle. And all of the other colored bars are the other load bins. This is a mapping of the US EPA off-road diesel engine standards, and it's colored by tier 1, 2, 3, 4I, and 4F. But the number of PEMS from our study currently do not support the different NOx standard groupings here by tier and horsepower bin. And so what we looked at is the NOx standards that are circled here in red, that across different tiers, they have the same NOx standard. And so we use this to do a different NOx grouping for our emission update. And so this is the way we're looking to group our new NOx groupings. And I just want to note that emission inventories is based in engine horsepower. And so the majority of these slides are actually noted in engine horsepower, but on this slide on the far right column, we do have kilowatt hour here. And so the table here just shows the description on the left, which is a combination of tier and engine horsepower. And then the green column talks about our new number labeling. It's just numbered from 1 through 13. And then the yellow is the NOx standard. It's how they're grouped according to NOx standard. And then this last column is the kilowatt conversion. So this looks at expanding the US EPA NOx standards based on this NOx standard and new ID numbering as opposed to tier numbering. And so this just plots on the top, it's labeled by tier. So 0, 1, 2, 3, 4I, 4F. And on bottom, it's these new NOx numberings from 1 through 13. And on this slide, it shows how we are grouping the different activity bins and the NOx bins together. And so the dashed black line shows how horsepower bin is grouped around the different NOx IDs, with a horsepower bin here on the left. And so based on this, we have 22 combinations for NOx ID and bin grouping, and every bin does have an idle bin and then 10 non-idle bins. So this is a look at the PEMS data. This is NOx emissions in grams per brake horsepower hour by load bin. The x-axis here is each of the different NOx IDs. And so there's no data for tiers 0 through 1, which corresponds to NOx IDs 1 through 4. And then there's a gap here for NOx IDs 11 and 12. Those are the 750 plus horsepower engines. And what's important to notice here, the green bars are the average NOx in grams per brake horsepower hour for each of these NOx groupings. And the yellow line is the NOx standard that corresponds to each of these groups. And what I would like to highlight here is on these lower load bins, emissions are higher. So they tend to be higher than the NOx standard, whereas the higher load bins are lower than the NOx standard. And just a close up here, this is NOx 13, which is tier 4 final. And you can see how the NOx standard, this pinkish red line, is actually very close, sitting right on the emissions for the higher load bins, but the lower load bins are emitting higher than the standard. Okay, so this is a visualization of the goals that I mentioned in the very beginning. So this gray box here shows our old method, which assumes that 100% of all activity uses the same value. And just for this example, we're saying a NOx emissions factor is 2.3 grams per brake horsepower hour, and the average load for maybe a tractor is 0.48. So this new method, it combines these three different pieces of information. So using data loggers and the PEMS data, we have activity data on this top bar chart. So this is activity, and this is an example for bin 2. So it's the percent of time in load bin. And then we have the middle section here is the percent of average engine power in load bin. And then from the PEMS units, we have this bottom bar chart, which is the NOx for group 6. Group 6 is one of the groups that corresponds to bin 2. So the emission factors, the first light green bar on the left is for idle, and that's measured in grams per hour. And the solid dark green bars are measured in grams per brake horsepower hour, and that's for the non-idle bins. And so then we multiply each of these together, and this is going to create our new NOx emissions factor. And so here's a look at the equation that we're using now to calculate NOx emissions. So our new NOx, it's based on a portion of idle emissions plus non-idle emissions, and then this is for inventory calculations, and then it's all multiplied by the equipment population. And so idle NOx emissions, it's based on the idle time activity. If you recall, I think it was 36% for construction bin 2, and then NOx ID in grams per hour, and then that's multiplied by the estimated annual hours, and then there's a unit conversion, and then that's going to bring us to the grams per brake horse, or the tons per day. And then we look at the non-idle emissions, which was that visualization of the goals I showed you, which sums the activity percent in time by load bin times the emissions in grams per brake horsepower hour for each of those load bins. And then we add in, or we multiply in the average load for that grouping of equipment and the engine horsepower for that grouping of equipment. And all of that's multiplied by population. And then that's how we are getting our new NOx emissions for the emission inventory. So you might ask yourself, well, how are we calculating idle? And so we did an analysis for the emissions inventory using the data loggers on how idling is appearing. And so in this pinkish red dots, we have, first of all, load equals 0, so that's idle. And then we wanted to know what's happening with the steady state idling. So we assigned 15-second groupings to the raw data, and we looked at what the average speed using engine RPM for each of those groupings. And we looked to see how the speed fluctuated, and if there was a ratio greater than 5% and the speed was greater than 1100 RPM, it was not idle, and anything less than that was considered steady state idle. And it might be a little bit difficult to see, but circled here are these little green dots in the load box. And that's how we calculated idle in grams per hour. So here's a summary of what the proposed Tier 5 NOx groupings would look like based off of the Tier 5I and Tier 5 final proposed standards. And so these groupings, we have 6 groupings here. And so first column is our horsepower description, then it's our horsepower bin. Again, I said that emission inventories are focused on horsepower. And then the last 2 columns are important to look at, and it shows the proposed estimated emission reductions from Tier 4 final to Tier 5I, and then Tier 4 final to Tier 5 final, the last 2 columns. There will be a separate emissions benefits workshop shared later by my colleague, Dr. June Park, and he's going to go into further detail on this information. And I just want to note also, we have the low load cycle here in the 75 to 750 horsepower range, and that's applied when the engine load is less than 25%. And so here's just a figure that shows the blue bars are the Tier 4 final average NOx, and this orange line is the Tier 4 final NOx standard here at 0.3. And then we have this yellow line here, which is a Tier 5 iNOx standard, 0.16. And that's a 45% reduction. And purple line is a 90% reduction to Tier 5 final at 0.03. And on the bins 10, 20, and 30, we'll see a low load cycle for under 25. And that's estimated to be 0.06. And so the impact of this analysis, this is the first time for emissions inventory that we're quantifying idle versus non-idle emissions in off-road engines, and we're looking specifically at low load engine cycles. And so from this analysis, we will be able to model low load cycles in our off-road diesel emission inventories, and then we will work to quantify potential Tier 5 impacts. So our next steps will be to complete this ag data logging contract. It's not included in this presentation yet because the contract just ended, or it's in the process of ending. We'd like any further discussion with industry, and once there's additional testing, we can consider adding additional pollutants to update in our emissions inventory. Right now, we're just focusing on NOx. So that's about it. So if you have any of your questions or comments, here's my email address, and you can email me until November 30th. Thanks.
But we're also taking questions now, too.
Yes, also now.
I think our first question is at 3:01 from David Peck. Julie, do you have an average annual hours of operation for California compression condition engines?
We have average annual hours for in our inventories. They're specific for the industry sector, the equipment grouping, horsepower grouping. It really just depends on which inventory we're talking about.
Well, let me see here. I think 255. There's also an inventory question. Yeah, from Steve Berry. Do you believe that MFEC model for non-road engines is an accurate CO2 emissions estimation as it is for NOx emissions following the described updates? The presentation focuses on NOx emissions, where the updates also improving CO2 emissions estimates. I'm sorry. Were the updates also improving the CO2 emissions updates?
So this update is specific for NOx emissions. We have not looked at anything for CO2 yet. So that would come potentially later if and when we get additional data.
We have David Peck asks, oh, I'm sorry, one second. At 302, we have a question. Have you simulated what percent NOx reduction in the NOx as a result of Tier 5 translates to in an absolute NOx reductions? Further to that, what would the resulting reduction in atmospheric NOx concentration be, i.e., what impact would Tier 5 have on the air quality in milligrams per meter cubed?
So we are going to have a future presentation by Dr. June Park, and he's going to talk about percent reduction of NOx. So we don't have any like inventory results to share at this time. We're just looking at the methods for updating NOx emissions. But he's going to be walking through, I think, some slides that would potentially answer your question.
Thank you. David Peck has a follow-up. Can you provide, share, or publish those numbers, the annual hours of operation by category and inventory?
Yeah, that's a good question. We have our off-road inventories are published online in our off-road. It's part of MFAC. Our off-road emission inventories are online, and you can select which category you're looking for, what calendar year you're looking at, and you can pull all of this information. If you have any trouble, you can always send me an email, and I can help walk you through that.
Thank you. Steve Berry asks, would you care to offer any thoughts about how MFAC compares to the EPA MOVE's non-road emissions model, especially for CO2 modeling?
I can't really speak to CO2 at this time. The differences I can speak to right now are our off-road inventory models are all California specific, and they're either based off of reported data or survey data, and that's specific to California. I'm not sure that all of the MOVE's inventories are specific, how specific they are, but our California inventories are specific to California.
Christian, can I just chime in with a little additional material related to the question about quantifying benefits and then translating that to like a microgram per cubic meter impact on the atmosphere?
Please do so, Kim.
Okay, so I just wanted to clarify. So as part of the staff report and associated materials that we'll put together when we formalize this proposal and bring it to our board, we will be quantifying the total benefits expected from the proposal. And we do the same thing for a couple alternatives and explain like why we're choosing the alternative we do. And we'll look at how much health impacts we expect would result from those emissions being reduced. We don't typically do a lot of like photochemical modeling, looking at, in order to quantify exactly how much impact on the whole atmosphere, you'd have to look at where all the equipment is operating exactly and what's being emitted from everything else in the state. We typically do that modeling not just for one measure at a time, but for a whole package of measures where we're saying, okay, we know this is the air quality today, this is the health-based ambient air quality standards we have to try to achieve on a certain timeline, and here's a package of measures that we will be modeling to see if we'll reach attainment in time, and we run different scenarios for different like weather conditions and that kind of stuff. So we don't usually go to that level of specificity for each individual rule. But this rulemaking is being pursued because it is one of the measures in the state implementation plan, and it's part of the package that's being modeled as what we need in order to move California towards attaining those health-based ambient air quality standards. So I just want to add a little bit more context beyond the Julie's our expert in this in this specific source category, but I just wanted to chime in there.
I'm wondering, was there a question from yesterday? Kim, I think you alluded to that we might have missed on inventory. Do you recall that?
There was. Let me look.
Yeah, it was a question about does CARB have an inventory by power category? Of total ORCI, NRCI in California. Does that sound right?
This is Corey. I can speak to that one. I am the manager of the off-road diesel inventories. So on our online platform, we do have an inventory of all the off-road equipment out by horsepower group and type, and that can be matched up to the definitions of preempt and non-preempt equipment to get the totals of each. It's not sorted like that on the platform, but that can be done. The next set of workshops where Joan Park will be presenting on sort of the emission impacts, one of the things we can include is just the population of equipment to show the population of equipment that we expect this Tier 5 rule to impact. So I think that'll be part of future presentations. Although it is up online now, if you want to review that, if you go to CARB's impact website and click on the off-road categories.
What's next, Christian?
We have a new question from John Reich. Was any consideration or analysis given to adopting a load cycle and a standard to Tier 4 final engines? If so, how does inventory analysis compare to Tier 5 final emissions proposal?
I'm not sure if this question is actually for me. I did not do the analysis for load cycle. Oh, here's Yi. Let him answer that.
I can try to answer this question. We did a qualitative, we did actually look at the real world activity profiles, and we noticed that there are a lot of low load operations in the real world. And you can also, as mentioned by Julie's presentation, you can see there are a lot of low load operations for off-road equipment. So we don't have an exact number from the emission inventory to quantify the benefit. We do not have the inventory analysis results. But I think that's going to be part of the forthcoming workshops.
I just want to add that that's correct. We do not have any analysis from how any of these updates would affect the emissions inventory.
We have another question. Was part of the data and analysis done here partly used for CARB's justification for 3-bin moving average window and 2-bin moving versus 2-bin moving average window in the IUT program?
For this question, I just want to get a confirmation from the anonymous attendee. Does that mean the inventory presentation? If so, yes, we share some of the data with the inventory team for our analysis. And we use the real world activity data for our 3B more analysis as well.
Thank you, Yi. Still looking if there's any new inventory related questions.
Okay, well, since we don't see any, people can still drop them in the chat or in the Q&A if you have some, but why don't we move on to the beginning and start ticking off some of those outstanding questions from the top.
Okay.
So it's back to OBD.
Yeah, that's right. We got a comment or question, 1205. Based on the response to the previous questions on the 1.2 grams per kilowatt hour for OBM for the greater than 560 kilowatts.
Yeah, let me take a look at this question, Christian. Is that a question or a comment?
It might have been a follow-up question. There's a lot of discussion on this slide. You know, it might have been towards, is this for gensets or for mobile machinery?
Yeah, I don't know
it's
what
not clear from this particular line.
Yeah, the poster should clarify the question because it just it's not even a complete sentence.
Yeah, I probably was joined with during our OBD session, but for time reasons we got cut short.
You know, maybe I don't know if it's a continuation of the question. I guess it's not. I was thinking it might be a continuation of the one at 1211, but I don't think it is. Just have to drop the one at 1205 and hope that they retype it in.
Okay. The next question is, can CARB confirm mill lamp requirements are outside of phase one, even if the presence of manufactured diagnostics?
That is correct. We are not requiring any particular diagnostics per se for phase one. So the mill requirements don't come into phase two when we have diagnostic requirements.
Okay. Our next question, is the Tier 5 PM standard and OBD thresholds considered to be a carbon-based only or to consider DEF-derived based PM also?
Christian, I don't actually understand this question. If anyone does, please go ahead and clarify or answer. But maybe the poster can make this a little bit more clear.
Okay, we'll look if there's later for another question if it's clarified on this one. The next question is, if the embedded service tool is being considered, does CARB have plans to develop similar -84 or J1699-5 protocol for PVE1 testing?
Yeah, that's a good question. But we'll take one step back and first we would want, before we got to the point of developing a -84 type test for an embedded scan tool, we'd want to first get over another hurdle, kind of a first hurdle, which is to see if our equivalence criteria, the physical DLC equivalence criteria could be satisfied. Oh yeah, they're on the screen right now. So yeah, if we can reach that point where industry believes that these can be worked out and we can we have a clear path forward towards being able to support the embedded scan tool concept, then I think at that point we could start putting resources towards developing a test to ensure that it meets standardization requirements, like the -84, for example.
Thank you, Paul. We have a question from Eric Swenson. I trust the math for the 3 bins and the highway 2 bins will be forthcoming. Can't write message descriptions without them. Did you want to comment on this?
Yes. So actually, initially I had some hard time in understanding this question or the comment. But based on our understanding, I want to reiterate the method we use to classify windows into the 3 bins. Yesterday in our presentation, maybe I can share my screen. Okay. As we see in this one, we look at the window average engine load, and the window average engine load will be calculated by these 2 equations. Basically, you can calculate the 1 Hz engine output power for the 300-second window and get the engine load relative to the engine maximum power, and take an arithmetic mean for the window and get the value and compare to the engine load in the table and determine which bin this window belongs to. That's the method we are considering using. For the heavy-duty on-road, please refer to 40 CFR 1036 subpart F. I believe the section is 1036-530. There is a detailed description about how to use the 2B mod method for the on-road engines. And our 3B mod method for off-road will be similar as the on-road 2B mod, although we are not going to use the normalized CO2. We are using the normal the engine percent load for our 3B mod method.
The next question is related to OBD. In heavy-duty OBD, CARB/EPA allowed a 3-year phase-in for child ratings. What is the reasoning to only allow 1 year off-road? As reference, 2010 OBD had several year lead-in with EMD, but even 2010 was challenging that strained industry and companies' resources with only 6 heavy-duty on-highway companies. With off-road, you have 31 companies in 2023, and 70 of those already have experience in heavy-duty on-highway. That leaves 24 companies that will be straining the limited internal experienced OBD people and engineers. Please submit resumes, salary requirements now, and external consultant resources. Saying there's a generous lead time to 2033/34, there's still the 5 to 7 years to develop the technology to ensure compliance to the standards, and then another 3 to 5 years to do OBD design, validation, testing, and aging. I think Jason wanted to comment on that.
Yeah, I'm assuming that this commenter also commented yesterday because the question is similar, but with a little bit more detail, and that the commenter is very familiar with the heavy-duty OBD requirements because he or she keeps referring back to it. So, as some of you may well know, the heavy-duty OBD requirements are very comprehensive, and they have a lot more diagnostic and requirements than our off-road requirements. So it's like comparing apples to oranges. We can't do a direct comparison. I think it's unfair to pick on one aspect of heavy-duty OBD and say, hey, it did that, we should kind of do the same thing in off-road without like considering the other requirements, comprehensive requirements in the on-road proposal. Our off-road proposal has a lot less diagnostic requirements, lot less testing requirements, and it's more front-loaded towards standardization requirements, which doesn't require calibration. It just and has been done in the on-road sector for many years, and there hasn't been any new details from that. So it's just kind of front-loaded to standardization and doesn't require like a lot of resources to calibrate. There has been some we felt that standardization requirements for phase one should be matched with the Tier 5 implementation, because the emission standard implementation would require any hardware upgrades, and it would make sense to put that standardization requirements up front. And plus, our in-use compliance programs wanted that the standardization requirements to support their program. So since that was important to them, we had to design our proposal around their requests. So we couldn't match a lot of the implementation requirements allowances as heavy duty OBD. But as this slide shows, it's let me just point out some differences, because the poster mentioned what is the reasoning to only allow 1 year for off-road. And if you look at, I think they must be talking about the child ratings, but, and that's true that there is 1 year of what you call it, free deficiencies for the child ratings in the 2036 model year timeframe for the 130 to 560 power category. But if you look at the big allowance given for parents, it's far larger than what we do for heavy duty OBD. And you know, I just wanted to mention that in heavy duty OBD, there was a requirement to implement full-on heavy duty OBD for the parent engine rating, but like for the child rating, there was allowed to be extrapolated. So technically, the child rating started earlier, at least for that parent rating engine. Ours is totally different. We're kind of front loading it to the parent engine rating here. And then the child rating has a lot longer to implement. And so the parent rating is kind of like where we consider where manufacturers can learn from, learn how to implement, make their mistakes. And then when child engines come about, which I understand from talking with Jeff Lowry, that the child ratings make up the bulk of all engines. So that's like the big hitter right there for emissions. And if you look at that long allowance, I mean, that doesn't mean that you can't implement earlier if you want that like free deficiency allowance so you could learn. It's like if you look at the entirety, there is a lot of allowance in here. But it's you know, if there's like some specific concerns that you want us to consider, I requested the commenter contact us directly so we could better understand what issues are they're concerned about. Because if it's about child ratings, maybe we can adjust child ratings, or maybe we could have a third pathway where a manufacturer can implement heavy duty on-road OBD in its entirety, if that's what the posters would like. But like I would prefer not to have that option because it complicates our proposal. As I mentioned previously, I wanted to have as simple as a proposal as possible. But please feel free to contact us with your concerns.
Thanks, Jason. The next few questions are related to the MAR. So first one, will hybrid components also be subject to the MAR requirements?
Yeah, so for comprehensive component monitors that are associated with hybrid components and which can turn the mill on, the answer is yes. So they would also be tracking the data required by the monitor activity data.
Thank you, Paul. The next question. Let me see here. Maybe I had accidentally. The next question is, why did CARB remove special denominator requirements concept for Tier 5 OBD MAR?
Okay. I will try to answer this, and if I don't, but I welcome Paul Hendrick to also respond if he has anything more. But I think in Paul's presentation on standardization, he kind of mentioned this already. But with the MAD proposal, it's a much simpler concept than RUMPR. RUMPR is what has special denominators from heavy duty OBD or on-road OBD requirements. So we wanted to simplify MAD requirements to run just on specific operating conditions. And we haven't determined what those specific operating conditions are yet, but it's going to be some kind of arbitrary requirements that we think is, or arbitrary operating conditions that we would determine would make a good basis to compare monitoring results with. And it's not going to be the same as on-road, because on-road has some vehicle speed requirements, so we would have to think of something else. So really, we wanted to simplify things and just have it make a decision based upon that particular denominator, instead of having a different flavor denominator for each monitor. It could be hard to track. And as I mentioned, we wanted to simplify our proposal as much as we could. Paul, do you have anything more to add?
No, that's it. I just wanted to add that we understand that there are some monitors that will very naturally run much less frequently than others. So some monitors wait for very special circumstances, like a DPF regen event or something like that, and so they will have a much lower monitor activity ratio, for example, and so that we recognize that, and any thought going into having some type of minimum value that we want, sign of life type minimums, we'll take that into consideration.
Thank you. The next comment comes from Rakesh Malhotra. With reference to the conversation between George and Bill, it is incorrect to put the burden on engine manufacturer for items that are not in his control. Specifically, in this instance, where at the time of certification, the engine usage in all application is either not known or not completely defined by the machine builder. It is not fair for certification processes to be held up and the engine manufacturer held hostage for items that he does not control. Unfortunately, I don't think Bill is no longer online with us. So the next question then is, when we come to the emission threshold monitoring for OBD and OBMD, it is mentioned that the NRTC might be adopted for the test cycle. Are ARB staff going to consider, one, both cold and hot NRTC, and two, IRAF calculation for periodic regen scenarios?
Yeah, I can this question. And for the, as we mentioned in the presentation, actually OBD pathway and OBM pathway might be slightly different. We're just talking for the OBD pathways, and every time we mention the emission threshold monitors, we always apply the applicable emission test cycles, which it's not like we mentioned might be adopted. Actually, if the standard emission standard is talking about which kind of emission test cycles, you have to use that one. And if the emission cycles is using both of the cold and hot NRTs to calculate emission standard, you've got to follow exactly the same protocol. And RF will be included as well. So that's pretty much a standard like a current on-road OBD. But for the OBMD, actually, we have two different types of emission threshold monitors. One is the OBM NOx emission threshold. This is based on the we usually the 3 mode, being B and being C. So that's actually, you know, it's developed the moving average windows, which is already excludes the regeneration things. So that's where the RF application was not applied for that one for sure, because it's solely based on the being B and being C LLC and similar like an RTC cycle for the being C. But for other kind of monitors under the OBMD, or is the PM the monitor emission thresholds, where we still subject the same kind of requirement for emission thresholds, which is using applicable emission test cycles. Thank you.
Thank you, Young. Our next question is a follow-up to an earlier question at 208. On timing applicability to the greater than 50 kilowatt category, I think the question extends to all power categories greater than 130 kilowatts. The 3 years being proposed for TPEM does not cover the 4-year Tier 5 interim period. The 7 years in the federal program allowed some low volume to skip the Tier 4 interim so that the product only had to be redesigned for Tier 4 final. The differences in years being proposed by CARB for Tier 5 could require some products to not be available for the full Tier 5 interim period. The Tier 5 final engines might not be available and equipment testing completed to introduce Tier 5 final 1 year earlier than the regulation requires. I think Jeff wanted to comment on this.
Sorry about that. I didn't realize I was on mute. No, thank you, Christian. And person who wrote this comment, Anonymous, thank you for giving me the chance to come back after that the previous question. The intent, it's not really to bypass the Tier 5 interim for the equipment manufacturers. In a sense, if that was the intent, there'd be no point in having Tier 5 interim because everyone would just skip it and continue to use Tier 4 engines. That wasn't the point at all. Let me move things around on my screen. Okay, so the previous question you had asked is like, well, why did we skip 2033? And we didn't really. The intent was for the TPM program was to give 3 years for manufacturers greater than 560. So that, and it would start with the beginning of Tier 5 interim. So it'd be 2030, 2031, 2032. And after which point, the equipment manufacturer would be able to catch up with the engines that presumably had already been being produced to meet the Tier 5 interim requirements. So it's just giving the equipment manufacturer additional time to modify the equipment. Now, I understand your comment. You're saying, well, exempt us completely from the interim, so we only have to modify it once. You could potentially choose option 4 for that. Where you would only have to modify once, you'd have to do it a little bit earlier. But again, you potentially run into the same problem, not knowing what the operating conditions, the footprint is of the new engine. So again, that was the whole point of the TPEM. So we're offering 2 ways you can use it. You can use it at the beginning of Tier 5 interim. Okay, so in this case, hopefully you can see my screen, for greater than 560. It would start in 2030, go to 2032. Or you could wait and use it beginning in 2034, which I'm guessing most people will do. At least I think that's what most people will do. And then, in this case, you would have 3 years during which you could still bring in the previous tier engine. And that was the intent. It wasn't to bypass the entire Tier 5 interim period. And in terms of, missing 2033, it's just a characteristic of how it's laid out. You either start in 2030 for 3 years or you start in 2034 for 3 years. And the reason the other categories I don't think were affected was because for the smaller engines, at least, you had a longer period of time. So in that case, you probably could bypass Tier 5 interim completely if you're producing less than 130 kilowatt engines. Anyway, hopefully that answers the question.
Thank you, Jeff. Our next question is related to inducement. DEF consumption is also part of SCR inducement for heavy-duty on-road applications. Will ARB staff be considering this for Tier 5?
Yes, Christian, I take that by mentioning DEF consumption, if implied that the system monitors DEF level and usage to ensure that there is adequate amount of DEF for effective performance of SCR, the answer is yes. Yeah.
Great, thank you. Let's see here. Steve Berry has a question. I think this applies to perhaps the incentives and equipment flexibility, or maybe the miscellaneous amendments. Does Carbon 10 that Tier 5 applies to marine auxiliary engines? CARB's current version of Part 1039.5 states that all marine engines less than 37 kilowatts only have to meet Tier 2. The slide says they must meet Tier 5, though Jeff said, as we do today.
Yeah, thanks, Steve, for allowing me to clarify that. Auxiliary engines, they're treated in 2 different ways. If the engine is integral to the engine or the system, the exhaust system, the cooling, the fueling of the propulsion marine engine, then that auxiliary engine is only required to meet the same standards as the propulsion engine. However, if it doesn't share those characteristics, if it doesn't share exhaust and fueling and cooling, then it's a standalone auxiliary engine. Maybe something you bring on board to, power a refrigerator while you're boating, something along those lines. That engine would have to meet the land-based standards still. But if it's integral or if it's a propulsion engine, then it would only have to meet the propulsion engine standards, which we are proposing will be under the regulation of EPA in Tier 5. Thanks.
Thanks, Jeff. We have a comment related to inducement. It says, the final inducement is triggered once 2 of the following occur. Refueling, parked idle, engine restarted. How about the initial and severe inducement activation?
Yes, for final inducement, you need to meet 2 of those trigger points. But for initial and severe inducement, there is no triggers. You get prior warnings, but there is no no triggers point like the final inducement.
Thank you. Our next question is, taking DEF quality as an example, one after a warning activation, the severe inducement shall be activated. If the monitor concept relies on the after run process of ECU and the equipment is running for more than 1 hour, would this still be compliant?
Yeah, Bradley's going to take that.
Yeah, you guys can hear me.
Yeah.
Okay, I'm gonna assume I know what this means, and if I get it wrong, the person asking the question can restate it. So as far as the deactivation for final inducement, you're not actually gonna be induced until you reach the safe harbor conditions. Some of those triggers Massimo was just talking about, right? So after 1 hour after the warning, you'll reach a state in which it can be induced to the final inducement, but that won't actually happen until you're in safe harbor. Now, if what you're saying is the monitor that's going to detect whether the inducing condition has been corrected in order to turn off the inducement requires a key cycle or an after run of the ECU in order for that monitor to run, then that would be a design consideration, but I don't think you would fall afoul of the final inducement requirements as long as it is inducing within an hour or meeting the safe harbor conditions after that hour has expired. So that's how I understood that question. If I got some part of that wrong, or if you need some further clarification, feel free to re-ask the question.
Thank you, Bradley. Our next question, will the warning/inducement activation of tampering follow the same requirement? For example, DEF quality tampering? Example, 1 hour after warning activation for severe and 4 hours after warning activation for final inducement?
Yes, the DEF quality and tampering are following the same strategies. That's correct.
Thank you. Our next question is from Yanbin Mo. For the greater than 560 kilowatts, how about TPEM for option 4? Tier 4B from 2032 to 2034, question mark? I think Jeff would like to respond.
Yeah, thank you, Christian. I'll take this, although I'm not completely sure what's being asked. Would TPEM allowances still be allowed for option 4? Let me pull that slide up. The answer is yes, but let's see. Hopefully I still have that open. So for greater than 560, get to the right one. Okay, so option 4, we say that the allowance would begin in 2030. Yeah, if a manufacturer wants to use it, if they claim option 4, I mean, there's really no reason for them to use it in 2030 because they already have a tier 4 final. I mean, technically it would be allowed, but again, no reason to use it. The smarter move would be to use it beginning in 2032, or excuse me, in this case, in 2034. But they could begin using it during the tier 5 frame in 2030, because that's when we said that the allowance would begin. So, I mean, this is something we can discuss further. If other implementation or iteration makes sense, we can certainly consider that. So thank you for the question.
Thanks, Jeff. The next question is related to OBD. Will DEF consumption be deviation monitoring Will DEF consumption deviation monitoring be implemented on tier 5 OBD for 50% or below?
So let's see. So the question relates to DEF consumption. So I'm assuming this is going to be an SCR equipped engine. So it's going to fall under the OBMD requirements. And we don't have any DEF delivery performance monitoring requirements for those engines. There will be comprehensive component monitoring on sensors that are involved, but there's no like reductant delivery performance requirements.
Thank you, Paul. I'm currently not seeing any new question. Oh, we have one question. CARB's move to OBM was to lessen the cert burden to non-road manufacturers that may be driven by OBD. If a manufacturer supplies both SCR and non-SCR equipment, did CARB consider that the overall burden on the manufacturer may in fact be increased and not reduced to manage both systems? What is CARB's perspective here?
Okay, I can try to answer that question. It's a good question. We didn't realize there would be an additional burden to manage both, but I can foresee perhaps there might be additional workload on that. We'll have to consider this comment and bring it back with us and discuss maybe that aspect. And if the commenter could contact us with specific concerns about increased burden, we could consider it. It's a good question.
Yeah, I would like to add a little bit for these questions. I think, I think the post asked this is because maybe the manufacturer is holding both SCR and non-SCR, which is subject to two different kind of pathways. But maybe you missed one point in our presentation. Even for the OBD pathways, actually the diagnostic is kind of, it's not totally like overlapped with the SCR, which is OBMD diagnostic requirements. Because you don't have the SCR system, you only require the third we have listed here, EGR, which is the electronic field control system, and the DOC, and a variety CCM monitor here. So I personally think there was no overburden for that part, because SCR definitely you have way more different kind of the diagnostic need to be carried. And so in general, I think it's still a good question, but I just mean for this kind of part, maybe the people wanted to think about it in that respect.
Yeah, if the poster can specify their concerns to us as far as increasing burden if for these two pathways simultaneously, just let us know. Young had some good points. I don't really can't really comprehend the added burden because some of the requirements are they're kind of similar for the most part. The standardization parts, there's some different diagnostic requirements, but and OBM is of course different. But it doesn't seem like it would be a huge burden, but maybe we're not seeing something. So please feel free to contact us with your concerns, with your specific concerns, so that we can better understand it.
Thanks, Jason and Young. Our next question looks like it's related to inducement. Warning/inducement activation has anything to do with failure statuses, example, pending and confirmed? Question mark.
So Christian, I'm going to take a stab on this, but Paul or Brad, if they want to chime in, if the failure status is kind of, they can distinguish between these as like a tampering or component wear and tear, that's a different aspect of that. But if there is no way to find out if this failure causing by tampering or component failure, the system should go to inducement for any of those reasons with the sensor or system who are monitoring the SCR systems.
Yeah, I think like in this question, the individuals using the words pending and confirmed kind of brings OBD to mind, but OBD fault codes and fault code handling is kind of a separate area from SCR inducement logic. So we don't mix them.
Yeah, let me kind of expand on Paul's comment. I'm thinking the poster of this question is kind of thinking that the inducements are tied to OBD monitors. As Paul mentioned, they are not. We don't have any inducement requirements. I think the inducement monitoring, the monitors for inducement are outside of OBD, and I'm not too sure they use the same wording like pending and confirmed. Those are OBD terms. Inducement is separate, so it's outside of OBD requirements.
Thanks, Paul. Thanks, Jason. I don't see currently any new questions.
Oh, I knew that anonymous attendee had more questions.
Sure. So this one. So as long as failure detected, the warning inducement activated, no need to double check the second time?
I guess as Jason mentioned, I guess this is mixed up with the OBD and SCR inducement, and SCR inducement is working on their own. So if you have to make your system or implement your system, so you detect the fault and act based on that. So as soon as you detect the non-compliance, you should the system should do the stage inducement, like warning, initial inducement, severe inducement, and final inducement based on the predefined timeframes. That's my answer to that.
Thank you, Muslim.
Yeah.
We have a comment. Thank you for this 2-day session from Canada. Really interesting for the upcoming Tier 5.
All right, and I just wanted to say some quick closing remarks, because I'm sure everybody's very tired, but appreciate the over 128 folks that are still on the line and have been really engaged in the process. As we stated yesterday, Tier 5 will go to the board in June 2025. In the meantime, please send us your comments on the proposal for the materials that we presented on yesterday and today. And in the meantime, you can also, if you need to, send us other questions or would like to meet with us, of course, we can do that as well. And we'll be working on our cost analysis, looking at cost benefits, as well as the inventory folks will be looking at their stuff on the NOx benefits and other criteria pollutant benefits and writing reg language. And So, and the initial statement of reasons. So that's kind of what we'll be doing in the next 12 months or so.
Pardon me. Oh, we do have a hand raised, and so maybe one more question from the audience, from Steve Berry. Steve, I'm going to ask you to unmute.
Not a question. I just wanted to say thanks to the CARB staff for all the time you spent the last couple of days, and of course, much more time spent preparing all these comprehensive materials. It's really appreciated, and Christian, kudos to you for your stamina hanging in there as MC for 2 days like this. You did a great job. Appreciate that staff took the time to address all of our questions in detail, and being one of the more often question askers, I offer my thanks, and of course the thanks of the association's members. One of the more prominent new items in the proposal that we hadn't seen before are the Tier 4 and Tier 5 interim standards. Greatly appreciate your attention to the objective and the interest to avoid the market disruption, recognizing the low volumes in California, diversity of the non-road sector, and all of that. We'll come back to you with our thoughts on that approach, and maybe we'll have some alternatives. Maybe we'll love it, but we'll be sure to let you know, of course. The one program element that certainly has struck me and a few of the others is the in-use test program and the burden associated with that. And I tried to illustrate that in my example for families greater than 37 kilowatts reporting through 75% of their useful life. That's 11 years into the 15-year useful life. These engine families will start stacking up. And once the program's fully mature, that's 440 engine families per year for which data will be submitted. And it will only take just over 2% of those engine families to fail the clean family flag in order to trigger the maximum 10 PEMS test orders per year for that manufacturer that's averaging 40 families certified each year, which is very common. So that strikes me as hugely worrisome, but we appreciate CARB's openness as always to hear us out, and we'll look forward to working with you on that and everything else shared today. But once again, thanks very, very much for very good materials and for your time with us today.
You're welcome, Stephen. I think you mentioned your question on the off-road and use testing burden for greater than 37. Did I hear you greater than 37 kilowatt?
Yes.
I think you'd use that because there isn't. We're not requiring the screening data to be reported for greater than 37. It's greater than 56 kilowatt to 560.
Thank you. And the greater than 37 were all the families with 15 years useful life. But you're right to restrict it to 56 to 560.
I just wanted to correct that for the record.
Good. Thank you, Jenna.
Yep. Okay, and there's a question, will the Q&A be posted on the website? No, the Q&A will not. What we will post is the recording from today and from yesterday, so you can go through that. All right. Well, thanks again. Really appreciate it. Really appreciate the great interaction, and we'll see you soon.
Thanks, Jenna. Take care, everyone.
And thanks to everyone for watching, particularly the person that thanked us from Germany.
Midnight there, isn't it? Wow.
I know, that's impressive. Okay, take care, folks. Happy Halloween.
Bye-bye.
Thank you. Bye-bye.
Bye.